Hey guys, in this video I'm going to teach you everything you need to know to get started writing code in JavaScript. So sit back, relax, and enjoy the show. If you wouldn't mind, please leave a like, comment, and subscribe. One like equals one prayer for the YouTube algorithm. Alright, let's get started everybody. What the heck is JavaScript? JavaScript is a web-based interpreted programming language that's used to add interactive behavior to web pages, build web and mobile applications, to create command line tools, and for game development. I like games. Here are some important notes before we get started. JavaScript is not the same as Java, even though they share the same name. Both languages were developed around the same time. Now, knowing HTML and CSS is helpful, but not necessary, at least until we near the end of this series, where we begin working extensively with the DOM, the document object model. Hey, if you're interested, I do have a 1-hour full course on both of those subjects. What you'll need a web browser and a text editor. You'll need a web browser, well, because JavaScript runs in a web browser. I recommend using the latest version of Chrome, Firefox, Safari, Opera, whatever. Please do not use Internet Explorer. I also recommend a text editor. A few popular text editors include, but are not limited to, Visual Studio Code, Sublime Text, Replit, which is an online text editor, or Notepad if you want to torture yourself. In this series, I'll be using Google Chrome as my web browser and Visual Studio Code for my text editor. If you would like to download Visual Studio Code, I'll show you how. To download Visual Studio Code, head to this URL, code.visualstudio.com. Look for this blue drop-down menu, then download the latest stable version for your operating system. I'm running Windows, I will install this for Windows. Then your download should start automatically. If it doesn't, you can hit this big blue button. Then I'm just going to go ahead and open this. Accept the license agreement. Yes, I actually did read it that fast. If you would like, you can create a desktop icon. Next, install. We might as well go ahead and launch VS Code now. Within VS Code, the first thing I recommend doing is downloading the live server extension. Let's go over to the left navigation bar, go to extensions, then look up live server. Then we're going to click on this. Let's pretend that this wasn't already installed. Then click install. What live server does is that every time that you save your JavaScript file, it will update your current web browser right away to reflect any changes. It's a helpful development tool. We're going to create a new folder to hold all of our files. I'm going to go to Open Folder. I'm going to create a new folder on my desktop. I'm going to right-click, go to New, Folder. I'll name this Website. Click Website, select Folder. There we go. Now let's create a new JavaScript file. Go to New File. I'll name this file index.js. Be sure to get that extension, JS, because, well, that's a JavaScript file. I'm also going to create an HTML file, index.html. On a website, this would be the landing page. Then a CSS style sheet, which I will name style.css. Okay, we have our three files, index.javascript file, our index.html file, then our CSS style sheet. We'll need HTML skeleton code to work with. So within your HTML file, if you type ! then hit tab, that will generate some sample text to be used to create a web page. We'll want to take care of this early. Let's link our CSS style sheet. Within the head tags of my HTML document, I'm going to create a link tag. Link, take the rel attribute, set this equal to style sheet. The next attribute is href. Set this equal to your CSS style sheet, style.css. So our style sheet is now linked to our HTML file. Then we need to link our JavaScript file to our HTML file. Within the body of my HTML document, I'm going to create a pair of script tags. Script, that's the opening tag, then / script to close it. Within the opening script tag, I will set the source attribute equal to the name of my JavaScript file. Mine is index.js. Then be sure to save everything. To save myself from potential future headaches, I tend to save all 3 files. To display output from our JavaScript file, we'll need to open up a web browser. An easy way to do that would be to go to Explore, right-click on your HTML file, open with Live Server. I now have this window to work with. This window is a representation of my HTML file. When coding with JavaScript, I like to place my browser window and VS Code right next to each other, kind of like this. To access our console, which we can use to display output, I'm going to right-click within my window, go to Inspect, click on these arrows, then go to Console, and then just save. Any output within my JavaScript file will go to my console. To display some output, we can type console.log, then a set of parentheses. Typically with programming, you end a statement with a semicolon. It's like the punctuation at the end of a sentence. It's optional to add a semicolon to the end of a statement, but in nearly all programming languages besides Python, to end a statement, you need a semicolon. I type it in just as a force of habit, but it would still work regardless. Now let's type something. Let's type some output to the console window. This can be either within single quotes or double quotes. Let's say something. I like some food you like. Pizza. I do have that live server extension set up. When I save, that will update my web browser. Within my console, we have this statement that I made. I like pizza. If I would like to print another statement, I can again type console.log. Then within either single quotes or double quotes, I can say something else. It's really good. I like pizza. It's really good. You can also create an alert box by typing window.alert within the parentheses, within a set of quotes. What would we like to say? I really love pizza. Alert will create a pop-up. I really love pizza. There's also comments. To create a comment, you use 2 forward slashes. Comments are ignored by the interpreter. This is a comment. Usually comments are used for notes for yourself or for other developers. You could also write a multi-line comment by typing ***. Wherever you would like your comment to end, you would type */ again. This is a multi-line comment. All right, everybody, that is a quick introduction to JavaScript. And in the next topic, we'll discuss variables. All right, everybody, that's a quick introduction to JavaScript. Hey, if you enjoyed this video, let me know by smashing that like button, leave a random comment down below, and subscribe if you'd like to become a fellow bro. All right, everybody, variables. So a variable is a container for storing data. It's a representation of some value. Think back to middle school algebra class where you had to solve an equation. You have to solve for x, and x is some representation of a value. It's basically no different in programming. A variable behaves as if it was the value that it contains. There's 2 steps to creating a variable: declaration and assignment. To declare a variable, we use one of 3 keywords, either var, let, or const. We'll discuss const in a future video, but for now, we can either use var or let. But using let is best practice due to something called variable scope, but that won't make too much sense until we reach the video on functions. So for now, for best practice, to create a variable, let's use the keyword let. We precede the variable with let. And now we need a unique descriptive name of this variable. So if you're thinking of algebra, you might think of a variable such as maybe x or y, like they are some number. But in programming, you want a variable to be descriptive of what it contains. Let's assign a number to this variable. Maybe in this example, we need to store a student's age. So age would be a descriptive name for this variable. And that is step 1. We have declared a unique variable named age, but it doesn't yet contain a value. That's where assignment comes in. That's step 2. So let's try and use this variable. Console.log, and I'm just going to display age, and then let's see what happens. If you declare a variable but do not assign it a value, it's undefined. So we haven't reached step 2 yet. We've only declared a variable. When you display a variable, make sure it's not within quotes, because then we're literally printing the word age instead of the value contained within age, the variable. Now, step 2 is assignment. We take the variable name and use the assignment operator, which is an equal sign, and set this equal to some value. Let's say that I'm 21 years old. Not anymore, but I like to think that I still am. Now, when I display this variable age, it displays the number 21. So age is a variable. It behaves as if it was the value that it contains. Now, with creating a variable, you can do this in 2 steps, or you can combine them both together. So instead of taking 2 lines of code, we could combine them both together like this. And this would do the same thing. But there may be times when you need to declare a variable and then assign a value later on, like maybe you're accepting some user input. So in that case, it would be better to do that in 2 steps. Different variables have different data types. 21 is a number data type. We can use this variable in some arithmetic expressions. Maybe it's my birthday and I need to add 1 to my age. I can easily change that by setting age equal to age plus 1. And my age is now 22. So this is a number data type. Another data type is a string. A string is a series of characters. Let's create a variable to hold a student's name. So we will use that let keyword, and I'll create a variable name named first name. Then I could assign a value later or right away. I'll do so right away. So I will set first name equal to, then to create a string, we can use a set of quotes, either double quotes or single quotes, and I can add a series of characters. So why don't you enter in your first name? And now I can use this variable and it contains a series of characters. Let's display this within our console. Console.log first name. So this displays bro 21. Another data type is a Boolean. A Boolean is only one of 2 values, true or false. This time, let's say that we have a Boolean variable named maybe student. If a person is currently enrolled, we could set student to equal true. If they're not enrolled, or maybe they graduated, this could be false. So a Boolean is one of 2 values, true or false. Then let's display this within our console. Console.log student. And this displays false. Or if I was a student, this could be true. So these are 3 common data types: strings, which are a series of characters, numbers, and Booleans. As a beginner, it's actually really easy to mix up strings and numbers. Numbers we can use with arithmetic expressions. Strings we cannot. Let's use that previous example of incrementing my age by 1 because it's my birthday. Age equals age plus 1. We can use numbers in arithmetic expressions. See, my age is now 22. But if this was a string, I'll put this within quotes, string, well, when we add 1 to age, it's going to concatenate 1 to the end of the string. I am not 211 years old. It's treating age as a series of characters, and we're adding an additional character to age. So as a beginner, you really have to pay attention to data types. It is really easy to put things within quotes when you don't mean to. When you display a variable within the console or the DOM, you can display it along with some other text. So along with my first name, I'm going to display hello. Hello. Then after I finish the string, I will add comma. So hello, bro. With my second log method, I'll print another message. Perhaps you are age years old. Hello, bro, you are 21 years old. And what can we do with student? Let's say maybe enrolled. So this will display true if I'm currently enrolled, or false if I'm no longer a student. If you need to display a variable within your DOM, here's one thing that we can do. So within our HTML document, let's create maybe some paragraph tags. I'll create 3. So we need an opening paragraph tag and a closing paragraph tag. I will set a unique ID of P1. Copy this, paste it 2 times. The second one will be P2, and the third will be P3. So within our DOM, we have 3 paragraph tags, each with a unique ID. If I need to change the inner HTML of these paragraph tags, I can do so using this statement. Document.get element by ID, parentheses, and then within a set of quotes, I will list the ID of the HTML tag I would like to change. Let's begin with P1, and then I will follow the statement with .inner HTML and set this equal to. So let's display hello. Then to display a variable, we will use some string concatenation. So we will use plus a variable name. Let's say first name. Hello, bro. Okay, let's do the same thing with P2. You are. So when using string concatenation, you do have to pay attention to spaces within strings. You are age plus years old. You are 21 years old. And lastly, P3. Let's say enrolled, colon space, student. Enrolled, true. And then you can change any one of these values. Well, yeah, everybody, those are variables. A variable is just a container for storing data. It's a representation of some value. A variable behaves as if it was the value that it contains. There's two steps, declaration and assignment. You can do these both together or separate. And variables have different data types. Three that we discussed are strings, which are a series of characters, numbers, and booleans, which are either true or false. You can display variables along with text within your console, or you could use string concatenation to display a variable's value along with some text in your DOM. So yeah, those are variables, everybody. If you would like a copy of all this code, I'll post this in the comments section down below. If you enjoyed this video, let me know by smashing that like button, leave a random comment down below, and subscribe if you'd like to become a fellow bro. Hey everybody, I have a super quick video on arithmetic expressions. An arithmetic expression is a combination of operands and operators. Operands are values, variables, etc. Operators are, well, the addition sign, subtraction, multiplication, division, and modulus, which we'll talk about a little bit later. An arithmetic expression can be evaluated to a value. For example, y equals x plus 5. X and 5 would be operands, and the addition sign would be the operator. Just really quick, let's cover a few. Maybe we have a variable named students. We're a teacher and we have a whole class of students to keep track of. I need to add one student. I could take our students variable and set this equal to, if I need to increment students by 1, I can set this equal to students, currently it's 20, plus 1. And then let's display this. Console.log students. And this should be 21. So we also have subtraction. Students equals students minus 1. And now we have 19. For multiplication, you use an asterisk. Maybe we're combining two classes. Students equals students times 2. And now there's 40 students. Perhaps we're dividing a class in half. Students divided by 2, and you use a /. And now there's 10. Now this one's a little bit strange. We will discuss modulus. The modulus operator is a percent sign. It gives you the remainder of any division. We have a class of 20 students, and we need to divide this class into groups of 3. But 20 doesn't divide by 3 evenly. I can store the remainder within a separate variable. I'll create a new variable called extra students. And we will take students modulus 3. And let's display the extra students that we have. So we have 2 extra students. But if this was 21, well, 21 divides by 3 evenly, so the remainder is 0. We have 0 extra students. So that is the modulus operator. One popular use of the modulus operator is that you can find if a number is even or odd by taking a value or variable modulus 2. If extra students is 1, that means we have an odd number. If it's 0, that means we have an even number. So that is the modulus operator. It can be somewhat tedious to write these long expressions out, so there is a shortcut. Instead of saying students equals students plus 1, you could just write students plus equals 1. This is also known as an augmented assignment operator. It's kind of like a shortcut. So students is now 21. Then we have students minus equals 1. Students is 19. Students times equals 2. There are 40 students now. Students divide equals 2. And there are 10 students. With augmented assignment operators, you can use these if you're reassigning the same variable. Like I couldn't say let extra students modulus equals 3, right? And then if we were to display this, we would have a syntax error. So augmented assignment operators are kind of like a shortcut you can do. if you're reassigning the same variable. Another thing to consider with arithmetic expressions is that there's operator precedence. Maybe we have this equation. Let result equals 1 plus 2 times 3 plus 4. And then I'm just going to display whatever the result is. So the result is 15. The order in which you solve this is that you begin at the left and work your way towards the right. You solve anything within parentheses first, then exponents, then multiplication and division, then lastly addition and subtraction. Starting on the left and working our way towards the right, we would solve anything with parentheses first. 3 plus 4 is 7. Then we solve any exponents. There aren't any. Multiplication and division. We can either resolve 1 plus 2 or 2 times 7. So multiplication has precedence over addition. We would solve this first. Then it's just 1 plus 14, which is 15. Now, by adding a set of parentheses, you can force operator precedence. This time, I would like to resolve 1 plus 2 first. And now we have a new result. The result is 21. So yeah, that's a super quick video on arithmetic expressions. It's a little dull, but it's kind of necessary to cover. Hey, if this video helped you out, help me out by smashing that like button, leave a random comment down below, and subscribe if you'd like to become a fellow bro. Hey everyone, in this video I'm going to show you how we can accept some user input in JavaScript. I'll demonstrate two ways, the easy way with a simple window prompt, and the difficult way with an HTML text box. Let's begin with the easy way. I'm going to create a variable named username, and the user will type in a name for themselves. Let username equals, and to create a window prompt, we type window.prompt, parentheses, and within the parentheses, we can add a message. What's your name? After a user types in some user input, we will assign whatever they type into a variable. So I'm going to display this. Console.log user name. What's your name? Type in your name, press OK, and this will display the value that you typed in. The difficult way, although it's more practical, is to use some HTML elements. Within our HTML file, let's create a prompt, a label. Enter your name. And then maybe I'll add a line break and an input box. Input. This is a self-closing tag. A line break. With my input tag, let's set the type equal to text. It's a text box. And I'll give this an ID of my text. Okay, so save, we have our label and a text box. Let's create a submit button. We'll need a pair of button tags. Type will be button, and the ID will be my button. You can add some text to the button. Between the button tags, just write something. Submit. Okay, make sure to save your HTML document, then we'll head back to our JavaScript file. What I'm about to show you is a little advanced, but you can always just copy this and save it for the future. After clicking our submit button, whatever text is within our text box, we'll assign it to a variable. We'll type document.getElement by ID. Then type my button. Follow this with dot on click, and we will set this equal to function parentheses, then a set of curly braces. At the top of my program, I'm going to declare my variable but not yet assign it. And within my function, the set of parentheses, I will take username and set this equal to document.getElement by ID, parentheses, then within quotes, my text. That's the ID of the text box. Dot value. So when we click on this button, take whatever text is within our text box and assign it to username. Then afterwards, let's display whatever our username is within our console. Or if you want, we can change maybe this label. Console.log username. Type in your first and last name, press submit, and this will display your name. Let's change this label, but I'm going to give this label a unique ID. ID equals my label. So save, go back to your JavaScript file. I'm going to edit the inner HTML of this label. Document.getElement by ID, my label dot inner HTML, set this equal to user name. Okay, so again, type in your first and last name, press submit, and this should change that label. Maybe I'll add hello plus username this time. Hello, bro code. So yeah, those are two different ways to accept user input. You can go the easy way with a simple window prompt, or you can take the difficult approach with an HTML text box, although it's more practical. But it's above our current level of understanding at this point in time. So yeah, those are two ways to accept user input in JavaScript. If this video helped you out, you can help me out by smashing that like button, leave a random comment down below, and subscribe if you'd like to become a fellow bro. Hey guys, in this video I'm going to explain type conversion. Type conversion is the ability to change the data type of a value to another. And I'll explain how to do this with strings, numbers, and booleans. Here's one issue when accepting some user input. Let's say we have variable age, and I'll create a window prompt to ask a user to enter in their age. How old are you? Once we accept some user input, I'm going to increment age by 1 because let's say it's the user's birthday. Then let's display the user's age. Console.log happy birthday. You are our age variable, years old. How old are you? Let's say that I'm 21. I press OK. Happy birthday, you are 211 years old. When we accept user input, it's of a string data type. We can't normally use strings for any sort of arithmetic expressions. What I intended was to add our age 21 plus 1. That would give me 22. If you add a number to a string, you just concatenate that number to the end of the string, because a string is just a series of characters. If I need to take some user input and use it with some sort of arithmetic expression, I'll want to convert that string to a number, and one way I can do that is to use the number constructor. So I'm going to set age equal to, then type number, make sure it's capital, parentheses, and then pass in age. This will convert a string to a number. How old are you? 21. Press OK. Happy birthday. You are now 22 years old. If you ever need to get the data type of a variable, there is a type of keyword. Let's display it. Type of age. So before we convert our age variable, it's a string. Then let's display the data type of age after we convert it. At first, it's a string, we convert it, and now it's a number. And then we can use it in arithmetic expressions. Here's a few other examples. We have 3 variables, x, y, and z. I'm going to set x to equal, and we will use the number constructor, and we will convert the string 3.14 into a number. And then I will display whatever x is, as well as the data type, type of x. Remember, we're converting a string into a number. So 3.14 is now a number. Let's convert a number into a string. Y equals, and we can use the string constructor, and we will convert the number 3.14 into a string, console.log, y, and type of y. 3.14 is now a string. And to convert something to a boolean, you can use the boolean constructor. So if you pass in an empty string, just a set of quotes, this will give you false. Console.log, variable z, and the type of z. So converting an empty string to a boolean will result in false. And this is of the boolean data type. But if you type in anything else, it will give you true. So maybe I try and convert the word pizza. When you convert a string to a boolean that's not empty, this will give you true. If it's an empty string, just a set of quotes, it results in false. This would be useful if you need to accept some user input or a user types in their name. If they skip that step, and using an if statement, which we'll talk about later, you can check to see if a user typed in something or not, based on if that boolean is true or false. But we'll get into that later. So yeah, those are a few basic ways of type conversion. You can change the data type of one value to another. If you need to get the data type of a variable, just precede that variable with the type of keyword. And to convert a value or variable into another data type, you can surround that value or variable with a given constructor, the number constructor, the string constructor, or the boolean constructor. Oh, one fun fact too, if you try and convert something into a number that normally shouldn't be a number, like the word pizza, well then this will result in NaN, not a number. That's just a fun fact. So yeah, that is type conversion in JavaScript. If this video helped you out, you can help me out by smashing that like button, leave a random comment down below, and subscribe if you'd like to become a fellow bro. Hey everybody, in this video I'm going to explain constants. A constant is a variable that can't be changed. It adds some security to our code. To declare a constant, you use the const keyword in place of var or let. In this example, we're going to create a sample program to calculate the circumference of a circle, which has this formula. Circumference equals 2 times pi times radius. Let's declare all of the variables that we'll need. We're going to write this program without constants and then later with constants, and I can show you their usefulness. We'll create 3 variables. Let pi equal 3.14159, just the first few digits of pi. Let radius and let circumference. We're going to accept some user input. We will assign radius equal to window dot prompt, enter the radius of a circle. Then when we accept user input, it's a string, we'll need to convert that to a number. Radius equals, and use some type conversion and convert our radius into a number. To calculate the circumference of a circle, we will set circumference equal to, and follow that formula, 2 times pi times radius. And with the radius, the user will type that in. At the end of our program, we will display our result. The circumference is circumference. Let's run this. Enter the radius of a circle. If the radius is 9, I press OK. The circumference is 56.54. Now here's why constants are useful. Let's say that somebody changes our code. Pi now equals 420.69. Now when we run this program and we type in 9 for the radius, well, the circumference is now 7,572. We can prevent a variable from being changed if we assign it as a constant. In place of let, use the const keyword, and our variable pi is now a constant. And a common naming convention for constants is that you make all of the letters uppercase. It's not necessary, but it's good practice. Then we are going to change that here too. Enter the radius of a circle. I'll type 9, the same as before. And we encountered a type error, assignment to constant variable. So once we declare a constant, we can't change it. So if I were to get rid of this line, run this again, 9, the circumference is 56.54. You'll want to use constants as often as possible if you have a variable that you know will not be changed later. We're not going to assign radius and circumference as constants because we'll need to update them later in our program. So yeah, those are constants. It's basically just a variable that can't be changed. It adds a little bit of data security. If you found this video helpful, you can help me out by smashing that like button, leave a random comment down below, and subscribe if you'd like to become a fellow bro. Alright everybody, let's talk about JavaScript math. Math is an intrinsic object that provides basic mathematics functionality and constants. There's a lot of functions I think that you would find useful. In this example, we have a variable x, and x equals 3.14. Feel free to choose any number that you want. Maybe I need to round this variable. Well, there's a built-in function of math that can do that for us. I could just type x equals, then type math dot, and then I have access to a bunch of different functions. I would like to round x, so add a set of parentheses and pass in a value or a variable that you would like to round. And then if I was to display the value of x with console.log, this would display my value or variable rounded, whatever's within the set of parentheses of this function, and x rounded is 3. Let's cover a few more. The floor function will always round a number down. If this variable was 3.99, the floor function will always round down. X is still 3. If you need to round up, there is the ceiling function, which is shortened to CEIL. If x is 3.14, ceil will round up. X is now 4. You can raise a value to a given power. X equals math.pow. In the parentheses, you'll give a base and an exponent, each is separated with a comma. X to the power of 2 is 9.8. X to the power of 3 is 30.9. Their square root, x equals math dot square root, SQRT for short. The square root of x is 1.77. To find an absolute value, you can use the absolute value function, x equals math dot abs. The absolute value is the distance away from 0. If x was negative 3.14, the distance away from 0 would result in a positive number, positive 3.14. This time we have a couple variables and we need to find the maximum and the minimum. We'll create two more variables. Let y equal, I don't know, what about 5? Let z equal 9. I'll declare a maximum and a minimum. Let maximum, let minimum. I will assign maximum equal to math.max function and pass in x, y, and z. This will return the maximum and assign it. So the maximum between x, y, and z is 9. Then there's also minimum. So minimum equals math.min. The minimum between x, y, and z is x, 3.14. There's also some built-in constants too. With x I assigned 3.14. I would like to assign pi with more digits. Well, there is a built-in constant of math. X equals math.pi. And when I display x, x is 3.141592653589793. So math is an intrinsic object that provides basic mathematics functionality and constants. There's a lot more functions and constants than what we covered, but here's a few of the basics. So yeah, that is JavaScript math. If you found this video helpful, you can help me out by smashing that like button, leave a random comment down below, and subscribe if you'd like to become a fellow bro. Hey, welcome back everybody. In this video, we're going to create a practice program to find the hypotenuse of a right-angled triangle. And the formula to solve that is c equals the square root of a squared plus b squared. We'll create two variations of this program. First, we'll accept some user input via some prompts. Then later on, we'll adjust this program and accept some user input through some HTML text boxes. Let's begin. Let's declare three variables, each for side A, B, and C. Let A, let B, and let C. We'll accept some user input for sides A and B. A equals window.prompt, and the prompt will be enter side A. When we accept user input, it's a string. We'll need to convert that to a number. A equals number, pass in A. Let's do the same thing for side B. Let's copy and paste what we have, but change A to B. And the formula to calculate the hypotenuse goes a little something like this. C equals, we'll need to square sides A and B and add them together. We can use JavaScript math dot power function, A to the power of 2, plus, copy this, paste it, B to the power of 2. Then we need to square all of this, and that equals C. So in the next step, we could set C equal to math.square root and pass in C. If you would like to do this in less steps, you could copy all of this, cut this line, and paste what we just copied. So this would only take one line of code. Then at the end, we will display side C. Side C, C. Okay, let's run this. Enter side A. A is 3, B is 4, side C equals 5. Okay, now let's make a more advanced version of this program. We'll accept some user input via some HTML text boxes. So let's head to our HTML file and add a couple elements. We'll create three labels. Label, the first will have an ID equal to maybe a label. Then close this tag and I'll add a line break. Then I'll copy this, paste it. We'll have a B label and a C label. I'll change the text to side A, colon, side B, and side C. Okay, and this is what we have so far. I'll add two text boxes right underneath A and B, and then a button later. We'll create a self-closing input tag. Then I'll add a line break at the end before I forget. Set the type equal to text because it's a text box. And I will give this a unique ID of a text box. Okay, let's copy this. Then underneath B label and give this text box an ID of B text box. Okay, this is what we have so far. Then I'll create a button underneath this second text box. So right here. So we'll create a pair of button tags and a line break. I'll set the type equal to button and an ID of what about submit button. Then I should probably add some text. So between the button tags, submit. So let's save. Then heading back to our JavaScript file, this is what we have to type. This will be a little bit advanced for us because we haven't discussed functions yet. When we click on this button, we need to do something. To select this button, we will type document.getElement by ID. Within the parentheses, we will list a unique ID. I would like the ID of my submit button. Then follow this with .onClick. When we click on this button, we would like to do something. We would like to perform a function. Function, parentheses, curly braces. Within the curly braces, we will execute some code. And actually, we can copy a lot of what we have here. So let's copy our previous code and paste it. But we need to change a couple things around. We would not like window prompts. So let's change this line to A equals document.getElement by ID. And I would like to get the value of this text box, which has a unique ID of a text box. Follow this with .value. We're taking the value of this text box and assigning it to variable A. When we accept user input, it's normally a string. We're going to convert it to a number. Let's do the same thing with B. So copy that line, paste it, change A to B here and here as well. Then convert it to a number. We can keep this line of code. The logic is still the same. And lastly, we can update this label. I'm going to change this around real quick. I don't want to display anything, but we'll still keep the label. I'm going to change the inner HTML of this label, C label. Document.getElement by ID. We are selecting C label, and I'm going to change the inner HTML and set this equal to side C :space plus C. Okay, so make sure you save both your HTML document and your JavaScript file, and let's run this. So side A is 3, side B is 4. Let's press submit, and side C is 5. So yeah, everybody, that is a practice program to find the hypotenuse of a right-angled triangle. If you would like a copy of all this code, I'll post this in the comments section down below. If this video helped you out, feel free to help me out by smashing that like button, leave a random comment down below, and subscribe if you'd like to become a fellow bro. Hey yeah, everybody. In this video, we're going to create a simple counter program using JavaScript. So sit back, relax, and enjoy the show. Let's begin, everybody. So head to your HTML document. We will create one label and 3 buttons. Label, use a closing tag, add a line break. The ID of this label will be count label. Count label. The text will set to be 0 to begin with. We'll need 3 buttons. Button, close it. The first button will have an ID of decrease button. Decrease button, and the text will be decrease. Okay, let's copy this button, paste it 2 additional times. The second button will be a reset button, text reset, and the third button will be increase. Increase button, increase. I would like to change the font size as well as the positioning of my count label. I'll link an external CSS style sheet. So I will create a new file, style.css. Within the head of my HTML document, I need to link this style sheet. Use the link tag. We'll set the relationship attribute, set this equal to style sheet, and set the href attribute to the name of your style sheet, style.css. We'll need this count label ID. I would like to change the CSS properties of my count label. So add a set of curly braces. We'll center this label and increase the font size. Display, block, text, align, center, font size 50 should be fine, 50 pixels. Save your style sheet, save your HTML file, and head to your JavaScript file. We'll declare and assign a count variable, let count equal 0. When we click on one of these three buttons, we would like to perform some function. Let's select the decrease button. Document.getElementById, decrease button, dot on click, let me close out of this, equals a function, parentheses, curly braces. So copy this, paste it 2 additional times. We have reset button and increase button. When I select the decrease button, I will take our count variable, minus equals 1. And we will change the inner HTML of this label. Document.getElementById, count label, dot inner HTML. Set this equal to our count. Copy these 2 lines of code. Paste it within each of these functions. For the reset button, we will set count to equal 0, and the increase button, count plus equals 1. Let's save. When I click the increase button, it increases my label. Decrease decreases my label, and the reset button resets my label. So yeah, everybody, that is a simple counter program in JavaScript. I'll post the code for this program in the comment section down below. Hey, if this video helped you out, help me out by smashing that like button, leave a random comment down below, and subscribe if you'd like to become a fellow bro. Hey everybody, just so you know that this topic is completely optional. If you're ever interested in making any sort of games with JavaScript, then this video is a must. Let's begin. To create a random number, let's declare a variable, and we will set this equal to type math dot, and there is a random method. Then let's display whatever x is, console.log x. The random method of math will generate a random decimal number between 0 and 1. But we can actually use that. Maybe we're rolling a dice. How do I generate a random number between 1 and 6? So to do this, I'm going to take math.random and multiply this by 6. This gives us a random decimal number between 0 and 5 technically. To truncate the decimal portion, we can round down. I will surround this with a set of parentheses, and we will use math.floor, and this will round down. This generates a random number between 0 and 5 because computers always start with 0. If I need 1 through 6, I can add an offset. I'll just add +1. This generates a random number between 1 and 6 as if we were rolling a dice. Now, I like to play a lot of Dungeons and Dragons, and there's different sized dice. There's 8-sided dice, 10-sided dice, 20-sided dice, etc. If I'm simulating rolling a 20-sided dice, I would multiply math.random method times 20 plus 1. So this generates a random number between 1 and 20. Maybe I need to roll a couple dice. I'll copy this line of code. We'll create variables y and z. Then display them. Console.log x, y, and z. This would be as if we're rolling 3 dice. We get 3 random numbers between 1 and 6. Just for fun, let's create some labels and generate some random numbers within our DOM. So within the body of my HTML document, I'll create a couple labels. Label, ID, this will be X label. Then close this label, add a line break. I'll add 2 more. Y label, and Z label. Then I'll create a button. Close the tag. Type equals button, ID equals roll button. Then I will add some text to the button, roll. Make sure to save, heading back to our JavaScript file. When we click on this button, we will execute a function. So we need to select our button, document.getElementById. The name of our button is roll button. Dot on click equals, set this equal to a function, parentheses, curly braces. Let's copy these lines of code, We don't need to declare these again. Let's get rid of this text. We'll declare the variables at the top. So after rolling 3 random numbers between 1 and 6, I will update our labels. X label, Y label, and Z label. We need to select each of these labels. Document.get element by ID. X label dot inner HTML. Set this equal to X. Then do the same thing with Y and Z. Make sure to change the labels to Y label equals Y, Z label equals Z. So make sure to save both of your files. Oh, I'm forgetting Z there. Okay. So now when I press this button, we will roll 3 dice, and we end up with 3 random numbers between 1 and 6. So yeah, that's how to generate some random numbers in JavaScript. If this video helped you out, you can help me out by smashing that like button, leave a random comment down below, and subscribe if you'd like to become a fellow bro. Hey, welcome back everybody. So let's talk about some useful string properties and methods. I have a variable username and assign this whatever your first and last name is. If we type this variable and add a dot, we have access to a bunch of different properties and methods of this string. One of which is the length property. This will give us the length of a string. How many characters are within this string? We could assign this to a variable, name length equal username.length, or we could display it. I'm going to display this with a console.log statement. Console.log username.length. The length of my name is 8 characters, but yours will likely be something different. Let's cover a few more. We can get the character of a string at a given index. Type the name of the string variable, dot, char at, add a set of parentheses. Whatever character you would like to return, you will add the index of that character. Computers always start with 0, so the first character in the string would have an index of 0. So maybe I would like to assign this to a variable. Let first letter equal username dot char at index 0. Or I could display it with console.log and then just add this variable and method within the parentheses. The character at index 0 of my string is B. Then index 1 would be R, 2 would be O. That is the char at method. You can find the index of the first occurrence of a letter. Type the variable name, user name dot index of, then pass in a character you would like to find the first index of. How about O? And then I will display this with console.log. The index of the first occurrence of the character O is at index 2, 0, 1, 2. There's also last index of. Last index of, and we'll keep that as O. The last occurrence of O has an index of 5, 0, 1, 2, 3, 4, 5. We can also trim spaces before and after a string. So I'm going to display this as it is. And I'll turn these into comments. Okay, console.log, username. And we have all the space that we would like to get rid of. So to do that, we will reassign username with username.trim. This gets rid of any empty spaces before and after any other characters. We could make our string all uppercase, username equals username.toUppercase. And my name is all uppercase. There's also lowercase. 2 lowercase. And all the characters are now lowercase. Okay, here's another. Replace all, but this time let's create a phone number. Let phone number equal, then within a set of quotes, make up some phone number with dashes. 123-456-7890. Okay, using the replace all method, I can replace all given characters with another one. So phone number equals phone number dot replace all. So this has 2 arguments. The character we would like to replace, add a comma. The second character is what we'll be replacing all of these dashes with. How about a /? And we will display phone number. So here's my phone number. If you would like to eliminate these dashes, then just don't type in anything. And those dashes are gone. So yeah, those are a few useful string properties and methods. If you have a string variable, add a dot, and you have access to a bunch of different properties and methods, a lot of which we didn't cover, but these are just a few of the basics. So yeah, those are some useful string properties and methods. If this video helped you out, you can help me out by smashing that like button, leave a random comment down below, and subscribe if you'd like to become a fellow bro. Sup everybody, let's talk about the slice method. The slice method extracts a section of a string and returns it as a new string without modifying the original string. How is this useful? Maybe we have a variable full name. Set this equal to whatever your full name is. What I would like to do is extract certain portions of this full name to create a first name and a last name without changing the full name. I'll declare two additional variables but not assign them yet. First name as well as last name. I can create an entirely new string from an existing string via the slice method. Let's extract this last name and assign it to this last name variable. Last name equals, then type the original string, full name, dot, slice. Within the parentheses, there's up to two values that we can add, the starting index and the ending index. If I need my last name, that would be at index 0, 1, 2, 3, 4. So 4 would be the last value. If you don't add a second value, it's assumed to copy everything until the end of the string. I would like the entire rest of the string after index 4, and then we'll assign it to this new variable, last name. Let's display it to test it. Console.log last name, and this should display my last name. Yep. What if I need the first name? You can place up to two indices. So first name equals, type the original string, full name, dot, slice. The starting index will be 0, and the ending index will be, in my example, 0, 1, 2, 3. This doesn't include the last character. All right, then let's display my first name. And there's my first name. Even though this does work, it wouldn't be realistic to do this by hand manually every time we would like to create a first name and a last name from a full name, right? So why don't we use the string index of method to search for any spaces and return an index? So let's try this again. Let's begin with last name. Last name equals full name dot slice, and we only need one index. We need the starting position of where to begin. So we would like to begin where there's any spaces, +1. So we need to begin at this character in my example, but it might be different depending on what your full name is. So I would like to search for any spaces, and I can do that by taking my string, full name, dot, and use the index of operator, and we will search for the index of any spaces. So let me hide my first name here. Oh, pay attention to capitalization. There. However, I need to get rid of the space because the first value is inclusive. So I will add +1. Everything after the first space, slice it and create a new string. So there's my last name. Then let's do this with our first name. First name equals full name dot slice. Then we'll need two indices. 0, the beginning, and we will end wherever there's a space. So there's my first name and my last name. Let's try a different name just to be sure that it's working right. How about Snoop Dogg? Yep, Snoop Dogg. All right, everybody, that is the slice method. It extracts a section of a string and returns it as a new string without modifying the original string. In our example, we created a first name and a last name from a user's full name. And that is the string method. If you found this video helpful, you can help me out by smashing that like button, leave a random comment down below, and subscribe if you'd like to become a fellow bro. Hey everybody, we're talking about method chaining. Method chaining is a programming technique where you call one method after another in one continuous line of code. Here's an example of where it could be useful. Let's say we have a username. And assign this whatever your first name is, but I'm going to make this all lowercase in this example. What I would like to do is take the first character of the string and make it uppercase. Without using method chaining, we could do something like this. We'll create a temporary variable to store a letter, and I will return the first letter in the string. User name dot, and I will use the char at method, and the first letter has an index of 0. Letter is now B, but now I would like to make it uppercase. I will need to reassign my letter variable equals letter dot to uppercase. And then we can display this. Console.log letter. This should display the letter capital B. To write this code a little more elegantly, we could use method chaining. After calling one method, we can call subsequent methods. I'll eliminate this line and follow the char at method with to uppercase. Then add that set of parentheses. This single line of code will do the exact same thing, and it's easier to read and understand. You can follow one method call with another. If I would like to invoke another method, I don't know, like trim, I could just add that to the end. You have the capability of calling one method after another in one continuous line of code. It makes your code cleaner and more readable. So yeah, that's method chaining. If you found this video helpful, feel free to help me out by smashing that like button, leave a random comment down below, and subscribe if you'd like to become a fellow bro. Sup guys, in this video I'm going to explain if statements. An if statement is a basic form of decision making. If a condition is true, then we do something. We execute some subset of code. If not, then we don't do it. In this example, I have variable age, and I'll set this equal to maybe 21. If somebody's age is over 18, I would like to display a message that says, you're an adult. If they're under 18, it doesn't display anything. So to create an if statement, type if, a set of parentheses for a condition, and then a set of curly braces. If some condition that we check is true, we will execute any code within these curly braces. I would like to check to see if age is greater than or equal to 18. If it is, then we'll execute whatever code is within these curly braces, and I'll display a message. You are an adult. My current age is 21. The if statement checks this condition. It's true, so we do this. If it's not true, like I'm 12, it will skip over anything within these curly braces entirely. This gives us a lot of options. If statements are a basic form of decision making. Now, in place of just skipping this code entirely, we could do something else. If you would like to take a different course of action, you could add an else statement. Else, let's print a different message. You are a child. Now, when I run the same code, we will check this if statement. If it's false, then we skip everything within the curly braces. If there's an else statement, we instead do this. You are a child. If there's any other conditions you would like to check before reaching the else statement, you can add an else if statement. Else if, maybe I'll check to see if age is less than 0, and we'll display something else. Console.log, you haven't been born yet. Currently, my age is 12. This condition isn't true, we skip it. This condition isn't true, we skip it. And we move on to the else statement, kind of like a last resort. Now, if this condition is true, age is less than 0, maybe I'm negative 5 years old. Well then, this statement is false, but this one is true. And you can add as many else if statements as you want. Now check this out. Let's check to see if somebody is a senior, if they're 65 or older. Else if age is greater than or equal to 65. You are a senior citizen. So let's change our age to 65. Now check this out. So it displays the message, you are an adult still. That's because this if statement is still true. Our age is greater than or equal to 18. So the order of your if statements does matter. If I would like to check this condition first, I should probably move this to the top and make it an if statement. So let's make this statement if, and the second one, else if. There. You are a senior citizen. If you need to check a Boolean value, that's actually really easy to do with if statements. So I'm going to turn all of these into comments. And here's another example. Maybe we have a variable, online. If somebody's online, this is true. If they're offline, this is false. If you need to check a Boolean value using an if statement, you could just place the Boolean variable within here. If online. So if a user is online, let's display you are online, else you are offline. Okay, online is set to true, you are online. If this was false, you are offline. So yeah, everybody, those are if statements. It's a basic form of decision making. If a condition is true, then do something. If not, then don't do it. So yeah, those are if statements in JavaScript. Hey, if this video helped you out, you can help me out by smashing that like button, leave a random comment down below, and subscribe if you'd like to become a fellow bro. Hey guys, in this video I'm going to explain the checked property of checkboxes and radio buttons. All the checked property does is let us know if a checkbox or a radio button is selected. Accessing the checked property will give us a Boolean value, true or false. Heading to our HTML document, let's create a checkbox. Input, the type will equal checkbox. Give this checkbox a unique ID. My checkbox is good. There's our checkbox, but we should probably add a label because we don't know what it's for. Label for equals copy your ID, paste it, close the label. Let's add some text. Perhaps this is a subscribe button. We can check either the checkbox itself or click on the label to check that. Then we will add a button. This will be a submit button. Button ID equals my button. Let's close it, add some text, submit. I think I'll add this on a new line. I'll add a line break, and that should be good for now. Heading to our JavaScript file, when we click on this button, we would like to do something. First, we will select this button by typing document.get element by ID. The ID of that button was my button. Set the onClick event attribute equal to a function. When we click on this button, what would we like to do? I would like to see if this checkbox is checked or not. I'll use an if-else statement. If that checkbox is checked, we'll do something. If not, we'll do something else. Within the parentheses, we'll select this checkbox. Document.get element by ID. The ID of that checkbox was my checkbox. Follow this with the checked property. We can check to see if this is true by using the comparison operator, which is two equal signs, true. This is optional, but you don't necessarily need to write that. If document.get element by ID, my checkbox is checked. What are we going to do? Let's let the user know that they're subscribed. Console.log, you are subscribed. Else, if this checkbox is not checked, then you are not subscribed. Okay, let's try it. I'll just press submit. You are not subscribed. I'll reload the page, check that checkbox again, press submit. You are subscribed. Now, this can be a little difficult to read. What I like to do is store elements within a variable for readability. I'm going to copy this section, then assign it to a variable, maybe a constant. Const my checkbox equals document.get element by ID, my checkbox. We can refer to this element by this variable name. If my checkbox is checked. This would do the same thing. I find it easier to read. Okay, level 2. Let's do this again, but with radio buttons. Heading back to our HTML file, we'll create 3 radio buttons. Input type equals radio. These will all have the same name. Perhaps this will be card for payment. What kind of card are you going to use? The ID of the first button will be a Visa button, if they're paying with a Visa card. Okay, let's copy this, paste it 2 times. A MasterCard button. Then what about PayPal button? I'm gonna add a line break at the end. Then let's add some labels. Label, close it. The for attribute will be the same as the ID. The text will be Visa, then MasterCard, MasterCard, lastly PayPal, PayPal. Okay, we have our 3 payment options. Since these 3 radio buttons are within the same group, we can only select one. Be sure to save everything. Heading back to our JavaScript file, let's get all of the buttons and store them within a variable. Const Visa button equals document.getElementById. The ID was Visa button. Then we have MasterCard button. Then PayPal button. Okay, we have our buttons. Using if-else statements, we'll check to see which of these buttons is selected. First, we'll check our Visa button. If Visa button dot checked, then we'll display a message. You are paying with a Visa. Else if MasterCard button is checked, you are paying with a MasterCard. Else if PayPal button is checked, you are paying with PayPal. Else, no radio button must be selected. You must select a payment type. Let's try this. I'll select Visa, press submit. You are paying with a Visa. MasterCard, submit. You are paying with a MasterCard. PayPal, submit. You are paying with PayPal. I'll refresh the page, not select anything. That will execute the else statement. You must select a payment type. So yeah, everybody, that is the checked property. They're typically found within checkboxes and radio buttons. You can access this property by following a checkbox or a radio button with .checked. This value will be true or false. If it's true, you can do something. If not, you can do something else. So yeah, that's the checked property, everybody. If you would like a copy of all this code, I'll post all of this in the comment section down below. And well, yeah, that's the checked property in JavaScript. Hey guys, in this video I'm going to explain switches. A switch is a statement that examines a value against many case clauses. It's more efficient than using many else-if statements. In this example, I have a letter grade. What I would like to do is examine this letter grade. If our grade equals A, then we will display you did great. Else if grade equals B, you did good. C, you did okay. D, you passed, barely. F, you failed. And there is an else statement. If something is not one of these letter grades, maybe the word pizza. Pizza is not a letter grade. It's not normally good practice to use a whole bunch of else-if statements. If you find that you're using a lot of else-if statements, it may be better to instead create a switch. Let's write the same program, but use a switch instead. To create a switch, we type switch, a set of parentheses, and then a set of curly braces. Within the parentheses, we're going to examine a value or variable. I'm going to examine our grade, and we will compare our grade against many case clauses and see if there's a match. To create a case clause, you type case, and then some value that you would like to examine to see if there's a match. Case A. We're checking to see if grade is equal to A. If they match, then we do something. So add a colon, then type whatever you would like to do. Console.log. You did great. Then at the end of your case, make sure to add the word break. This is our case if grade is equal to A. So what if grade is equal to B? Case B. You did good. Case C. You did okay. Case D. You passed. Barely. Case F. You failed. Now, if there's no matching cases, you can add a default clause. Default, Let's display grade is not a letter grade. This will do the same thing, except it's more efficient. Our grade is A, you did great. B, you did good. C, you did okay. D, you passed, barely. F, you failed. Let's make up something. Pizza. Pizza is not a letter grade, so that's a switch statement. Now with your cases, you could put a condition. Instead of letter grades, what if we were working with number grades? Like 95 is an A. So another way of writing the switch is that if we're checking conditions, we could pass true within the switch. We'll examine true against some matching conditions. Case grade is greater than or equal to 90, so that would be an A. Case grade is greater than or equal to 80, that would be a B. Grade is greater than or equal to 70, that's a C. Grade is greater than or equal to 60, that's a D. Grade is less than 60, so that would be an F. Now this way, you can compare a value or variable against many matching conditions. So that would be another way of writing a switch. So yeah, everybody, that is a switch statement. It examines a value for a matching case against many case clauses. It's more efficient than using many else-if statements. Using an else-if statement isn't bad, but you don't want, 10 of them. So yeah, that's a switch, everybody. If you found this video helpful, you can help me out by smashing that like button, leave a random comment down below, and subscribe if you'd like to become a fellow bro. Well, alright then everybody, we are on the AND as well as OR logical operators. They give us the ability to check more than one condition concurrently. How is this useful? Here's an example. We have a variable temp. Temp short for temperature. I would like to check to see if my temperature falls within a certain range using an if statement. Is 15 degrees Celsius. That's not a bad temperature. Within the condition of an if statement, I would like to check if my temperature is greater than 0 and less than 30. So within the parentheses, let's check if temp is greater than 0. And to check another condition concurrently, we can use AND, which is 2 ampersands. And I would like to check if temp is less than 30. If my temperature falls within this range between 0 and 30, then we execute whatever's within this if statement. Let's display the weather is good. Else, the weather is bad. Our temp is currently 15 degrees Celsius. The weather is good. This condition is true, and this condition is true. With the AND logical operator, both conditions must be true in order for us to execute this if statement. If one of them is false, then we don't. What if our temperature was -10? This condition is false, but this one is true. And using the AND logical operator, both conditions must be true, which they're not in this example, so we skip this if statement and execute the else statement. The weather is bad. Maybe our temperature is 50 degrees Celsius. This time, this condition is true, but this one is false. Therefore, we skip this if statement. The weather is bad. That's one use of the AND logical operator. You can check more than one condition, and it's useful if you need to find if something is within a certain range, like a range of temperatures. Let's talk about the OR logical operator. Using the OR logical operator, either condition can be true in order to execute this if statement. So let's rewrite this. This time, let's check to see if temp is less than or equal to 0, or, which is represented by 2 vertical bars, or temp is greater than or equal to 30. If at least one of these conditions is true, then we execute this if statement, but the weather will be bad. Else, the weather is good. Our temperature is currently 50. The weather is bad. What if our temperature was -10? The weather is still bad. How about 15? Well, the weather is good. Using the OR logical operator, either one of these conditions can be true. If one is false and the other is true, that's completely fine. Now, you can add more than one logical operator. Let's head back to our previous example. I'm just going to undo everything. Let's throw in another variable. Let sunny. Sunny will be a Boolean value. Sunny will equal true if it's sunny outside. If it's cloudy outside, well then sunny will be false. So in order for the weather to be good, the temperature needs to be above 0 and under 30. and sunny needs to be equal to true. But if you're working with a Boolean value, you don't need to say equals true. You can just add that Boolean variable. So our temperature is 15, and sunny is true. All three of these conditions are true. Therefore, the weather is good. If the temperature is 15, but it's not sunny outside, that's false. Well, then the weather is bad. You can link more than one condition using these logical operators. So yeah, that's the and as well as the or logical operators. You can check more than one condition concurrently. Hey, if this video helped you out, you can help me out by smashing that like button, leave a random comment down below, and subscribe if you'd like to become a fellow bro. Hey everybody, let's talk about the not logical operator, which is represented by an exclamation point. Within a condition, it's typically used to reverse a condition's Boolean value. A condition that is true, that's preceded with the not logical operator, becomes false. If it's false originally, it becomes true. It gives us a few additional ways to write code. Here's an example. We have variable temperature, temp for short, and I'll set this to 15 degrees Celsius. If I would like to check to see if it's warm or cold outside normally, I could write an if-else statement. If temp is greater than 0, then it's warm outside. It's warm outside. Else, it's cold outside. Currently our temperature is 15 degrees Celsius. It's warm outside. If it was negative 15, it's cold outside. Using the not logical operator, we can write this code a different way if we choose to. We can check to see if the temperature is not greater than 0. So to do so, we will surround this condition with a set of parentheses and precede this condition with the not logical operator, an exclamation point. In plain English, we're checking to see if our temperature is not greater than 0. So that would mean it's cold outside, right? Else, it's warm outside. So taking our same temp of negative 15, it's cold outside. If it's 15, it's warm outside. Now let's do this with a Boolean variable. Let sunny equal true. If, with a Boolean variable, if you would like to place it within a condition, all you have to do to check if it's true is just write the name of the Boolean variable. If sunny. So you don't necessarily need if sunny equals true. If sunny is true, then it's sunny outside. Else, it's cloudy outside. Currently, sunny is true. Therefore, it's sunny outside. If I would like to check if it's not sunny outside, I can precede this Boolean variable with the not logical operator. And you don't necessarily need to surround it with those parentheses if it's a Boolean variable. If it's not sunny, well then it's cloudy outside. Else, it's sunny outside. Sunny is true, it's sunny outside. If it's false, it's cloudy outside. So by using the not logical operator, it gives us a few additional ways in which we could write code. More versatility is a good thing. So yeah, that's the not logical operator. It's typically used to reverse a condition's Boolean value. If a condition is true, it's now false. If it's originally false, it's now true. And that is the not logical operator. Hey, if you found this video helpful, be sure to smash that like button, leave a random comment down below, and subscribe if you'd like to become a fellow bro. Well, sup everybody, I have to explain what a while loop is. A while loop is like an if statement, except it repeats some code while some condition is true. It could potentially repeat an infinite amount of times. Here's an example. Let's say we need to get some user input. We would like a user to type in their username. Let's create a variable username, and I will set this equal to just an empty string for this example. To create a while loop, we type while, set of parentheses, set of curly braces. We will continue this code while the condition remains true. Let's check to see if our username is equal to an empty string. That means the user didn't type in anything. So within the curly braces, let's create a window prompt. Username equals window.prompt. Enter your name. Then at the end, let's display console.log hello username. Enter your name. I'm just going to press OK. When we reach the end of a while loop, we check the condition again. If it's still true, we repeat this code for another iteration, and then check again. I'm hitting OK, but I can't exit this window prompt until I enter in my name. I'll type in my first name, hit enter, hello, bro, my username. Although in this example I'm hitting OK, but you could hit cancel to exit. Let's add another condition. Or username is equal to null. That means there's no value. To exit, I simply can't press OK or cancel. I need to type in something because we're stuck in a while loop. I'll type in my first name again, and then we can exit. Once I typed in something for my username, both of these conditions were no longer true. Then we could escape the while loop and continue on with the rest of the program. Now, when you create a while loop, you should write some sort of way to escape the while loop from within it. Otherwise, you'll encounter what's called an infinite loop, like this. While, and our condition is while 1 is equal to 1. There's no way we can escape it. Console.log help. I'm stuck in an infinite loop. So this code will just repeat forever. You can see that the counter here is going up. I think my web browser froze. So yeah, that's a while loop, everybody. It repeats some section of code while some condition is true. Once you reach the end of that section of code, you check the condition again. If it's still true, you repeat the code again. And this could potentially repeat an infinite amount of times. So that's a while loop in JavaScript. If you found this video helpful, be sure to help me out by smashing that like button, leave a random comment down below, and subscribe if you'd like to become a fellow bro. Alright guys, I have to explain a variation of the while loop. It's called a do while loop. How this works is that you do something, then you check the condition, then you repeat if the condition is true. So going back to the previous topic on while loops, I have a while loop. We're checking if our username is an empty string, which it is originally. While this condition is true, we will prompt the user to enter their name. If I run this program and press OK without typing anything, I can't escape this prompt. Once I type in my name, hit enter or OK, we escape the while loop and move on with the rest of our program, which displays hello, whatever your username is. What I would like to do is not assign my username right away. I'll declare this variable, but not yet assign it anything. Now, when I run this program, here's the problem. We don't get that window prompt to type in our name. We skip the while loop and continue on with the rest of the program, and this displays hello undefined. We're using a variable we declared, but not yet assigned. Once we reached our while loop, this condition was false from the get-go, so we skip over the while loop entirely. What if I would like to run this code at least once, and then prompt again if the username is equal to an empty string? One way, although I wouldn't recommend it, is that we can copy this line of code and paste it before the while loop. That prompt comes up, I'll skip it, and then we enter the while loop, and we're stuck within it until we type in something. I don't like to repeat code if I don't have to, so there's a better way of writing this. Let's convert this while loop to a do while loop. Let's copy the while keyword and the condition, and we're going to move it to the end of our curly braces. And preceding the opening curly brace, we will write do. Instead of checking the condition first, we check the condition last. We will do all of this code and then check the condition. Now, if I run this program, we encounter that window prompt. I'll press OK and try and skip this prompt. I can't. I'll type in my name, and we escape the while loop. So a do while loop is a variation of the while loop. You do something first, and then check the condition. With a standard while loop, you check the condition, and then do something if that condition is true. With a standard while loop, you may skip some code entirely if the condition is false from the beginning. With a do while loop, you do it at least once, and then check the condition. So yeah, that's a super quick video on do while loops. In the next topic, we'll move on to for loops. Well, I should probably explain for loops. A for loop repeats some code a certain amount of times. There's a lot of similarities between what for loops and while loops can do. There are a few discrepancies though. You tend to use for loops when you want to repeat code a limited amount of times. A while loop is better suited to something that could execute an infinite amount of times possibly. In this example, we'll create a program to count to 10. We'll start at 1, count to 10. And we could do that with a for loop. So type for, parentheses, curly braces. What would we like to do within our curly braces? Let's display a variable, console.log. Let's call this counter. Now within the for loop, there's 3 statements that we can add. The first is that we can declare and assign a counter or some other variable. The first statement, we will type let counter, and I'll set this equal to 1. Then make sure to add a semicolon at the end to terminate the first statement. Second is our condition. We'll continue this statement as long as this condition is true. I will continue this for loop as long as our counter variable is less than or equal to 10. Then add a semicolon. And the third statement is that we can increment our counter. Counter plus equals 1. After each iteration, we increment our counter variable by 1. After running this program, we begin at 1 and count to 10. If I need to count to 100, I can just change this condition. Counter is less than or equal to 100. And we have counted from 1 to 100. If I need to begin at a different number, I could just set my counter to a different number, like, I don't know, 50. Now we have begun at 50 and counted to 100. So this variable counter, it's known as a local variable. It doesn't exist outside of this for loop. What a lot of programmers do, if they need some sort of temporary variable within a for loop to keep track of what iteration they're on, they'll simply just use I. That's a common convention. So let's change counter to I. So let I equal, let's change this back to 1. We'll count to 10 and increment I by 1 after each iteration. Now we could begin at 10 and count down. If we were to take that approach, we'll set our variable I to 10. We'll continue this for loop as long as I is greater than 0, and we will decrement I by 1. We could pretend that this is a countdown to New Year's Day. This time, when we escape the for loop, let's print Happy New Year. Console.log Happy New Year. Okay, we begin at 10, count down to 1. Once this condition is no longer true, we escape the for loop and print Happy New Year. So this simulates a countdown. So for loops are fairly flexible. We can increment or decrement our counter, I. We're counting down by 1 currently, but we could count down by 2 if we would like. Let's change I minus equals 1 to 2. And now we will count down by 2. 10, 8, 6, 4, 2, Happy New Year. Or even 3. 10, 7, 4, 1, Happy New Year. So yeah, that's basically a for loop. We repeat some code a certain amount of times. There's a lot of overlap where you could use either a while loop or a for loop. A while loop tends to be better in certain situations where you may potentially need to repeat some code an infinite amount of times. For loops are more suitable for code where you only need to repeat it a certain or given amount of times. So yeah, those are for loops. Hey, if this video helped you out, you can help me out by smashing that like button, leave a random comment down below, and subscribe if you'd like to become a fellow bro. Hey guys, I have a super quick video on the break and the continue statements. Let's begin with the break statement. The break statement breaks out of a loop entirely. In this example, I'm going to create a for loop. We will count the numbers 1 through 20. However, once we reach 13, I would like to exit this loop, because 13 is considered an unlucky number. I know it's a weird example. So let's define our counter I equals 1. And I will continue this as long as I is less than or equal to 20. Then increment I by 1. For the time being, let's display whatever I is. This will display the numbers 1 through 20. If I would like to break out of this loop entirely, if we reach the number 13, I can add a break statement. So let's check to see if I is equal to 13. If it is, then we'll break. Okay, we have the numbers 1 through 12, then we break. There's also the continue statement. It will skip an iteration of a loop. If we replace break with continue, we will skip that specific iteration and continue on. So we have 1 through 20, but the number 13 is not here. So that's the main difference between break and continue. Break will break out of a loop entirely. Continue will skip only that iteration. So yeah, those are the differences between the break and continue statements. Hey guys, in this topic I'll be explaining nested loops. A nested loop is just a loop inside of another loop. Here's an example. So I'll create an outer loop that will count, I don't know, to 3. Let I equal 1. Continue this as long as I is less than or equal to 3. Increment I by 1. During each iteration, I will display the value of I. Console.log I. This counts up to 3. What if I would like to repeat this entire for loop so many times? Well, I could put a for loop inside of a for loop. So let me copy this, get rid of this line, and paste another for loop within the curly braces of the outer for loop. We have a nested loop. It's a loop inside of another loop. Now, one thing with nested loops is that you'll want another counter besides I, because we don't want to reuse the same counter. A common convention of the counter of nested loops is that they'll use a counter of j, because j comes after I in the alphabet. So let's replace I with j, and do so with our console.log statement. So if I was to run this program, we would count the numbers 1 through 3 times. Once we complete all of our iterations of the nested loop, we then complete one iteration of the outer loop. If I change this outer loop to continue as long as I is less than or equal to 2, well then we will repeat this inner loop a total of 2 times. Here's a different example. Let's use nested loops to draw a rectangle within our DOM, and we'll accept some user input. The outer loop will be in charge of the rows, the inner loop will be in charge of the columns. We'll declare 2 variables. Let rows equal window.prompt enter number of rows. Then let columns equal number of columns. The outer for loop I will continue as long as I is less than or equal to rows, and the inner for loop will continue as long as j is less than or equal to columns. We'll need an HTML element to work with, so within your HTML file, let's create a label. Label, close it, and I will give this an ID of my rectangle. Make sure to save. Then heading back to our JavaScript file, let's change the inner HTML of our label. I will select our label, document.getElementById, my rectangle. I will set the inner HTML. Before we draw a rectangle, let's print some of these numbers. I would like to append the inner HTML. I will set this to plus equals our counter j. The inner for loop will print 1 row. Then to go down to the next row, we can add a break line. Document.getElementById, my rectangle, dot inner HTML, and I'm going to append a line break. Okay, so let's try this for now. We'll just print some numbers. What about 3 rows and 9 columns? So we have 3 rows and 9 columns of our index j. Let's replace these numbers with maybe a symbol, so it's an actual graphical rectangle. Let symbol window.prompt enter a symbol to use, and replace j with our symbol. Enter a symbol to use. What about a $sign? Press OK. Number of rows, maybe 4 rows, 5 columns. And we have a graphical rectangle. Let's try it again. What about an asterisk? 3 rows, 9 columns. Sweet. So yeah, everybody, that's a nested loop. It's a loop inside of another loop. When you encounter them, it's kind of situational. In this video, we used a nested loop to help us print a rectangle. So yeah, that's a nested loop, everybody. Hey, if you found this video helpful, be sure to help me out by smashing that like button, leave a random comment down below, and subscribe if you'd like to become a fellow bro. Hey everybody, we are moving on to functions. With a function, you define code once and then use it many times, whenever you need. To perform some code, you simply call the function name. In this scenario, I need to sing happy birthday like 3 separate times. So without using a function, I could write something like this. This will be one iteration. So when I run this, we sing happy birthday once. If I need to sing 2 additional times, well, I would have to copy this code and paste it 2 additional times to sing 3 verses of my happy birthday song. So we don't like to repeat code if we don't have to. Wouldn't it be nice if we could write this code once and reuse it whenever we need? Well, we can do that with a function. So to create a function, we will type function and then a unique function name. Let's name this function happy birthday. Add a set of parentheses and a set of curly braces. Any code you would like to repeat, simply place within the curly braces. If I need to sing 1 verse of happy birthday, I take the function name and add a set of parentheses. This will invoke, otherwise known as call the function. So you type the function name, add a set of parentheses. I like to think of the parentheses as a pair of telephones that are talking to each other. That's how you call a function. If I need to use this code again, I can simply call the function again. So that's 2 times and 3 times. So we have accomplished our task of singing 3 verses of my happy birthday song. What if we have some variables? Let user name equal your first name, and let age equal some age. Within my happy birthday song, I'm going to insert my username as well as my age. So within my happy birthday song, we have my username and my age. Functions have access to global variables. A global variable is basically a variable that's declared outside of any functions, or any set of curly braces. For example, we may have a function to start our program, and we will place this code within here. I will call the start program function to begin my program. But we have one issue. Uncaught reference error. Username is not defined. Variables, when declared with the let keyword, aren't recognized outside of the immediate set of curly braces. So my happy birthday function has no idea what username or age is. These variables only exist within the immediate set of curly braces. What I could do is that when we invoke the happy birthday function from within the start program function, we can send some information to this happy birthday function so that it will recognize my username and my age. To pass some values or variables to a function, when you invoke that function, within the set of parentheses, just list whatever you would like to send over. I would like to send over my username and my age. These are known as arguments. However, you need a matching set of parameters. Within the declaration of my happy birthday function, I need a matching set of parameters. You can just copy the arguments over and then paste them within the happy birthday function. These are known as parameters. You need to send over a username and an age. So now this should work. So here's my username and my age. If I invoke this function without passing my arguments, well then this function doesn't know what my username and age is. And with your parameters, they don't necessarily need to be the same name. You can rename these values when you receive them within the function. I'll rename username as A and age as B. And I'll change that here and here. This would also work, but make sure you get the orders of the arguments and the parameters right. So if I switch these around, happy birthday, dear 21, you are bro years old. So the order of the arguments and the parameters does matter. So yeah, everybody, that's a function. You define code once, and then you can use it many times. To perform some subroutine of code, you just call the function name. This is useful because we don't have to repeat code more than once. If you find that you're going to repeat code more than once, you could write it within a function. So yeah, those are functions, everybody. In the next video, we'll discuss return statements. Hey, if this video helped you out, you can help me out by smashing that like button, leave a random comment down below, and subscribe if you'd like to become a fellow bro. Well, alright everybody, I need to discuss the return statement. The return statement is used within a function to return a value back to the spot in which you invoked a function. When you call a function, you can return some information. To demonstrate this, we're going to create a program to calculate the area of a rectangle using a function and then return the value. So to create this program, let's declare a few variables. Let area, let width, and let height. We'll accept some user input. Width equals window dot prompt enter width. Copy this line, paste it, change width to height here and here. At the bottom of our program, let's create a function to calculate the area of a rectangle. So to create a function, type function. Let's name this get area, parentheses, curly braces. When we use this function to calculate the area of a rectangle, we'll need to set up some parameters. In order to do so, we'll need a width and a height. When we invoke this function, we will pass these variables as arguments. When we assign our area variable, let's set this equal to, then invoke the get area function. But we need to pass in a matching set of arguments, our width and our height. Let's fill in this get area function. I will declare a temporary variable let result equals, and to calculate the area of a rectangle, it's simply width times height. If I need to send a value back to the spot in which we called a function, we can use the return keyword. I would like to return the result. Then at the end of our program, but before our function, let's display the result, just to be sure that it works fine. Console.log, the area is area. Okay, let's try it. Okay, enter the width, maybe 5, height 6, the area is 30. Let's try it one more time. How about the width is 6 and the height is 9. The area is 54. So when we returned the result, once this function was completed, just imagine that we're replacing this function call with 54. We're returning a value back to the spot we invoked a function. We assigned 54 to our variable area. You could shorten this code as well. You don't necessarily need a temporary variable. We could eliminate this line and return width times height. And that would do the same thing. 6 times 9 is 54. So yeah, everybody, that is the return statement. It returns a value back to the place where you invoked a function. So yeah, that's the return statement. Hey, if you found this video helpful, be sure to smash that like button, leave a random comment down below, and subscribe if you'd like to become a fellow bro. Hey guys, in this video I'm going to explain the ternary operator. It's a shortcut for an if-else statement. It's represented by a question mark. There's 3 parts. We write some condition, follow the condition with a question mark as if we're asking a question. If that condition's true, we perform an expression. If that condition is false, we perform a different expression, and separate each expression with a colon. Here's an example. Let's create a function that will check a user's age. Initially, we'll use an if-else statement, and then later write it using the ternary operator. Maybe we have a Boolean variable, let adult, and we will invoke a checkAge function, and pass in some age. Let's define this function. Function check age. There is one argument. Let's name this age. I need to check to see if age is greater than or equal to 18. I could write with an if statement, if age is greater than or equal to 18, let's return a Boolean value of true. Else, return false. Let's display whatever our adult Boolean variable is. Console.log adult. I pass the number 21 as an argument. Check age returns true. If I was 12, well then check age returns false. There's another way of writing this, and I think it's a lot easier. A lot less syntax. This function will return a value, so I'm going to precede our ternary operator with the return statement. To use the ternary operator, we write a condition followed with a question mark as if we're asking a question. Age is greater than or equal to 18? Question mark. Second is an expression if that condition is true. We're returning something. Let's return true. And the second expression, if that condition is false, after a colon, write some expression or some value. False. So this will do the same thing. Currently I'm 12, this returns false. If I'm 21, well then it's true. We have 3 parts. A condition with a question mark, an expression if that condition is true, colon, an expression if that condition is false. Here's another example. Maybe we're playing a game, and we have to check to see if somebody won the game. I'll declare a check winner function. Function check winner. Let's declare a parameter of win. This will be a Boolean value. We're not returning anything. We don't need that return keyword. If we're examining a Boolean variable or parameter, all we need to do is type the name. Win? Question mark. If win is true, what do we do? Let's display a message this time. Console.log you win, colon, then some expression if win is false. You lose. Then let's invoke this function. Check winner. Then we can pass in a Boolean value or variable, like true. You win, or false. You lose. So that's the ternary operator. It's a shortcut for an if-else statement. You write some condition, followed by a question mark. If that condition is true, you do something. If not, you do something else. It's a shortcut, basically. So yeah, that's the ternary operator. If you would like a copy of this code, I'll post it to the comment section down below. And well, yeah, that's the ternary operator in JavaScript. Hey guys, in this video I'm going to explain some of the differences between the let and var keywords when declaring variables. Variable scope is where a variable is accessible. Any variable declared with the let keyword is limited to a block scope. It doesn't exist outside any sets of curly braces. Any variable declared with the var keyword is limited to a function. Here's an example. Let's create a for loop. We'll count up to 3. We will declare a counter of I, set this equal to 1. We'll continue as long as I is less than or equal to 3, then increment I by 1. So within my for loop, I will display whatever value I is, console.log I. Our results are 1, 2, 3. What if I attempt to access this variable I outside of this for loop? Console.log I. What would happen exactly? We have an uncaught reference error. I is not defined. That's because any variable declared with the let keyword is limited to a block scope. It doesn't exist outside of this set of curly braces. That's why my interpreter doesn't know what the heck this is. If we instead used the var keyword to declare a variable, well then this variable I can exist outside of curly braces, and that could be a problem. So now if I attempt to display whatever I is, it's now 4. So if I would like to reuse this counter I, but we declared it with var, since it already has a value, it's going to potentially mess with my program and cause problems. However, any variable declared with the var keyword doesn't exist outside of any functions if it's within one. Let's create a function. Function do something. I don't really care what it does. So let's copy this for loop, place it within the function, and invoke this function. Do something. Now when I display I, after it's been declared with the var keyword, we have that uncaught reference error. I is not defined. A variable declared with the var keyword can escape a set of curly braces, but it can't escape a function if it's contained within one. And that's where we need to discuss global variables. A global variable is declared outside of any functions. So we have our function. If I was to declare let name equal some name, since this variable is outside of any functions, it's considered a global variable. My entire program has access to it and recognizes what it is. If you use the var keyword when declaring a global variable, that can be problematic because if a variable declared with var is global, it can and will change the browser's window properties. Here's an example. For a demonstration, within my console, I'm going to access my browser's window object. I will type window, select it, hit enter. We haven't discussed objects yet, we will in a future video, but windows have properties. And my browser window has one property of name. And currently it's just an empty string. Let's say that I'm a beginner programmer and I would like to declare a name variable to hold a username. So if I was to use the var keyword and I create a variable name and set this equal to whatever my name is, behind the scenes I will unintentionally change this window property of name. So I'm going to save and run this. Let's access our window again. And let's find name. There. So I have unintentionally changed this Windows property of name, and I didn't even realize it. And that could happen to any of these properties, and that could of course possibly mess with your program and cause problems. Now this time I'm going to use the let keyword, and you may need to open this again with live server. This time I am using the let keyword. I will type window again, select it, hit enter, and let's find that name property again. There. By using the let keyword, I was able to declare this variable name without changing this Windows property of name. So yeah, those are some of the differences between the var and the let keywords. A variable declared with let is limited to a block scope. A variable declared with var is limited to a function scope. If you declare a global variable with var, it can potentially mess with your browser's window properties. Let will avoid that problem, so it's considered good practice to use let over var, but you should still know that var exists. So yeah, everybody, those are a few of the differences between var and let. Hey, if you found this video helpful, please be sure to smash that like button, leave a random comment down below, and subscribe if you'd like to become a fellow bro. Hey guys, in this topic I'm going to be discussing template literals. They're delimited with backticks instead of double or single quotes. They allow for embedded variables and expressions. Maybe we're working on a page for an online store. Let's create 3 variables. Let username, make up some username. Let items for the number of items that we have. Our cart has maybe 3 items in it. Let total, and make up some total price. $75. Okay, so normally if I would like to display these variables along with some strings with console.log, I would write something like this. Hello, username. You have items in your cart. Your total is $, total. Hello, bro, you have 3 items in your cart. Your total is $75. Another way of writing this, which I like to use, is to use template literals. In place of single or double quotes for strings, we will use these backticks. So I'm going to copy these 3 lines of code, turn these into comments. So when using backticks, we can embed a variable or expression within a string. For this first string, let's type hello, and to embed a variable or expression, use a $sign followed by a set of curly braces. And we can embed a value, variable, or expression. I would like to embed my username. So currently, this is what we have. Hello, your username. Let's try this again. You have, I would like to embed items. So that's $sign, curly braces, type the variable name, items, the word items, in your cart. You have 3 items in your cart. Your total is $sign, curly braces, total. So if you need that $sign, I could just precede this with another $sign. Your total is $75. I find using template literals a lot easier to work with. Here's a scenario. What if we would like to display one very long string? Here's what we can do. Let's assign a new variable, let text equals, and I will copy what we've placed within these log statements. Make sure it begins and ends with that backtick character. So we have assigned this entire string template to a variable text. If I need to display all of this, I can simply just use this text variable. Console.log text. Hello, bro. You have 3 items in your cart. Your total is $75. Where this is really helpful is if we need to update an HTML element with some text, especially if it takes up several lines. Let's head to our HTML file. I'll create a new label. Label, add a closing tag. I'll give this an ID of my label. In place of displaying this to my console, I'm going to update this label. To select that label, I will type document.getElementById. The ID was my label. Change the inner HTML equal to text. And this is what we have currently. Except I'm going to add some line breaks. I'll add that here, here, and maybe here. So there you go. Hello, bro. You have 3 items in your cart. Your total is $75. By using template literals, they allow for embedded variables and expressions. It's a more flexible way to write some output. I'll be using these a lot more in the future because, well, I like them. So yeah, those are template literals, everybody. If you would like a copy of this code, I'll post this in the comment section down below. And well, yeah, those are template literals in JavaScript. Hey, what's going on, everybody? So in this video, I'm going to explain the toLocale string method of numbers. What this does is that it returns a string with a language-sensitive representation of this number. It's fantastic if you need to format a number as some currency. We have a number. With numbers, there's a built-in method named toLocale string and a few arguments. The first is locale. Locale specifies the language. If you pass an undefined, well then you'll use the default set in your browser. Next is options. Options is an object with formatting options. We can specify if this number is currency, a unit of measurement, a percent. Let's begin. Let's create a number. Let my num equals, make up a number. I'll just pick 1, 2, 3, 4, 5, 6.789. So I'm going to reassign my num equals my num dot toLocale string. The first argument is locale. This is a string. Then we'll pass in a language. United States English, that would be EN-US. Then let's display my num. Console.log my num. So when I run this number is formatted with a comma for every thousands place. So that is US English. Okay, next let's try Hindi. So let's copy this, paste it. Hindi is HI-IN. So there's a different number formatting system. That is Hindi. Let's try one more. What about Standard German? Standard German is DE-DE. And there's a different number formatting system. Standard German. Whatever language you need, you just have to look up the format code, then pass that as a string. But those are a few. This time, let's format some currency. We would set that within options. I'll pick US English. To add some options, we'll use curly braces. Set the style to currency. Then currency, colon. Then a unit. USD is US dollars. So this number is now in US dollars. And you can see too that this number is rounded to dollars and cents. Originally we had 3 decimal places. Okay, let's try another. What about rupees? Let's copy this, paste it. HIIN. Currency. Rupees have a currency code of INR. There. Then let's try euros. Let's set the language to German, DE-DE. The currency code is EUR for euros. Now there's other styles besides currency. This time let's try a percent. MyNum equals MyNum to locale string. This time I will set the first argument in place of a language to be undefined. But I will set the style to be percent. This number as a percent is 12 million percent. So let's change that. 100 would be 10,000%, 0.5 is 50%, 0.01 is 1%. That's how to format your number as a percent. Then let's go to units. MyNum equals MyNum.toLocale string. We could set the first argument to be undefined. Then under options, set the style to be unit, a unit of measurement. What kind of unit would we like? I will separate that with a comma. Unit, colon, space. What about Celsius? Celsius. So currently my number is 100. Make sure it's lowercase. There, 100 degrees Celsius. You have a couple different units to choose from. Celsius, kilometers, miles, kilograms, whatever you need. Well, okay then everybody, that is an introduction to the toLocale string method. It returns a string with a language-sensitive representation of a number. You can set the locale, which specifies the language, by passing in undefined as an argument. That will use the default set in the browser. Then you can pass in formatting options. Would you like to set the style to currency, percent, a unit of measurement, etc. So yeah, everybody, that is the toLocale string method in JavaScript. Hey guys, in this video we're going to create a very basic number guessing game in JavaScript. So heading to our HTML file, let's create some HTML elements. I'll need a title for this game. I'll use an h1 tag. We'll add some text, number guessing game. Let's save that. I'll add a paragraph right underneath. Pick a number between 1 through 10. And I'll add a label. Label, close it. Enter a guess. We'll need some input. This will be a text box. Input ID equals guess field and a submit button. Input type equals submit. The ID will be submit button. And those are the HTML elements that we'll need. Now, heading back to our JavaScript file, we'll need a random number. I'll make this a constant. And it will be answer. Answer will be a random number between 1 and 10. So we will use math.random times 10. This will give us a random number between 0 and 9, so let's add 1 for numbers 1 through 10. Then we will surround this with math.floor to round it. Math.floor. And I will surround this code with math.floor. Math.floor. We'll keep track of our guesses. Let guesses equal 0. So when we click on this button, we would like to do something, but we need to select this button. And the ID was submit button. Document.get element by ID. The ID is submit button, and set the onClick event attribute equal to a function. What would we like to do? Well, there's a lot of stuff we have to do. We'll need to get the value from this text box. So document.get element by ID. The ID is guess field dot value, and we will assign this to guess. So let's declare that and assign it. Whenever we make a guess, we should increment guesses by 1 to keep track of it. Guesses plus equals 1. We'll first check to see if our guess is equal to our answer. If guess is equal to our answer, let's create an alert message. Alert. I'll use a template literal. Answer is the number. It took you guesses. Else if our guess is less than answer, we will alert the user to small. Else alert too large. Okay, make sure you save everything and let's run it. Enter a number. I'll pick something right in the middle. 5. Too small. What about 7? Too small. 9? 9 is the number. It took you 3 guesses. So yeah, that is a very basic number guessing game, everybody. If you would like a copy of this code, I'll post this in the comment section down below. And well, yeah, that's a very basic number guessing game in JavaScript. Hey everybody, in this video we're going to create a practice program in JavaScript to convert some temperatures using some HTML elements. So sit back, relax, and enjoy the show. Okay, let's begin everybody. Before we add HTML elements to our DOM, let's work on the logic behind the functions. Let's declare and assign variable temperature and set this equal to some temperature. Doesn't matter if it's Fahrenheit or Celsius yet. And at the end of our program, let's declare 2 functions. Function to Celsius, and there will be 1 parameter, temperature, and function to Fahrenheit. The formula to convert a temperature in Fahrenheit to Celsius is our temperature minus 32 times 5 divided by 9. The formula to convert Celsius to Fahrenheit is return temp times 9 divided by 5 plus 32. Let's say that our temperature is currently in Fahrenheit and I need to convert this to Celsius. I will reassign temp equal to, and I will invoke the toCelsius function and pass in my temperature. Then at the end, we will display whatever our temperature is. Console.log temp. So the temperature should be 0 degrees Celsius. If we're converting this to Fahrenheit, then 32 degrees Celsius converted to Fahrenheit is 89.6 degrees. Now that we have the logic behind these functions completed, let's add some HTML elements. Heading to our HTML file within the body tags, we will create a label. Then close it. And I'll add a line break. For some text, let's add enter a temperature. Then we'll create a text box. So use a self-closing input tag. I'll create a line break. The type is text. The ID, let's say, is text box. Let's create a second label. Label, close it, add a line break. We will add the text, convert to, colon, we'll create 2 radio buttons. Input type equals radio. So with a radio button, if they're in the same group, you can only select one. This first radio button will be for Celsius. We'll give this a unique ID of C button for Celsius. Name, unit. Let's save. There's one radio button, and we'll add a label next to this radio button. Label, close it, add a line break, and the label will be Celsius. Okay, let's copy these two lines and paste them and make a few changes. This will be the Fahrenheit radio button. We'll give this an ID of F button. The name will be unit, and change the label. Fahrenheit. Since these radio buttons are within the same group, they have the same name. We can only select one of them. If they had a different name, like C or F, well then you can select both of them because they're in different groups. So these will have the same name, unit. Let's create a submit button right at the end. So button, let's close it, add a line break. The type will be button. And the ID is maybe submit button. Let's add some text to this button. Submit. I'm going to close that. At the very bottom of our DOM, let's add a label that will display the temperature. Use a pair of label tags. I'll give this an ID of temp label. And those are all the HTML elements that we'll need. Let's save, head back to our JavaScript file. When we click on this submit button, there's a lot of things that we need to do. At the very top of my program, I'm going to type document.getElementById. The ID of this button is submit button. .onClick, and I will set this equal to a function, parentheses, curly braces. There's a lot of lines of code that we're going to add between these curly braces. So let's get rid of these 3 lines of code. We don't need them any longer. I'm going to declare a local variable within this function, let temp. So when we click on our button, let's check to see if one of these radio buttons is selected. Let's begin with the Celsius button. If document.getElementById, and the ID of this Celsius button is C button. We need to check to see if this radio button is checked or not. So add .checked. If this equals true, but since this is a Boolean value, you don't need to necessarily add equals true. Document.getElementById C button .checked. That's fine as a condition. If our Celsius button is selected, do something. Else if our Fahrenheit button is selected, do something else. Let's copy our condition, paste it. This time we are checking the Fahrenheit button, that is F button. And lastly, else. Else means we didn't select anything. Let's work on the else statement first. That's fairly easy. So I would like to change our label that's down here at the bottom, temp label. So type document.getElementById temp label, and I will change the inner HTML. I'll set this equal to select a unit. If I were to click on the submit button, it should change the text of my label to select a unit. We know that it's working. If we enter in a temperature, press the Celsius radio button, then click submit, what would we like to do? Let's extract the temperature from this text box. So we will take our temperature variable, set this equal to document.getElementById, and the ID of this text box is textbox. .value. When we accept user input from a text box, it's of a string data type. We'll need to convert that to a number. So let's reassign temp equal to, use the number constructor and pass in our temperature. It's assumed to be in Fahrenheit if we would like to convert to Celsius. Let's invoke the toCelsius function. I'll reassign temp equal to the toCelsius function, invoke it, and then we need to pass in our temperature. After the temperature is converted, we need to change our label. So copy this line of code, paste it, And I will set this equal to temp plus, if you're writing this code on a PC, if you need the degree symbol, one shortcut is to hold Alt, and on the numpad, press 0176. If you're on a Mac, then do this. I'll post it on the screen right now. So this temperature is in Celsius. Okay, let's test this. 32 degrees converted to Celsius is 0 degrees Celsius. If this was 50 degrees Fahrenheit converted to Celsius, that would be 10 degrees Celsius. Now with the Fahrenheit radio button, let's copy everything we have within this if statement, paste it, and we will invoke the to Fahrenheit function instead of the to Celsius function. And change the temperature from C to F. Okay, let's try this. 0 degrees in Celsius converted to Fahrenheit is 32 degrees Fahrenheit. So yeah, that was a practice project to convert temperatures using JavaScript. Hey, if you found this video helpful, please be sure to smash that like button, leave a random comment down below, and subscribe if you'd like to become a fellow bro. Well, we've finally made it to arrays. Think of an array as a variable that can store multiple values. It's a little more complex than that, but that's an easy way of thinking about them. In this example, I have a variable fruit. Fruit contains some string representation of a fruit, like an apple. I can store multiple names of fruits within this variable if I convert it to an array. So to change this variable into an array, surround all of your values with a set of square brackets and separate each value with a comma. Maybe I don't want just an apple, maybe I would also like an orange and a banana. Just so it's more obvious that this contains multiple values, I'm going to change this variable name from fruit to fruits. Well, I guess in the English language, fruit would also be plural, but it's just not obvious. So we have an array fruits. Now look what happens when I display this array using console.log. If I display my array fruits, it will display all of this junk. You can see the different values within this array. Apple, orange, banana. Each value within an array is also known as an element. If I would like to access a particular element within this array, when I use the array name, I will add a set of square brackets. Then I need to list an index number of the element I would like to access. Computers, they always start with 0. So the first element in my array has an index of 0. If I was to display fruits at index of 0, then we have access to the first element, which contains an apple. The next element, which has an index of 1, is my orange. At index 2, there's the banana. If I attempt to access an element that doesn't exist, such as index 3, well then it's undefined. You can also update and change the elements of an array. So to do that, type the name of the array, followed by an index number. Maybe fruits at index of 0 is now a coconut. And then let's display fruits. So we have a coconut, orange, and banana. If I change this to 1, we have an apple, coconut, banana. 2, apple, orange, coconut. So to access an element from an array, you type the array name, followed by a set of square brackets, and then an index number. You can later on add an element. To do that, use the push method. Type the array name, dot push, parentheses, then add a value, like a lemon. We have an apple, an orange, a banana, and a lemon. This will add an element. We can remove the last element, fruits.pop. Okay, that lemon is no longer there. Apple, orange, banana. Removes last element. We have the capability to add an element to the beginning of an array. Type the array name, dot unshift method, and add a value. Maybe a mango. Mango, apple, orange, banana. This method will add element to the beginning, and the shift method will remove the beginning element. Fruits.shift. Apple, orange, banana. That mango is gone because I ate it. So the shift method removes element from beginning. You can access the length property of an array. I'll store this within a variable. Let length equal fruits.length. And the length of my array is 3. We have 3 elements, an apple, an orange, and a banana. you can find the index of an element. Let index equal the array name dot index of method. I would like to find the index of our apple value, and I will display this. So again, computers always start with 0. The index of my apple value was found at index 0 at the beginning. Orange would be at 1. Banana is at 2. If you search for an index of an element that doesn't exist, such as, how about a kiwi? Well, then this will return an index of -1. That means it was not found. So yeah, everybody, that's an array. Think of it as a variable that can store multiple values. It's a little more complex than that, but that's an easy way to think about it. So yeah, this is the beginning on a small series on arrays. Hey, if this video helped you out, you can help me out by smashing that like button, leave a random comment down below, and subscribe if you'd like to become a fellow bro. Hey guys, in this video I'm going to show you how we can loop through the elements of an array. Maybe we have an array of prices, and I will set this equal to, and just make up some prices. It doesn't really matter. $5, $10, $15, $20. Good enough. Two popular ways to iterate over an array is one, to use a standard for loop, and the other is a for of statement. Let's begin with a standard for loop. So type for, parentheses, curly braces. We'll need to create a counter. Let I, set this equal to 0. I would like to continue this while I is less than the length property of our array, prices, prices.length. Then I will increment I by 1. I plus equals 1. During each iteration, I will display my array, prices, but we gotta list an index. So that index is I. Prices at index of I. During the first iteration, I will be 0. During the next iteration, it would be 1, then 2, then 3, so on and so forth. So after running this program, this will iterate and display the elements of my array, 5, 10, 15, 20, and it will adjust according to the size of the array. And my for loop will iterate over that price as well. Now, if you would like to iterate backwards over this for loop, here's how to do that. So I'm going to set my counter equal to prices.length, -1. I would like to continue this as long as I is greater than or equal to 0. And then lastly, we will decrement I by 1. This allows me to iterate over my array backwards. We're beginning at the end, 25, 20, 15, 10, 5. So that's how to use a standard for loop to iterate over the elements of an array. An additional option is a for of statement. We'll type for, parentheses, curly braces. We'll declare a counter. Let I of our array prices. Console.log just I. And this will also iterate over our array. But a better way of writing this, in place of our counter I, let's use a word that's more descriptive of what's within our array. Our array is named prices. An element of this array prices would be price. So let's change this to price because it's more descriptive. Console.log price. And I think people would understand that more. There, 5, 10, 15, 20, 25. So yeah, everybody, those are a couple different ways to iterate over the elements of an array. Hey, if this video helped you out, you can help me out by smashing that like button, leave a random comment down below, and subscribe if you'd like to become a fellow bro. Hey everybody, in this video I'm going to show you how we can sort an array of strings in JavaScript. Let's create an array of fruits, because I'm hungry, and add some various names of fruits. Make sure that they're not in order. Banana, apple, orange, and a mango. To display my array of strings, I can use a for of statement. We'll create a for loop, and the statement within the for loop is let fruit of fruits. Console.log fruit, singular. And here is my array of fruits. To sort this array, there's a built-in method of arrays called sort, but I'm going to reassign this to the same array. Fruits equals fruits, and use the sort method. And my fruits are now sorted in alphabetical order. If you need this in reverse alphabetical order, this is what you can do. I'm going to turn that line into a comment, copy it, paste it. We're going to do some method chaining. Add dot reverse, parentheses. and my array of strings is now sorted in reverse alphabetical order. So yeah, that's a super quick video on how to sort an array of strings in alphabetical order and reverse alphabetical order. If you would like a copy of this code, I'll post this in the comment section down below. And well, yeah, that's how to sort an array of strings in JavaScript. Hey guys, in this video I'm going to discuss 2D arrays, also known as multi-dimensional arrays. It's an array made up of arrays. So in this example, we'll create a grocery shopping list. And that grocery shopping list will be made up of separate individual lists. A list for fruit, vegetables, and meat. Let's begin by creating 3 individual arrays, and then add them all to one array to contain them. Let's begin with an array named fruit, or fruits. Let fruits equal, and think of some fruit. I'm thinking apples, oranges, bananas. This is our first array. Let's create another. I'll name this vegetables. What about carrots, onions, and potatoes? And lastly, meat, or meats. Eggs, chicken, fish. We have 3 individual arrays. If we wanted to, we could add these individual arrays into another array. I'm going to create another array. This will be our 2-dimensional array named grocery list equals, and add the names of the arrays that you would like to add. Fruits, vegetables, and meats. So grocery list is our 2-dimensional array. How can we iterate over the elements of this 2-dimensional array? We can use nested loops. I'll use nested for of loops. The outer loop will be in charge of managing each list. Let's name each item maybe list. Let list of grocery list. So right now, if I display list, it's going to display all of the individual arrays. I'm just going to test that. Console.log list. This for loop will iterate 3 times, 1 for each array within our grocery list, and it displays details of each list. To access the individual elements within each list, each array, I'm going to create a nested loop. We'll use a for of loop again. How about food, like each food item, of list. And I will display console.log each food item, each element, food. So this will display all the elements of my 2-dimensional array. Apples, oranges, bananas, carrots, onions, potatoes, eggs, chicken, fish. What if you need to change one of these elements within your 2-dimensional array? With a 2-dimensional array, there are 2 indices. To access one of these elements within a 2-dimensional array, type the name of the 2-dimensional array, and there's 2 indices. So if we take a look at the way that all of these elements are set up, it kind of resembles a grid. There's rows and columns. Picturing a grid, the first index would be the row. The second index is the column. I would like to replace apples with mangoes. I need to find the row number and the column number. So computers, they always start with 0. The first row would be row 0. And the first column would be column 0. So the indices are 0, 0. And I will set this equal to mangoes. I think that's how you spell mangoes. Yeah, after refreshing, we have mangoes, oranges, bananas. Let's replace bananas. That is row 0, column 2. 0, 1, 2. So change the second index to 2. Apples, oranges, mangoes. Let's replace eggs with steak. That would be row 0, 1, 2, column 0. Steak, chicken, fish. For my last example, let's replace fish with steak. That is row 0, 1, 2, column 0, 1, 2. 2, 2. Eggs, chicken, steak. Yeah, everybody, that's basically a 2D array. It's an array of arrays. It's useful if you ever need some sort of grid of information. We probably won't be using 2D arrays too much in the future. So yeah, those are 2D arrays. Hey, if you found this video helpful, please be sure to smash that like button, leave a random comment down below, and subscribe if you'd like to become a fellow bro. Hey everybody, in this video I'm going to explain the spread operator. It allows an iterable such as an array or string to be expanded in place where 0 or more arguments are expected. Basically speaking, when used with an array, it unpacks the elements into many individual pieces. Let me give you a demonstration. We have an array of numbers. Let numbers equals, make up some numbers, put them within this array. 1, 2, 3, 4, 5, 6, 7, 8, 9. Using console.log, if I was to display this array directly, console.log numbers, this will display the details of this array object. Now, if I was to precede my array with the spread operator, which is 3 dots, it would expand the elements of this array. We have the elements 1 through 9. Actually, you can do this with a string too. I'll give you a demonstration. Let user name equal your first and last name. So I will use the spread operator, a string. And this will spread the string into individual characters. How could this be useful? Let's say we need to find the maximum value within this array. Well, we could use the math.max method, but with the max method, it accepts a varying number of arguments. We could pass in a value, a variable, like x, y, z. Whatever the maximum is, we would return it. And we can store that within a variable. Let maximum equal math.max. So what if we stick an array in here? Math.max numbers, and then display it. Console.log maximum. What happens exactly? So this returns not a number. In place of passing this array directly to a method, we could expand it by using the spread operator. So this will unpack these elements into individual arguments. Now when I run this, we have our maximum value of 9. If I added another, like 10, well then it returns 10. So it's fantastic if you need to pass in a varying amount of arguments to a function or method. Here's another example. We're a teacher and we have 2 classes, each represented by an array of student names. I need to merge these 2 classes into one. We'll create class 1, let class 1 equal some student names. We have SpongeBob, Patrick, and Sandy. Class 2 has these students. Class 2 equals Squidward, Mr. Krabs, and Plankton. To add an element to an array, you type the array name, followed by the push method, and pass in an element. If I would like to add all of these students, you would think that I pass the array name as an argument, class1.push class2. So let me show you what happens. Console.log class1. So we have 3 students and an array. So we have an entire array as an element, which I didn't want to do. So in place of adding this class directly as an element, let's spread it into individual arguments by using the spread operator. Now when I display this array, we have 6 students: SpongeBob, Patrick, Sandy, Squidward, Mr. Krabs, and Plankton. Another way to display this is to use the spread operator. I will precede class 1 with the spread operator. Class 1 is divided into individual elements: SpongeBob, Patrick, Sandy, Squidward, Mr. Krabs, Plankton. So the spread operator allows an iterable such as an array or string to be expanded in place where 0 or more arguments are expected. By preceding an array with the spread operator, you unpack the elements. It's kind of like you're opening a box and taking out whatever's inside. So that's the spread operator. If you would like a copy of this code, I'll post this in the comments section down below. Don't be afraid to smash that like button, leave a random comment down below, and subscribe if you'd like to become a fellow bro. Hey everybody, in this video I'm going to explain REST parameters. REST parameters represents an indefinite number of parameters. It packs arguments into an array when you pass arguments to a function. Here's how using REST parameters would be useful. I have 5 different variables. I would like to sum a varying amount of these variables. Using console.log, I will invoke a sum function which we will need to declare. Let's pass in variables a and b to begin with. I need a matching function that is named sum that accepts 2 arguments. Function sum, arguments a and b. We will simply return a plus b. So this returns 3. Variables a and b are arguments. What if I would like to add another argument, like c? This specific sum function isn't suitable for 3 arguments. I would need a sum function that accepts 3 arguments this time. A, B, C. Return A plus B plus C. Then I could accept 3 arguments. But wait, what if I have to pass in another argument, like D? Well, this function no longer is suitable. I would need to create another function that accepts 4 arguments. A, B, C, D. Return A plus B plus C plus D. You can kind of see where I'm going with this. We have 3 different sum functions. If this time we need to pass in 2 again, 2 arguments, we receive not a number. We would need to give each of these functions a unique name, like sum2, sum3, sum4. But this isn't practical. Wouldn't it be better if we had a function that could accept an indefinite number of parameters? Well, we can with the rest parameters. So let's get rid of all this code. We will declare a function that will accept any number of arguments. Function sum. The rest parameters will pack these arguments into an array. So we will use the 3 dots for the rest parameters. Then we need a name for this array, like numbers. If our elements are within an array, we would just need some way to access those elements. There's a couple different ways you could do this. I'm going to create a total, let total equal 0, and we will iterate over our array. For let number of our array numbers, we will take our total, increment it by our number, and then at the end, return total. This time we can pass 2 arguments to this function, or 3, or 4, 5, doesn't matter. So that's the benefit of using rest parameters. They represent an indefinite number of parameters. When you call a function that has rest parameters, it will pack the individual arguments into an array. Then you would just need some way to access the elements of that array. You can mix and match the parameters. For example, you could say x and y. If I was to write it this way, these first 2 arguments will be x and y respectively, and any arguments afterwards would be packed into this array. If you're mixing and matching rest parameters along with some named parameters, make sure that the rest parameters take up the last parameter within this function. So yeah, that's rest parameters. If you would like a copy of this code, I'll post this to the comment section down below. If you haven't already, smash that like button, leave a random comment down below, and subscribe if you'd like to become a fellow bro. Hey guys, in this video I'm going to discuss callbacks. A callback is a function passed as an argument to another function. Using callbacks is a popular programming technique because it ensures that a function is not going to run before a task is completed. Here's an example of where a callback would be useful. Let's say we need to add 2 numbers together. Let total equal sum. Pass 2 numbers as arguments, maybe 2 and 3. I'll create a function to add these numbers together and return something. We will declare a function sum to add these 2 numbers together and set up some matching parameters to these arguments. Let's name these x and y. Let result equal x plus y. Return result. Then afterwards, I would like to display my result. One function to display the result to the console and the other to the DOM. Function display console. I'll name this argument output. Console.log output. After finding a total, we will invoke the display console function. We will pass our total as an argument. This displays the number 5 to the console. Now let's create a function to display some output to the DOM. Function display DOM. We'll keep output as the argument. However, we will change the inner HTML of an element. So heading to our HTML file, let's create a label. Close it. I'll give this an ID of my label, save, head back to your JavaScript file, and I would like to select my label. Document.getElementById. The ID of that label was my label, and I will set the inner HTML equal to the output that I receive. I will instead invoke the display DOM function. Display DOM, pass in total as an argument, and we have the number 5. Another way of writing this is that we could use a callback. We can pass a function as an argument to another function. Let's get rid of these lines. We won't need them anymore, but we will keep these 2 functions. This time, I'm going to invoke a sum function, pass in my arguments, 2 and 3, and also the name of a function I would like to execute once we finish this function. Let's invoke the display console function once we finish the sum function. So we will pass the name of this function as an argument. Just be sure not to add that set of parentheses after, because then you would be invoking that function. Just the name of the function. Next, I need to set up this sum function. This specific function will have 3 parameters. The first 2 are the numbers we would like to add together, and the third is a callback. So let's define a sum function. Function, sum, and there's 3 parameters. We'll name these x, y, and for the callback, you can really name it anything. I'll just name it callback. And again, make sure not to add that extra set of parentheses afterwards. So, callback. We'll add these 2 numbers together. Let result equal x plus y, and then we will invoke our callback. So at the end of the function, type callback. Remember that it stores a function, kind of like a variable, then add a set of parentheses. Then we'll be invoking this function. And if there's any arguments, we have 1 parameter, output, make sure to pass that in. So pass in result. Execute my callback, pass result as an argument, and this displays my output. If I would like to pivot and instead display my output to the DOM, I'll just pass in a different callback, display DOM. So we'll pivot and execute a different function, and our output is displayed to the DOM. So you don't necessarily need to name this parameter callback. We could name this maybe do something at the end of the function, do something, do some other function. Or maybe my func. This would be valid too. So remember, you can rename parameters. So using callbacks is an additional way in which we can write code. It ensures that a function is not going to run before a task is completed. It helps us develop asynchronous code. When one function has to wait for another function, it helps us avoid errors and potential problems. For example, we could wait for a file to load. Once the file loads, then we do something. We'll have more practice with callbacks in future videos. So yeah, that's a callback, everybody. You can pass a function as an argument to another function, and then execute it later. Hey, if this video helped you out, you can help me out by smashing that like button, leave a random comment down below, and subscribe if you'd like to become a fellow bro. Hey guys, in this video I'm going to discuss the for each method of arrays. The for each method executes a provided callback function once for each array element. We have an array of students. Let students equals, and make up some student names. In this example, let's make all of the letters lowercase. We'll create a function that will capitalize the first letter of each student name. So I'm going to write SpongeBob all lowercase, Patrick, and Squidward. Let's define a function that will capitalize the first letter of each string. Function capitalize. Now with the for each method, there's up to 3 arguments that are provided automatically behind the scenes that we have access to. An element, an index, and the array. We don't necessarily need to use any of these, but they're provided for us. But in this function, we will. To capitalize the first letter of each string, this is what we can write. I would like to access my array parameter at index of index equals our element at index of 0. This will select the first character of every string. Dot. Follow this with the to uppercase method plus element dot substring method. Pass in 1. This line right here will capitalize the first letter of each string. Then I will print one of these elements. Console.log students at index of 0. Now to use the for each method, we will type the name of the array, students dot for each, then pass in a callback as an argument. We will apply this callback to every element in an array. The callback is the name of the function, capitalize. Make sure to not add an additional set of parentheses. That will call the function. We're only passing the name of the function as an argument. This will display the first student, SpongeBob, and the first letter of his name is capital. Let's do this again, but create an additional function to print each student that's within my array. Function print. Up to 3 arguments are provided for us, an element, an index, and an array. We don't necessarily need to use all three. I would just like to use element. And remember, you can rename these too, such as x, y, or z, but I would do something that's descriptive. But this time we only need element. Using console.log, I am going to display each element. And again, we will use the for each method. Students.forEach, pass in our callback of print. And here we go. Yeah, SpongeBob Patrick Squidward. All right, everybody, that is the for each method of arrays. It executes a provided callback function once for each array element. So yeah, everybody, that is the for each method of arrays. If you would like a copy of this code, I'll post this in the comment section down below. And well, yeah, that's the for each method of arrays in JavaScript. Hey everybody, in this video we're going to discuss the map method of arrays. The map method executes a provided callback function once for each array element and creates a new array. Here's an example. Let's create an array of numbers. Let numbers equal 1, 2, 3, 4, 5. We're going to use the map method of this array numbers, and the map method will square each element in this array and create a new array. Let's define a square function. Function square. We need at least one parameter, element. We will return math, use the power method, pass in our element as a base, raised to the power of 2. This is our square function. We will pass the name of this function, square, as a callback to the map method. And this will create a new array, so let's define a new array. Let squares equal to, then I would like to invoke the map method of my numbers array. Numbers.map, pass in my callback of square. And then I would like to display the elements of squares. I'll do that with a print function. Function print element console.log element. And I will use the for each method of my squares array. Squares, for each method, pass in a callback of print. Let's take a look at the elements of squares. Yeah, each element from my numbers array was squared and added to a new array. Squares, 1, 4, 9, 16, 25. Hey, for fun, let's create a cube function. Function cube. We need at least an element parameter. Copy this line, but change 2 to 3. Element to the power of 3. Let cubes equals numbers.map cube. Cubes, for each method, pass in print as a callback. And all of my original numbers are now cubed and stored in a new array. Cubes. 1, 8, 27, 64, 125. So yeah, everybody, that is the map method of arrays. It executes a provided callback function once for each array element, and it creates an entirely new array. So yeah, that's the map method of arrays. If you would like a copy of this code, I'll post this in the comment section down below. And well, yeah, that's the map method of arrays in JavaScript. All right, let's talk about the filter method. The filter method creates a new array with all elements that pass a test provided by a function. We can filter out elements from an array and create a new one based on certain criteria. Let's create an array of student ages. Let ages equals, make up some student ages. 18, 16, 21, 17, 19, 90. I'm going to create a new array of anybody that's 18 or older. So I will create a function to check age. Function check age. And there is one parameter, element. This will create a new array. We will return, and now we need some test to filter out any elements that don't meet the criteria. Our test will be element is greater than or equal to 18. So we will use this check age function as a callback within the filter method. This will create a new array. So let's define that. Let adults equal ages, the original array, dot filter pass in the check age function as a callback. And then we just need to display all of the elements of this array. Adults dot for each, pass in a callback to a print function, which we'll define momentarily. Function print element console.log element. So the elements in our new array are 18, 21, 19, 90. So yeah, that's basically the filter method. It creates an entirely new array with all the elements that pass a test provided by a function. And this will leave the original array alone, but it creates an entirely new array of elements that pass a test. So yeah, that's the filter method, everybody. If you would like a copy of this code, I'll post this in the comment section down below. And well, yeah, that's the filter method of arrays in JavaScript. Hey guys, in this video I'm going to explain the reduce method of arrays. The reduce method reduces an array to a single value. A very good use of the reduce method would be to sum up all the values of an array. Imagine we have an online store and somebody has a bunch of items in their cart. We could sum up the prices of all the items and create a total. Let's create an array of prices. Let prices equals, make up some prices. $5, $10, $15, $20, $25. That's fine. And I will create a function that we will use as a callback. Function checkout. We'll call this function when we would like to check out and make a purchase. So there are at least two parameters that we need. Total, this parameter will hold the accumulated value as well as the current element that we're working with. We will return, if we're trying to create a sum of all the elements, total plus element. So when we return a value, we will reuse it as an argument for the next iteration. This is how we can reduce all the elements of an array to a single value. Let's create a total variable, and this will hold the final price that the user has to pay. To reduce all of these prices to a single value, we type the name of the array, use the built-in reduce method, and pass in the callback, checkout. Then I will just display what our total is. Console.log. I'll use a template literal for this. I will use a set of backticks. The total is total. Okay, so the total price is $75. Let's add something else. Something that is $30. Now the total is $105. So that's the reduce method of arrays. It reduces an array to a single value. A fantastic use of the reduce method is to sum up an array of values, like items in a shopping cart, and create a total. That's the reduce method of arrays. If you would like a copy of this code, I'll post this in the comment section down below. And well, yeah, that's the reduce method of arrays in JavaScript. Hey guys, in this video I'm going to show you how we can sort an array of numbers in JavaScript. Let's imagine that we're a teacher and we have a student grade book. Our task is to sort our students' grades in either ascending order or descending order. Let's begin. Let's create an array named grades and make up some student grades. I'm thinking 100%, 50%, 90, 60, 80, 70. Let's create a function that will be used as a callback to sort these numbers in descending order. So the greatest number will be first, the lowest number will be last. Function, let's name this descending sort. There's two parameters, x and y. All we have to do is return y minus x. This will compare two values at a time. To sort this array and use this callback function, I will reassign grades equal to grades.sort method and pass in a callback, descending sort. And then we just need to display our grades. Grades, I'll use the built-in for each method. And I will pass a callback of print. Then we just need to define this function. Function print, there is one parameter of element, console.log element. Now after running this, our grades are in descending order. Let's create a callback function for ascending order. So let's copy this, paste it, change descending to ascending, return x minus y. And for the callback, we will pass the argument ascending order. And our grades are now in ascending order. The lowest is first, the highest is last. So yeah, that's how to sort an array of numbers. If you would like a copy of this code, I'll post this in the comment section down below. And well, yeah, that's how to sort an array of numbers in JavaScript. Hey guys, in this video I'm going to explain function expressions. A function expression is a function without a name, also known as an anonymous function. A benefit is that function expressions help us to avoid polluting the global scope with random function names. We can write a function and then forget about it. If I need to create a function to display a greeting message using a function declaration, I would need to think of a unique function name, such as function. How about the say hello function? Console.log hello. Then to invoke this function, I just type the function name followed by a set of parentheses. Boom, we have our function. So it can get somewhat tedious and annoying to think of unique function names, especially if the rest of your program is not going to use it. Another way that we could write this is to use a function expression, and we will store that within a variable. I will use the const keyword this time. Const is just a variable that you can't change the value of later. Const greeting, and I will set this equal to a function expression. We will type function, parentheses, curly braces, and we do not need to think of a unique function name. What would we like to do? Console.log hello. Then to invoke the function stored within this variable, I just type the variable name followed by a set of parentheses to invoke it. Hello. So there was no need to think of a unique function name. We can assign an anonymous function to a variable or some other entity, which we'll discuss in the future. Here's another example. We'll create a counter. Using two buttons, we can increase or decrease our counter. Heading to our HTML file, let's create a label and two buttons. We'll need an opening label tag, close it, add a line break. I will set the ID of this label to my label. I'll add some text, just 0. We'll need two buttons, button, close it. The ID of this first button will be decrease button. The text will be decrease, and we'll need an increase button. Copy this, paste it, change decrease to increase, and we have our two buttons. If we were using function declarations, we would need to think of two unique names to link to these two buttons. Using function declarations, we would probably say something like function increase count, and we need a count variable. Let count equal 0. We will increment count by 1, count plus equals 1, and change the text of this label. So we need to select it, document.get element by ID. We are selecting my label, change the inner HTML equal to count. Then we will create a decrease count function. Function decrease count. Count minus equals 1. Lastly, we just need to link these buttons to these functions. There is an onClick event attribute. Beginning with the decrease button, take the onClick attribute, set this equal to the appropriate function. Decrease count, add a set of parentheses, copy this, paste it for increase button, and we will select the increase count function. Let's save and run this. So with this label, we can increase it and decrease it. However, I think this would be better with function expressions. We don't need to declare two functions, such as increase count and decrease count. We can assign some function expressions to these buttons and then simply forget about them. I'm going to get rid of both of these functions, and we will create some function expressions. Let's select this increase button. I'll just copy what we have here. Increase button dot on click. Set this equal to a function expression. What would we like to do? These two lines of code. Increase count by 1 and change our label. Let's copy this function expression, paste it, do the same thing but with the decrease button. Decrease button, decrement count by 1, and change our label. We can get rid of this previous code. Let's save. Heading back to our HTML file, we can also get rid of these onClick event attributes. Okay, save everything, and this should work. We can increase our label and decrease it, and there is no need to create two unique function names. We were able to assign function expressions to the event attribute of an HTML element. So those are function expressions. If you would like a copy of this code, I'll post this in the comment section down below. Don't be afraid to smash that like button, leave a random comment down below, and subscribe if you'd like to become a fellow bro. Hey guys, in this video I'm going to explain arrow function expressions, which are represented by, well, an arrow. It's a compact alternative to a traditional function expression. I'll give you a whole bunch of examples of where this could be useful. Let's create a traditional function expression, which we learned about in the last topic. I'll create a constant greeting, and I will set this equal to a function expression. Function, we have an argument, maybe username. Console.log will display a message. I'll use a template literal. Hello. Then my placeholder, user name. So to invoke this function, I type the function name, a set of parentheses, and I have one argument, a username. I'll type in my first name, run this, and this displays hello, whatever your username is. A compact alternative to this function expression is that we could convert it to an arrow function expression. We will eliminate these things. Eliminate the function keyword. After your arguments, add an arrow. And we can eliminate these curly braces. Looks good to me. Does this still work? Yes, it does. So depending on what arguments you have, if you have no arguments, you need just a set of parentheses. If you have one argument, you don't necessarily need to enclose this in a set of parentheses. If you have two or more arguments, you do need a set of parentheses. That is one example of the arrow function. Let's try a different example. The second example will have two arguments. It will calculate a percentage. First, let's write a function expression. Const percent equals a function expression. There are two arguments, x and y. X will be the nominator, y will be the denominator, and I would like to return x divided by y times 100. Let's use console.log. I'll use a template literal for this. I would like to display, here's my placeholder. I'll invoke this function, percent, pass in two arguments, a nominator and a denominator. What is 75 over 100? Then let's add percent to the end. So 75 over 100 is 75%. What about 80 over 150? 53.3 repeating percent. In place of a function expression, let's use the arrow function. So we eliminate the function keyword, keep the arguments, add an arrow, and we can eliminate these curly braces, and we don't necessarily need this return statement. And this still works the same. What about 45 over 50? That is 90%. Here's one last exercise. We'll reuse the code on the video on sorting an array of integers. In that example, we had an array of student grades. And these are integers. One student has 100%, another has 50%, 90, 60, 80, 70. If I was using standard functions, I would write something like this. Function descending. There are two arguments, x and y. Return y minus x. And I will also create a print function. Function print. We have one argument, an element. Console.log element. To sort and display each of these elements, I will use two separate functions. Grades.sort, pass in a callback, descending, and I would also like to print. Grades for each, pass in a callback to print. So all of these grades are in descending order. If we were writing the same code using function expressions, I could stick a function expression within each of these methods. Let's turn this first function into a function expression, cut it, and paste it within the sort method. And we will do the same thing with print. Get rid of the name, cut this, and paste it. And that does the same thing, but it uses function expressions. In place of function expressions, let's now use the arrow function. We get rid of the function keyword, add an arrow after the arguments, and we can eliminate these curly braces. And we don't need the return keyword either. Let's do the same thing with the for each method to display each element. Get rid of the function keyword, add an arrow after the arguments, we can eliminate the curly braces, and that semicolon. All right, let's see if this works. I can't believe it. It actually worked. In place of function expressions, we were able to instead use arrow function expressions. It's a compact alternative to a traditional function expression. It makes your code a lot more readable. So yeah, those were a few examples of us using the arrow function. You have your arguments on one side, arrow, then some code you would like to perform. So yeah, that's the arrow function, everybody. If you found this video helpful, please be sure to smash that like button, leave a random comment down below, and subscribe if you'd like to become a fellow bro. Hey guys, in this video I'm going to show you how we can shuffle the elements of an array. This would work perfect for a card game. Let's say we have an array of cards. Let cards equal, these will be string representations of cards. We have an ace, a2. I'm not worried about the suit, but you can feel free to add a suit if you would like. I'm just going to fill in this array. Then we have a jack, a queen, and a king. So this is our array of cards. To shuffle this array, I can create a function to do that for me. Function shuffle, and there will be one parameter, an array. When we invoke this function, we need to pass an array as an argument. Shuffle our array cards. Now to shuffle this, we'll begin at the end. I need this array's length, and I will store that within a variable that we will name current index and set this equal to the array's length. We will begin at the end, and we'll need a while loop. Our condition is while current index does not equal 0. Now we'll need a random number between the beginning of this array up to the length of the array. Let's declare random index, set this equal to math.random times the array's length property. Then surround this with math.floor. Math.floor. Decrement our current index by 1. Current index minus equals 1. So I'm going to maximize this. We will begin at the end. We will swap this element with another one. During the next iteration, the previous element will be the current index. We will swap this element with another one, chosen randomly. We'll continue this process until we reach the end of our array, then stop. Then it's a matter of swapping two elements, but we'll need some temporary storage. Let temp equal array at our current index. Array at our current index equals array at our random index. Array at our random index equals temp. At the end of this function, you can return the array if you like, if you would like to reassign it. I'm going to display all of the cards, the array itself. Console.log cards. So here's our array. Every time I run this program, these elements are being shuffled. If you would like the top element, that would have an index of 0. The top card in my deck currently is an 8. Now it's a king. One trick, if you would like to deal all the cards, is that you can use the for each method of arrays. Cards.for each method, we can pass in a callback, a function expression, or an arrow function expression. I'll use an arrow function expression. We have one argument. Let's name this card arrow. I would like to display that card. Console.log card. This will deal all of the cards in my deck. And every time I run it, it's shuffled. So yeah, everybody, that's one way in which we can shuffle the elements of an array. If you would like a copy of this code, I'll post this in the comment section down below. And well, yeah, that's how to shuffle the elements of an array in JavaScript. Hey yeah everybody, in this video I'm going to explain nested functions. It's a function inside of another function. Think of the topic on nested loops. It's a loop inside of another loop. Outer functions have access to inner functions. Inner functions are hidden from outside the outer function. They add data security and they're used in closures, which is a future video topic. So let's begin. We'll use traditional functions and then create some nested functions. I have two variables. Let username equal some username and a variable to hold the amount of messages that I have, like an inbox. Let user inbox equal 0 or some other number. I'm going to create a message to log in like we're logging into our email. Function login. I'll create a function to display our username. Function display user name. And another function to display our inbox. User inbox. When I display my username, let's use console.log. I'll use a template literal. Welcome. I'll add a placeholder. User name. With the display user inbox function, we will display how many messages we have. You have, add a placeholder, user inbox, new messages. After logging in, I would like to invoke these two functions, display username and display user inbox. And we need to invoke the login function as if we were logging in. Welcome, bro, you have 0 new messages. Now, a problem with this, we have access to the display username function as well as the display user inbox function from outside of the login function, meaning that we don't need to log in order to display our username and our inbox. So I can invoke these functions directly, display username, display user inbox, and there's no need to even log in. Welcome, bro, you have 0 new messages. To add a little bit of data security, I could place these functions within another function. So in order to access the display username function, I need to first log in. And the same thing goes with the display user inbox function. If I attempt to invoke these functions when they're nested, I don't have access to them. It adds some security. In order to invoke these functions, I first need to log in. So we'll invoke the login function, and then we have access to the display username function and the display user inbox function. So yeah, those are nested functions. They're functions inside of other functions. The outer function has access to inner functions. Inner functions are hidden from outside the outer function. It adds some data security, and they're also used in closures, which is a future video topic. So yeah, those are nested functions. If you would like a copy of this code, I'll post this in the comment section down below. And well, yeah, those are nested functions in JavaScript. Hey guys, in this video I'm going to explain what a map is. A map is an object that holds key value pairs of any data type. Here's an example. We have an online store. We can associate prices with items. Constant store equals new map. Add a set of parentheses, a set of square brackets, and within the square brackets we can create key value pairs. Add each key value pair to a set of square brackets and separate each pair with a comma. The first value is the key. The first key value pair is a t-shirt, and the associated value is 20 for $20. This is one pair in my map object. Let's create another. My second pair are jeans. They go for about $30 maybe. The third pair in my map are socks. I'll sell them for $10. And what about underwear? They're expensive. They're $50. They're very good underwear. Okay, here is my map object. It's named store. To iterate over the pairs in my map, I can easily do this using the for each method. So type my map name dot for each. I can pass in a callback, a function expression, or an arrow function expression. I'll use an arrow function expression. We have two parameters, a value and a key. Arrow. I would like to display my key value pairs. Console.log. I'll use a template literal. I'll add a placeholder, key, and each value, and I'll add a $sign. So this is what I have currently. This line will iterate and display each pair of my map. And here is each pair. It's kind of like I'm listing all the items in my store. If I need to get one of these items, like I would like to make a purchase, there is a get method. I'll create a variable to store the prices that are going to add up. Let shopping cart. I'll set this equal to 0. If I would like to buy one of these items, there's an associated price. And I just need to access this value. So I will take shopping cart and increment it. To access one of these values, I will type the name of the map, store, get, and then a key. I would like to buy a t-shirt. So I will get my t-shirt, and let's display our shopping cart. Console.log shopping cart. Currently, our shopping cart is 20. We have to pay $20. I would like to add another item. I want some of that fancy underwear. Store.get underwear. My total is now $70. $20 plus 50. So that is the get method. Here's a few other methods. There's a set method. We can add a pair to our map. Store.set. I would like to add a hat, and the price is $40. It's an expensive hat. It's Gucci. Now, when we iterate over this map, we have a t-shirt, jeans, socks, underwear, and a hat. That is the set method. We can delete a pair. Store.delete. Type in the key, hat, and our hat is gone. We can check if there's a key within our map. Type the map name, has, and pass in a key. Do we have any hats? This will return a Boolean value, so I'm just going to place this within a console.log statement. Do we have any hats? Store has hat. False. Store has underwear. That's true. That is the has method. And the last one I'll show you is the size property. Type the map name, store.size. I'll put this within console.log. And the amount of pairs within our map is 4. So yeah, that's a map, everybody. It's an object that holds key value pairs of any data type. You can associate a key with a value. One example that we covered is if we had an online store, we could associate products with prices. So those are maps, everybody. Hey, if you found this video helpful, please be sure to help me and smash that like button, leave a random comment down below, and subscribe if you'd like to become a fellow bro. Alright guys, we have finally made it to object-oriented programming. An object is a group of properties and methods. Properties are what an object has, like a name, a color, a year. Methods are what an object can do. For example, if we're creating a car object, 2 possible methods could be drive and brake. So let's create some car objects to begin with. I'll create a constant car, and this is how we can create an object. Within a set of curly braces, we can create some properties, which are kind of like variables. This car has a model property, and we can assign a value. This car is a Mustang. Separate each property with a comma. Let's create a color property. The color could be red, and a year. The year is 2023. We can also add some functions too. I'll create a drive function. So create a function name, colon, function, parentheses, curly braces. When we invoke the drive function, we can do something. I'll display a message. Console.log, you drive the car. Let's create another function. This will be the brake method. So function, parentheses, curly braces, you step on the brakes. And there we go, we have a car object. Within a set of curly braces, you can assign properties and methods. And then at the end, make sure you don't have a comma. An object can have properties, what an object has, like a model, a color, and a year, and methods, what an object can do. This car can drive, and it can brake. To access an object's properties and methods, follow the object name with a dot. If I need access to the model of this car, I would type the object name, car, dot, model. And I will display this within console.log, but you can assign it, change it, do whatever you want with it. This statement displays Mustang. If I need the color property, I would type the object name, dot color, which is red. Car dot year is 2023. If I would like to invoke one of these methods found within my car object, I would type the object name followed by the method I would like to perform. Car dot drive, add a set of parentheses to invoke it. You drive the car. Then we have car dot brake. You step on the brakes. We can create multiple objects, each with different properties and methods. One way to do this, we haven't discussed classes or constructors yet. We could just create a new name, and we'll rename car as car1. So we have two different car objects. But I'll change the properties of car2. We'll keep drive and brake the same. This will be a Corvette. The color is blue, and the year is 2024. So this car is named car2. In order to access this car's model, I would type the name of the object, car2, car2.model, car2.color, car2.year, car2.drive, car2.brake. We have a Corvette. The color is blue. The year is 2024. When we invoke the drive method, you drive the car. The brake method displays you step on the brakes. So yeah, those are objects. It's a group of properties and methods that have a name. Properties are what an object has. Methods are what an object can do. They're functions that belong to an object. To access properties and methods of an object, you use a dot following the object name. So those are objects. If you would like a copy of this code, I'll post this to the comment section down below. If you haven't already, please be sure to smash that like button, leave a random comment down below, and subscribe if you'd like to become a fellow bro. Hey yeah everybody, in this video I'm going to explain the this keyword. All it is a reference to a particular object, but it depends on the immediate context where you use the this keyword. Here's an example. I have two objects, car1 and car2. Car1 is a red Mustang, car2 is a blue Corvette. Each has a similar drive function. You drive the car. In place of the word car, why don't we replace the word car with the model of each car object? I'm currently using a template literal. I could insert the model of my car. We'll create a placeholder. This is what happens if I just type model. You think this would work because this is like a variable, right? And let's do the same thing with car2. I will invoke these two methods, car1.drive and car2.drive. Okay, we ran into an error. Model is not defined at object drive. Within an object, if I would like to use one of these properties, I would need to precede this property with the this keyword. In place of model, I would type this.model and do the same thing with car2, this.model. Let's run this again. You drive the Mustang, you drive the Corvette. This refers to the object that we're currently working with. The immediate context within this object, the immediate context of this is car1. In this other object, the immediate context of this is car2. Within an object, when using the this keyword, just imagine that we're replacing this with the object name, car1.model and car2.model. This would do the same thing. So this is just a reference to the object we're working with. Let me show you what happens if I use the this keyword outside of any objects. I will console.log this. So what the heck is this? We're actually within the context of a window object. If you use the this keyword outside of any objects that you declared, well then this refers to instead the window object, because that is the immediate context. And I can change one of these properties if I wanted to. Let's change this name property. I would type this dot name equals my cool window. So I can run this. Let's find that property. There's my name property, my cool window. If I would like to access this property directly, I would follow this with dot name, my cool window. So that's the this keyword, everybody. It's a reference to a particular object. Just imagine that we're replacing the keyword this with the name of an object. Hey, if you found this video helpful, please be sure to smash that like button, leave a random comment down below, and subscribe if you'd like to become a fellow bro. Hey yeah, everybody. In this video, I'm going to explain classes. A class is a blueprint for creating objects. Within a class, we can define what properties and methods that type of object should have. And they typically contain a constructor to assign some unique properties, but we're going to focus on constructors in the next video. I had some trouble brainstorming some possible class ideas that wouldn't utilize a constructor, but one that I thought of could be a player. We can create a player class as a blueprint and create some player objects. So to create a class, we will type class player curly braces, and we can define properties and methods that all player objects will have. It's a blueprint. Maybe each player has their own individual score, and I will set this to 0. Each player will start at 0. Each player has a pause method. Now, when you declare a method within a class, you don't necessarily need that function keyword. When a player pauses, we will display a message. Console.log, you paused the game. And maybe an exit method. Console.log, you exited the game. Now, to utilize this class to create an object, we would need an object name. Let's say constant player1. This will be the first player that joins. Now, to utilize this class to create a player object, we use the new keyword followed by the name of the class, player. Add a set of parentheses and a semicolon. We have created player1. Player1 has a score property and 2 methods, pause and exit. Let's display what player1's score is. Console.log player1.score, and that is currently 0, but you can adjust its score. Player1.score plus equals 1. He scored a point. Player1 now has 1 point. Player1.pause method, you pause the game, and player1 can exit. Player1.exit. You exited the game. We can reuse this class to create multiple players. I'll create player2. Constant player2 equals new player. I'll display player2 score. And we will have player2 exit the game. Player1 has 1 point, player2 has 0 points. Player1 invoked the pause method, player2 invoked the exited method. You can keep on reusing this class as much as you would like. This time I would like 4 players. So same process as before. Declare a unique object name. Set this equal to, use the new keyword, the name of the class. That's a class. It's basically a blueprint for creating objects. We can create as many objects as we want. And within this class, we define what properties and methods that each object created from this class should have. And in the next video, we're going to discuss constructors, so we can assign some unique properties to each object. So those are classes. Hey, if you liked this video, let me know by smashing that like button, leave a random comment down below, and subscribe if you'd like to become a fellow bro. All right, everybody, constructors. A constructor is a special method of a class. Its job is to accept arguments and assign properties, or anything else you would like to do when you instantiate an object. Let's create a student class. Class student. To create a constructor, we will type constructor, parentheses, curly braces. Now, when we create an object, a student object in this example, we can assign some properties. Each student has a name, an age, and a GPA. Within the constructor, we can assign some of these arguments to properties of this class. We can state this dot name equals name, this dot age equals age, this dot GPA equals GPA. There we go, there's our constructor. You can also add additional properties or methods outside of the constructor. Let's add a study method. Study. Let's display, I'll use a template literal. This dot name is studying. Okay, let's create some student objects. We can use var, let, or const. I'll use const. Student1 equals new student. Within our constructor, we have 3 parameters. That means that we need to pass 3 arguments, a name, an age, and a GPA, so that we can assign these properties. The first student will be SpongeBob, that's his name. His age, he'll be 30, and his GPA, he has a 3.2 GPA. And I can display these. Console.log student1.name. His name is SpongeBob. Age and GPA. SpongeBob, his age is 30, his GPA is 3.2. And for fun, let's invoke the study method. student1 dot study. SpongeBob is studying. Now we can reuse this class as a template to create other students and pass some unique arguments to assign to its properties. Let's create student2. Student2 equals new student. This student's name will be Patrick. He will be 35 years old. His GPA is 1.5. And we have access to student2's properties and methods. Student2.name, age, GPA, and he has his own study method. Okay, Patrick is 35, his GPA is 1.5, and Patrick is studying. We can reuse this class to create as many students as we like. So lastly, let's create one last student, student3. Student3 will have a name of Sandy. Sandy will be 27, and Sandy's GPA is of course a 4.0. Student3 has its own unique properties and methods, a name, age, GPA, and study method. We have Sandy, she's 27, her GPA is 4.0, and she has her own study method. Sandy is studying. So that's a constructor. It's a special type of method within a class. It accepts arguments and assigns properties when you construct an object. So those are constructors. Hey, if you haven't already, please be sure you smash that like button, leave a random comment down below, and subscribe if you'd like to become a fellow bro. Hey guys, in this video I'm going to explain the static keyword. A member that is static, whether it's a property or a method, belongs to a class, and not any objects created from that class. In this example, I have a class car and a constructor. When we create a car object, we can pass in a model of a car. So I have 3 car objects. Suppose I would like to keep track of how many cars I have created. We're entering some cars into a race. Well, we could create a property to keep track of how many cars that we have instantiated. Let me show you why we would want to make this static. So we have a property, number of cars, and I will set this equal to 0. Within the constructor, we can add additional code. Every time we create a car, let's increment cars by 1. Number of cars plus equals 1. Now I will precede number of cars with the this keyword. So what happens when we display number of cars for each car? Console.log car1.number of cars, car2, car3. So the total number of cars within our race is 1, I guess. So the reason why number of cars isn't 3 is because each car object has their own number of cars variable. Each car object can share the same property or method, and we would precede that property or method with the static keyword. Instead of each car having their own copy, the car class itself has the only copy. Then to increment number of cars by 1, in place of the this keyword, I will use the name of the class, car. The car class's number of cars will be incremented by 1 every time we call the car constructor. There's a problem here. I'm accessing the number of cars property, but no one object from this class has ownership of this variable. To access the static property of number of cars, I will use the name of the class, car. Car.number of cars. How many cars have we created? We have created 3 cars, and I could create another. Car 4 is a Ferrari. Now we have 4 cars, or even 5 cars. A static property is useful for caches or anything with a fixed configuration. We also have the capability to make methods static. It's more or less useful for utility functions. Now we would like to start our fictional race. We could create a start race method. Start race. Console.log 3, 2, 1, go. So currently this is not static. So any one of these cars can begin the race on their own terms. Car 1 wants to begin the race. Start race. 3, 2, 1, go. So I'm going to make this a static method. It's more or less a utility function. So precede the method name with static. Now to invoke this start race method, type the name of the class, car. Car.startRace. 3, 2, 1, go. Basically, that's the static keyword. Anything that's static belongs to the class and not the objects. One place where we do see static methods is within the math class. Say I need to round. Math, the name of the class, dot, round method. I wouldn't need to create a math object such as const math1 equals new math. That would be silly. To access the round method, I would just type the name of the class, dot round. It's a static method. That's the static keyword, everybody. If you would like a copy of this code, I'll post this to the comment section down below. And well, yeah, that's the static keyword in JavaScript. Hey, yeah, everybody. In this video, I'm going to explain inheritance. Inheritance is when a child class can inherit all the methods and properties from another class. How is this useful? Let me give you a demonstration. Our job is to create 3 classes. A class for rabbits, fish, and hawks, 3 specific kinds of animals. So we have class rabbit. Each rabbit will have a Boolean variable called alive, and I will set this to true. If you're a rabbit object, you're alive. And a name equal to rabbit. Each rabbit should be able to eat. Console.log. I'll use a template literal. This, add a placeholder. This dot name is eating. And all rabbits should be able to sleep. Sleep. This dot name is sleeping. And one more. How about run? Run. This dot name is running. This is our rabbit object. So let's copy this class, paste it, and convert the second class to fish. Alive will remain true. Name will be fish. Eat and sleep will remain the same. But fish, they don't run, well, because they don't have legs. They will instead have a swim method. This dot name is swimming. Copy all this code, and we will create a hawk class. This will be the last class. Class hawk. Name is hawk. Hawks will be able to eat and sleep. In place of a swim method, they will have a fly method. This dot name is flying. We have 3 separate classes, rabbit, fish, and hawk. But with programming, we don't like to repeat code, and we're repeating quite a lot of code within each of these classes. Each class has an identical eat and sleep method, as well as an alive Boolean variable. So to eliminate the need for us to repeat some of this code, we can simply create a class, and all of these individual animal classes can inherit some properties and methods from that one class. So what do all of these classes have in common? An alive Boolean variable and an eat and sleep method. So why don't we create a separate class, and each of these classes will inherit from that one class. This will be a parent class. Rabbit, fish, and hawk will be children classes. So let's create class animal. That's descriptive of what they all have in common. Class rabbit will extends the animal class. Rabbit is the child class, animal is the parent class. Do the same thing with fish and hawk. Any properties or methods that all of these classes have in common, we can put within the parent class. They each have an alive property set to true. We can eliminate that for each class and stick it within the parent class. There's no need to repeat this variable each time. They each have the same eat and sleep methods. We can copy those, paste it within the animal class, and then eliminate each of these methods within the children classes. So any properties or methods that are unique to these children classes, you should keep within the children classes. Rabbit inherits these properties and methods from the animal class. Fish does the same as well as hawk. And you can see that we eliminated a lot of lines of code. There was no need for us to repeat ourselves. Let's create some animal objects. Const rabbit equals new rabbit. Fish equals new fish. Hawk equals new hawk. Let's test to make sure that each of these children classes does in fact have access to these properties and methods. Rabbits should have an alive Boolean variable. If you're a rabbit, you're alive. Congratulations. It's console.log rabbit.alive. That is true. Even though within the rabbit class we didn't write an alive Boolean variable within the rabbit class itself, it inherited one from its parent. And I bet rabbits can also eat. I bet they can sleep. And they can run. Yep, the rabbit is eating, sleeping, running. So let's test this with fish. Fish.alive, fish.eat, fish.sleep. What would happen exactly if I attempt to invoke the run method of fish? Fish.run is not a function. So this run method belongs to the rabbit class. Fish don't have a run method, but what they have in common are those eat and sleep methods. Fish do have a swim method, So the fish is eating, the fish is sleeping, the fish is swimming. And let's test hawk. Hawk.alive, hawk.eat, hawk.sleep, hawk.fly. Okay, true. This hawk is eating, this hawk is sleeping, this hawk is flying. So that's inheritance, everybody. A child class can inherit all of the properties and methods from a parent class. If you have multiple classes that all have the same properties and methods, you could stick those properties and methods within a parent class, and there's no need to repeat those properties and methods if they're identical. Not only does this eliminate repetition when you're coding, but if you need to make any changes to one of these methods, it's all in one place. If my boss says I need to change the eat method to this.name is eating to hunting, I just have to make this change in one place. If we had an eat method within each of these classes, I would have to go to each individual class and make that change manually. It's not bad if there's 3 classes, but imagine if you had hundreds. That would be a lot of unnecessary work when you could just make that change in one place. So that's inheritance, everybody. If you would like a copy of this code, I'll post this in the comment section down below. If you haven't already, please be sure you've smashed that like button, leave a random comment down below, and subscribe if you'd like to become a fellow bro. Hey guys, in this video I'm going to explain the super keyword. The super keyword, when using inheritance, refers to the parent class. It's commonly used to invoke the constructor of a parent class. Here's an example. I have 3 children classes, rabbit, fish, and hawk. They all inherit from the animal parent class. Suppose we have a constructor within each of these child classes. Constructor. Rabbits will have these 3 properties: a name, an age, and a run speed. So to assign these properties, when we instantiate a rabbit object, we could assign this.name equals name, this.age equals age, and this.run speed equals run speed. I'll copy this constructor, paste it within the fish child class. Fish, well, they don't have a run speed, but they will have a swim speed property. Swim speed. This swim speed equals swim speed. Let's copy our constructor, paste it within hawk, change swim speed to fly speed. This fly speed equals fly speed. Let's create some of these objects. Const rabbit equals new rabbit. We have to pass in 3 properties: a name, an age, and a run speed. For the name, we'll say rabbit. Age, 1 for 1-year-old. And a run speed of 40 kilometers per hour. I don't know if that's accurate, I just made up a number. Okay, let's create a fish object. Fish equals new fish. The name is fish. The age will be, I guess, 2. Swim speed, 80 kilometers per hour. Okay, then we have hawk equals new hawk. Pass in a name, hawk, and age, maybe 3, and a fly speed, 200 kilometers per hour. Just to test everything, I'm going to display my rabbit's name, age, and run speed. Rabbit.name, rabbit.age, and rabbit.run speed. Okay, let's take a look. What the heck? So we encountered an uncaught reference error. Must call superconstructor in derived class before accessing this. So if we have any children classes, and those children classes have constructors, we would want to invoke the constructor of a parent class. One of the reasons why this would be useful is that within each of these constructors, we're repeating some code. This.name equals name, and this.age equals age. But the run speed, swim speed, and fly speed are all unique to each of these classes. To promote code reusability, we can call the constructor of a parent class to assign the name and age properties. So within the animal class, I will create a constructor. We will have a name and age property, and then we'll assign them. This.name equals name. This.age equals age. We can eliminate these 2 lines, and when we construct a new rabbit object, we will first invoke the superconstructor. So you type super, then pass your arguments to the superconstructor. We will pass our name and age, and we can do this with the other constructors. This eliminates some code repetition, and this should work. So we have our rabbit, we have our name, rabbit, age is 1-year-old, and the speed is 40 kilometers per hour. Let's try this with fish. Fish.name, fish.age, fish.speed. swim speed. The name of this fish is fish. This fish is 2 years old, swim speed of 80. And in our last example, we have hawk. Hawk.name, hawk.age, hawk.fly speed. The name is hawk. This hawk is 3 years old and has a fly speed of 200 kilometers per hour. So the super keyword refers to a parent class. It's commonly used to invoke the constructor of a parent class. It helps with code reusability. We could write this code once and simply reuse it by invoking the superconstructor of the parent class. Then if any class has any unique properties, you can assign those unique properties within the constructor of each of these child classes. So that is the super keyword. It just refers to the parent class. If you would like a copy of this code, I'll post this to the comments section down below. And well, yeah, that's the super keyword in JavaScript. Hey, yeah, everybody. In this video, I'm going to explain getters and setters. Let's begin with getters. To create a getter, you use the get keyword. Its job is to bind an object property to a function when that property is accessed. Here's an example. Let's create a class car. Class car. I'll create a constructor. Constructor. We'll have one parameter, power. This will be in horsepower. This dot power equals power. When I create a car object, let car equal new car. I will pass in a unit for power. This will be in horsepower. 400 horsepower is good. Then I will display this console.log car.power. My car has 400 horsepower. One thing I don't like about how my code is written is that when I'm displaying the car's horsepower, there's no unit of measurement. When I display this property, I could add on car.power plus HP for horsepower, but I have a better idea. Let's use a getter. When we get this property, we can add some additional logic. I will type get, the name of the property, power, parentheses, curly braces. When we access this property, we will instead invoke a function. We will return this dot power. Now there's a couple issues with this. When I run this, first we have a type error. Cannot set property power of car. The property name and the getter cannot have the same name. A common naming convention with properties of objects, if you have getters and setters set up, is that you take the property name and precede it with an underscore. This lets other developers know that this is a protected property and you probably shouldn't mess with it. Now if I run this, we have another issue. Uncaught range error, maximum call stack size exceeded. That's because when we invoke this getter, we're returning this dot power. Again, we're invoking the getter method from inside of it. We will instead return this dot underscore power. Underscore power is the protected property. Now when I run this, it displays my number, 400. By associating a protected property with only a getter, this protected property is read-only and not writable. If I was to take car.power and set this to like a gajillion, and I display my car's power, well, it's still at 400. We do not have direct access to this property. I mean, theoretically, you could set car.underscore power to a gajillion, but developers know that if you see underscore then a property name, that means it's protected and you shouldn't mess with it at all. Another thing that we can do with getters is that we can add some additional logic. Instead of just returning this dot power, let's add horsepower to the end. I'll place this within a template literal and add HP for horsepower. So when I display my car's power, it's 400 horsepower. So that's a few benefits of getters, is that 1, it increases data security, and 2, you can perform some additional logic when you access a property directly. To use a getter, you type the object name followed by the getter name. It appears to be no different from accessing that property directly. We don't need to invoke a power method. You just type power as if it's a property. Let's create a protected property for gas. Within my constructor, I'll set this dot underscore gas to some amount of gas in liters. Perhaps we're selling cars and each car will have 25 liters of gas to start with. Then to display my gas, I can use a getter. Get gas, return this dot underscore gas. The unit of measurement will be liters. Let's display my car's power and its gas. 25 liters. Let's add some additional logic. Along with the gas level, I would like to display the percentage of what my tank is at. So 0% would be empty, 100% would be full. I'll return a template literal. What about this dot underscore gas divided by maybe some max tank size, like 50 liters, times 100%. If my gas level is at 25, well then my tank is half full. And I can change this to a different number, like 50. Now my tank is completely full. Or it's empty. Now let's work on setters. Setters bind an object property to a function when that property is assigned a value. With my power property, I don't want anybody to mess with that. That's why I only have a getter. But with the gas level, I would encourage people to change the gas level. They would want to be able to fill their tank. I'll create a setter, set gas. We'll need some argument. I'll name this value. To fill my car with gas, I can take this dot gas property equals value. Since gas has a setter, that means it's writable. I'll take my car's gas property and set this equal to some value as if I'm filling the tank. Currently, there's no additional logic within this gas setter. A user could theoretically add like a kajillion liters of gas. Now my gas is like 2 billion% full. I might want to limit that. I'll check to see if our value that we receive is greater than maybe 50. So that will be the max tank size. If the value is greater than 50, then let's set value equal to 50 to limit it. If we attempt to add over 1 billion liters of gas, it will be capped at 50. Or possibly somebody will set this to a negative number, negative 100 liters. Else if value is less than 0, value now equals 0. There, now our tank is empty. So yeah, everybody, those are getters and setters. They bind an object's property to a function when that property is accessed, in the case of a getter, or assigned a value, in the case of setters. So those are getters and setters, everybody. If you would like a copy of my code, I'll post this in the comment section down below. And well, yeah, those are getters and setters in JavaScript. Hey guys, in this video I'm going to show you how we can pass objects to a function as an argument. I have a class car, and we have 3 car objects. Each car has a model, year, and color. How could passing objects to a function be useful? I need a function to display all of the information for each car. So let's create a function. Function, and we could name this display info. If we're accepting an object as an argument, we need a matching set of parameters. I think we should just name it simply car, all lowercase. Remember, when you pass an object to a function, the parameter name is kind of like a nickname that you're giving it temporarily. Then to invoke this function, I will type the function name, display info, and pass a car object as an argument. I would like to display car1's info. Within this function, let's display this car's model, year, and color. Car.model, year, and color. Okay, let's see if it works. Yeah! With this car object, the model is a Mustang, the year is 2023, the color is red. We can pass a different object as an argument this time. How about car2? Display info, car2. Car2 is a Corvette, the year is 2024, and the color is blue. Then car3 is a Lambo, the year is 2022, and the color is yellow. Let's create another function to maybe change the color of a car, and we will have 2 parameters. Function change color. We will accept a car object and a color. We will take car.color, set this equal to whatever color we receive as an argument. Let's change the color of our Lambo. So I will invoke the change color function, and I will pass in 2 arguments, a car and a color. Car3, and let's change the color to gold, and then display it. And the color of our Lambo is now gold and not yellow. That's how to pass an object to a function. When you invoke a function, just pass the name of an object as an argument, and with the parameter name, just find a name of what's descriptive of what you're accepting as an argument. So that's how to pass objects as arguments. If you would like a copy of this code, I'll post this in the comment section down below. If you haven't already, please be sure to smash that like button, leave a random comment down below, and subscribe if you'd like to become a fellow bro. Hey guys, in this video I'm going to show you how we can create an array of objects in JavaScript. I have a class car, and we have 3 car objects. Car1, Car2, Car3. Each car has a model, year, and color, as well as a drive method. Let's come up with a descriptive name of this array. What about cars? Then with creating arrays, you use a pair of straight brackets, What would we like to add to this array's elements? Well, the names of our objects, car1, car2, and car3. Let me show you what happens when we display one of these elements. Console.log, type the name of the array, followed by an element number. The first element has an index of 0, because computers always start with 0, and we have our car object. But if you need one of these properties or methods, you would follow the array name and the index number, dot, and then a property or method. So at index 0 of our array cars, I would like to access the model property. The first element of this array has a model property of Mustang. If I were to repeat the process for cars at index of 1 and 2, those respective models are a Corvette and a Lambo. If you need to access a property or method of an object that's within an array, you type the array name, an index number, followed by dot, then a given property or method. Just for practice, let's invoke the drive method of each of these cars. So I would type the array name, an index number, follow it with a dot, then a property or method. I would like the element at index 0 within this array to use the drive method. Let me get rid of these lines. Okay, you drive the Mustang. Let's do that with the other elements, 1 and 2. You drive the Mustang, you drive the Corvette, you drive the Lambo. Just as a challenge, let's create a function that will loop over the elements of this array and invoke the drive method of each element. We're going to have a race. We need a function to start our race and have every car use its drive method. So I will create a function. Let's name this start race. Say that we need to pass our array of objects as an argument. We'll need a matching set of parameters. I will name this parameter cars, and I would need to loop through all of the elements within this array. I can use a for of loop for that. Let's say const car of cars. Car is the current element. I need each car to use its drive method. Then we need to invoke this function. Start race, then we can pass in our array of objects, cars. You drive the Mustang, you drive the Corvette, you drive the Lambo. Hey, let's add another car. Car 4 is a Ferrari. The year is 2025. The color is white. So let's add this object to our array. Car 4. Now we have 4 cars in our race. You drive the Ferrari. So yeah, that's an example of an array of objects. It's a useful programming technique because you can keep all objects organized within an array. So that's an array of objects. If you would like a copy of this code, I'll post this in the comment section down below. If you haven't already, please be sure you smash that like button, leave a random comment down below, and subscribe if you'd like to become a fellow bro. Hey guys, in this video I'm going to explain anonymous objects. They are objects without a name. A benefit is that using anonymous objects requires less syntax, and there's no need for unique names. However, a downside is that we do not have direct access to one of these objects. So here's an example. We're going to create an array of cards. Each card will be an object, which we'll create with a class. Class card. I'll add a constructor. Each card will have both a value and a suit. This dot value equals value. This dot suit equals suit. Suppose I would like to make a card. Normally, if we're using names, not anonymous objects, I would declare a unique name like let card1 equal new, then the name of the class to instantiate an object, card. For this object, I need to pass in a value and a suit. This card will be the ace of hearts. A, the second argument will be hearts. I'll create a couple other cards. Card 2 will be named, well, card 2. Card 2 will be the ace of spades. Card 3, ace of diamonds. Card 4 will be ace of clubs. I'll just create 4 more cards. I'll copy all of this, paste it. We have cards 5, 6, 7, 8. These cards will be 2 of hearts, 2 of spades, 2 of diamonds, and 2 of clubs. I'll just stick with 8 cards for this example. I don't need a whole deck of 52 cards to explain this. So we have 8 cards. I'm going to add them to an array. Let cards equal, we'll add card 1, card 2, and the others. That's good enough. To access one of these properties of one of these cards, I can either do so directly by the object name or by an array element. So if I were to display console.log card1.value plus card1.suit, this would display ace of hearts. Or I could access this object indirectly via the array. That would be my array cards at index of 0 dot value plus cards at index of 0 dot suit. This would do the same thing. With this first statement, we're accessing this object directly by its name. In the second statement, we're accessing this object indirectly via an array index. You know, this does in fact work and all, but I would write this a different way. There's no need to create all of these unique names. That's a lot of work. If we were to rewrite this using some anonymous objects, this is what we can do. We'll get rid of everything before the new keyword. We've created 8 cards, but we have no way to reference them. In place of adding some object names directly to our array, when we instantiate a card object, we can actually place that within the array. We'll add a new card with these properties, and that will be the first element. Then let's add the others. I'll speed up the footage. This would do the same thing. However, we have a reference error. Card 1 is not defined. So there is no card 1 anymore. My interpreter doesn't know what the heck card 1 is. That's because we never declared it. So using anonymous objects, we have no way to directly access these objects by a name because, well, they don't have one. In order to access the properties of an object, I would need to do so indirectly. Since these objects are within an array, I can reference them by an index number. Cards at index 0 would be the ace of hearts. Cards at index of 1 is my ace of spades. And then 7 is my 2 of clubs. So you can see that this still works, and it's a lot less syntax. Sometimes it would be impractical to give an object a name if you're never ever going to reference it directly. For fun, let's display all of the cards within this deck using the for each method. Cards.forEach. We will take card as an argument, arrow function, console.log. I'll use a template literal. Let's take card.value and also display card.suit. There. Here are all the cards of my deck displayed. So yeah, everybody, those are anonymous objects. They're just objects without a name. You don't need to declare a name to create an object. Names are just used as a reference, as storage. The downside is that you don't have direct access to an anonymous object. You would typically store them within something, like an array. And some benefits is that there's less syntax, it reduces the size of your code, and there's no need to create some unique names. So those are anonymous objects, everybody. If you would like a copy of this code, I'll post this in the comment section down below. And well, yeah, those are anonymous objects in JavaScript. Hey guys, in this video I'm going to explain error handling. Errors are objects with a description of something that went wrong. Encountering an error will halt the execution of your program. We would like some way to gracefully handle these errors without interrupting our program. Errors can happen for one of a few reasons. A few examples would be you can't open a file, you lose connection to a device, a user types in some incorrect user input, or a type error. One example of type error is that we mistype something. Instead of saying console.log, maybe we misspell log as leg, console.leg. Well, we encountered an uncaught type error. Console.leg is not a function. If an error happens while your program is running, it can cause your program to stop. We would like to gracefully handle these errors, and one way to do that is to surround any dangerous code with a try block. Code that could cause an error is considered dangerous. Accepting user input is almost always dangerous because you don't know what they're going to type in. So let's create a try block and add some dangerous code. Now, if you have a try block, you need to follow this with a catch block. And there's one argument, an error. If something goes wrong, we will do something else. In fact, I will display whatever our error is. Console.log error. Again, if I type console.leg, well, this won't interrupt my program. It will simply just display the error. Type error console.lag is not a function, so we don't get that big nasty red error message. Sometimes in your program, something will go wrong, but it won't generate an error. Here's an example. Let's accept some user input. We'll ask a user to type in a number. Let's declare variable x. X equals window.prompt. Enter a number. When we accept user input, it's of a string data type. We'll need to convert that to a number. Okay, at the end, let's display a message. Console.log. I'll use a template literal. X is a number. Okay, let's run this. Enter a number. Well, pizza is my favorite number. I'll enter that in. So even though this didn't cause any errors, it's definitely going to cause problems for me in my program. Something is going to go wrong. Using this throw keyword, I can execute a user-defined error, but we'll need to know when to use it. I'll add an if statement. If, and the condition is not a number, pass in x. If this is true, then we will throw an error or an argument to be used as an error. So we're just displaying a message in this example. That wasn't a number. So now when I run this again, I'll enter pizza in. That wasn't a number. What if the user doesn't type in anything? They just press the OK button. 0 isn't a number. So that means they didn't type in anything. We can throw a user-defined error. We'll need another if statement. If x is equal to an empty string, then throw that was empty. Let's try this again. I'll just press OK. That was empty. So an error is an object with a description of something that went wrong. There may be times when something will go wrong in your program, but it doesn't raise an error. Like somebody types in something that you didn't anticipate. You can use this throw keyword to execute a user-defined error. Now there's one more statement that we can add to this. You can add a finally block. Finally will always execute. Doesn't matter if your code is successful or unsuccessful if there's an error. Here's one use of the finally block. Let's say we open a file. After we open the file and are done with it, we would like to close it. But if we open the file and cause an error, we would still like to close it. So the finally block is good for any sort of cleanup. But we're not going to be working on opening files. Let's just display a message. Console.log. This always executes. Let's run this again. I'll enter in a number, 123. 123 is a number. This always executes. So even if our code is successful, we will still execute the finally block. Let's enter in something that's not a number, like the word pizza. That wasn't a number. This always executes. So yeah, everybody, those are a few ways to handle errors. An error is an object with a description of something that went wrong. Sometimes things will go wrong and they don't cause errors. If that's the case, you would want to use this throw keyword, and it will execute a user-defined error, or a message or value that can be used in an error. So that's some basic error handling. If you would like a copy of this code, I'll post this to the comment section down below, and well, yeah, that's error handling in JavaScript. Hey everybody, in this video I'm going to explain the setTimeout method. It invokes a function after a number of milliseconds. It's an asynchronous function, meaning that it doesn't pause the execution of your program. For my example, we're going to be annoying. We're going to spam some alert messages after a given amount of milliseconds. Let's create a few functions. Function will display 3 messages. This will be the first message. First message. I'll create an alert. Alert. I'll use a template literal. Buy this course for $500. Okay, let's create 2 more messages. Second message. Third message. For the second message, let's say that this is not a scam. The third message will be, do it. I would like to invoke these functions after a given amount of time. I will use the setTimeout method. So we pass in a callback, a function expression, or an arrow function expression. Just to keep things simple, I'm going to pass a callback. Let's begin with the first message. That's the first argument. The callback is the first argument. And then a given amount of milliseconds we would like this function to execute. After 3,000 milliseconds, 3 seconds, we will alert the user to buy this course for $500. It is possible to have multiple setTimeout methods executing concurrently, let's invoke the setTimeout method 2 additional times. After about maybe 6 seconds, we will invoke the second message function. Then we will invoke the third message function after 9 seconds. Okay, let's try this.
Buy this course for $500. This is not a scam. Do it.
If at any time you ever need to clear or cancel your setTimeout method, you can use the clear timeout method. But I'm going to link this to a button. Let's create a button within our HTML document. Button ID of my button, and the text will be buy. If we want to buy that fictional course that we're selling, I need to select this button by its ID. Document dot get element by ID. The ID was my button. Set the onClick attribute equal to a function. I will invoke the clear timeout method, but we need to pass in the ID of a timer. When you invoke the setTimeout method, it will return an ID. So let's store that within a variable. Let timer1 equal setTimeout. Then let's create timer2 and timer3. So we will pass these variables as arguments to the clear timeout method. So copy and paste timers 1, 2, and 3. Let's alert the user. So if they click on this buy button, they buy our fictional course.
Thanks for buying.
Buy this course for $500. I'll click buy. Thanks for buying. That will cancel and clear the setTimeout methods. If you need to pass arguments to a function, you can list those after the milliseconds argument. Let's create variable item. We would like to sell, how about a cryptocurrency this time? We will list a price. Let price equals 420.69. So I'm going to pass these two variables as arguments, item and price, when I invoke the first message function. But we need parameters item and price. Let's actually use these. Buy this item for price. Buy this cryptocurrency for 420.69. So yeah, everybody, that is the setTimeout method. It invokes a function after a number of milliseconds. It's an asynchronous function. It doesn't pause the execution of the rest of your program. If you need to perform a task after a given amount of time, you can invoke the setTimeout method. Hey, if you found this video helpful, please be sure to smash that like button, leave a random comment down below, and subscribe if you'd like to become a fellow bro. Hey guys, in this video I'm going to explain the setInterval method. The setInterval method, much like the setTimeout method, it invokes a function repeatedly after a number of milliseconds. It's an asynchronous function. It doesn't pause the execution of your program. Let's create a count up timer. I will declare a counter. Let count, set this equal to 0, and we will accept some user input. Let max equals window.prompt count up to what number? I'll need to convert the user input to a number because it's normally of the string data type when we accept user input. Now let's invoke the setInterval method. setInterval, we can pass in a callback, a function expression, an arrow function expression. Let's just pass a callback to keep things simple. Count up. After how many milliseconds would we like to repeat this function? Maybe 1000 for 1 second. Let's declare this function. Function count up. I will increment count by 1. This will be our counter, and we will display whatever count is. Console.log count. Let's stop if count is greater than or equal to max, the number that we enter in, the user input. To stop the setInterval method, we can use the clearInterval method. However, as an argument, we need to pass in the ID of the setInterval method. So we can actually assign that. Constant, let's name this my timer, equals setInterval. My timer is storing the ID of the setInterval method. I'll pass that as an argument to the clearInterval method. And when I run this, we should count up to a number that we set. Count up to what? Let's count up to 10. Press OK. Okay, we begin at 1, 2, 3, 4, and we should stop at 10. Yeah! If you ever need to pass arguments to a function, a callback, maybe a lot of these variables are within a function. So if I need to pass max, I can add that as an argument, then make sure to have a matching set of parameters. So that is the set interval method, everybody. It invokes a function repeatedly after a number of milliseconds. If this video helped you out, please be sure to smash that like button, leave a random comment down below, and subscribe if you'd like to become a fellow bro. Hey guys, in this video I'm going to discuss date objects. Date objects are used to work with dates and times. To create a date object, we just call the date constructor. Let date equal new date. And then we can display the date. Console.log date. And here's the current date and time, including time zone. Although it's not that readable, we can actually change that. I will set the date equal to date.toLocale string method. And that is a lot more readable. Hey, for fun, within our DOM, let's create a label and update the label with the current date and time. So within my HTML file, I'm going to create a new label, close it. I'll give this a unique ID. My label is fine. And I will change the inner HTML of my label. Document.getElementById. Pass in a unique ID, my label, change the inner HTML equal to date. Yeah, it's pretty cool, right? Now with the date constructor, if you don't pass in any arguments, date will equal the current date and time. However, if we pass 0 as an argument, 0 is a reference point for us. This is known as the epoch. It will be some date around the year 1969. Imagine this is the date where time began. Not really, but just imagine it. This is a reference point for us. Within the date constructor, we can pass an amount of milliseconds as an argument. So if I pass in, I don't know how many milliseconds that is, this will create a new date 10 million milliseconds after this date, the starting point. So 10 million milliseconds after our epoch is the same day, but 8 o'clock at night. So I'm just gonna pass in some random numbers and see what dates we get. This number equates to the date September 8th, 2001, 8 p.m. And let's see what this is. Okay, now we're in the year 33,000. So you can pass an amount of milliseconds to the date constructor, but 0 is a reference point. There are additional arguments you can pass too. The first argument is a year. Let's pick the year 2023. The next argument is the month. 0 corresponds with January. February corresponds with 1. Then you just follow that pattern. I'll pick, let's say January, so 0. The next argument's for the day, the hour, minutes, seconds, and even milliseconds. So after passing, how many arguments do we have here? I think 7. The current date and time is January 1st, 2023, about 2 in the morning. If it's easier for you, you can even pass in a string representation of a date and time. How about January 1st, 2023, midnight. That's another option available to you too. You can even get properties from a current date. If you need the year, we could assign that to a variable. Let year equal date.getFullYear. And let's display this. So the current year is 2022. Day of the month, day of month. The corresponding method is getDate. Let's display day of month. And it is the 7th currently. Day of week, getDay. Sunday is 0, Monday is 1, Tuesday is 2. You just follow that pattern. Since day of week is 1, that means it's Monday. We have access to the month. Get month. The month is currently 1. January is 0, February is 1, March is 2. You follow that pattern. We have access to hours. Get hours. The current hour is 10. This is in military time. So the possible hours are between 0 and 23. Minutes. Get minutes. So the current time for me is 6 minutes after 10. Seconds, get seconds. Every time I refresh this page, you can see that the seconds is going up, and even milliseconds. Let's name this variable ms for short. Get milliseconds. And this is pretty much updating every time I refresh the page. So if you need one of these properties of a date, you can use an associated method. You can also set these properties too. I would like to set the year of my date. Date set full year. I'll pass in the year 2024, and let's display our date. So for me, I'm recording this on February 7th, but the year is changed to 2024. There's also set month. Date.setMonth. I'll change the month to December. So that would be 11. December 7th, 2024. You can set the day of the month. Date.setDate. I'll change this to 31. December 31st, 2024. We have set hours. Date.setHours. Let's move this to 12. That would be 12 p.m. And 23 would be 11 p.m. Same thing applies for minutes. Set minutes. What about 1? Seconds. Set seconds. I don't know, 30. And even milliseconds, although we're not displaying it currently. Date.set milliseconds and pass in some amount of milliseconds. So those are various set methods. You can set a property of a date. We can even create our own custom functions to format a date and time. So I'm going to get rid of this line. Let's create a function to format the date first. Function format date. We will accept a date as an argument. Let's create a few variables for the year, month, and day. Let year equal, and we can get the year. Date.get full year. Let month equal date.get month. And let day equal date.get date. So let's return a string representation of the year, month, and day. Return, I'll use a template literal. So if you would like the month first, like what's displayed in my web browser, we can put the month first, then the day next, and the year. When I update my label, I will invoke the format date function that I created and pass in our date. There we go. Remember though that January is 0 and February is 1, but whoever's using this program probably won't know that. Let's add 1 to our month. There, now it's February. And for some additional practice, let's create a format time function. Function format time. We have one parameter, a date. Let hours equal date.get hours. Let minutes equal date.get minutes. Let seconds equal date.get seconds. Let's return a string representation of the hours, minutes, and seconds. I'll use a template literal. Hours, minutes, seconds. Let's invoke the format time function that we created. Yeah, and that's my current time, but it's currently in military time. Let's change it to standard. Let's add AM or PM. I don't know what to name this variable. AM or PM, I guess. Equals, and I'll use the ternary operator. Our condition is, we'll check if hours is greater than or equal to 12, question mark. If that's true, we will return PM. If it's false, we'll return AM. And I will display my variable AM or PM. And it is currently AM. The hours are still currently in military time, so to convert that to standard, this is one way in which we can do that. Let's reassign hours equal to, we'll write hours modulus 12. Modulus finds the remainder of any division. Then I'll use the bitwise OR operator. 12. We're taking hours modulus 12. If hours is currently 12, this expression would evaluate to be 0. Then using the OR bitwise operator, we would instead use 12. So this line will convert your hours from military to standard. So yeah, everybody, that's a few things we can do with date objects. They're used to work with dates and times. If you would like a copy of this code, I'll post all of this in the comment section down below. And well, yeah, those are date objects in JavaScript. Hey everybody, in this video we're going to create a practice program to create a clock that will update every second. Let's begin by going to our HTML file and I will add a label. We'll use a pair of label tags and I will set the ID equal to my label. Save, head back to your HTML document. I'll assign that variable to a label, constant my label equals document.get element by ID. The ID was my label, and we'll create an update function. Function update, and we will get the current date and time. Let date equal new date. Let's update this label just to test it. My label dot inner HTML equals date, and then we should invoke this function update. So that's the current date and time. But I would like to format this. Within our update function, let's create a nested function to format the time. Function format time. Let's get the hours. Let hours equal date.get hours. The minutes. Let minutes date.get minutes. And seconds. Seconds date.get seconds. Let's return a template literal. Hours, minutes, seconds. Make sure you spell return right. Let's invoke the format time function, and we should probably pass a date. So set up a date as an argument and a parameter. This time is in military time, so let's set this to standard. We'll need AM or PM. Let AM or PM equal, I'll use a ternary operator. We'll check if hours is greater than or equal to 12 question mark. If that's true, return PM. Otherwise, return AM. Let's add our variable AM or PM. My current time is 12:22 PM. The hours is still in military time, although you can't tell from my example. To convert that between 1 and 12, I can set hours equal to hours modulus 12. Bitwise operator, 12. Modulus gives you the remainder of any division. If hours is 12, then the remainder of 12 divided by 12 is 0. Then we would instead use 12 in place of 0 using the OR bitwise operator. Since I'm filming this at 12 PM, there's no change. I would like this clock to update every second. After we invoke the update function, let's invoke the set interval method of our window object. The first argument is a callback. We'll pass our update function as a callback, and then a delay. Every 1000 milliseconds, I would like to update our clock. There, it's updating currently. Now, if one of these variables is a single digit, we don't have any leading zeros. I'd like to change that. If we have a single digit, I would like a leading 0 before the actual time unit. So let's create another nested function. Function, let's call this format zeros. We'll accept a time. Let's set our time parameter equal to time.toString. This will convert a number to a string. Then we will use some string concatenation. And return, we'll use the ternary operator. Let's check the times length property. If it's less than 2, that means it's a single digit. If our time length is a single digit, then we will precede our time with 0. If it's false, we'll just return time back. So then we just need to invoke and reassign hours, minutes, and seconds. We'll invoke our format zeros function, pass in our hours, and do the same thing with minutes and seconds. And we now have some leading zeros. So yeah, I thought that would be a fun practice project. We have a clock that will update every second. If you would like a copy of this code, I'll post this to the comment section down below. And well, yeah, that's a simple clock program in JavaScript. Hey guys, for this topic, I will explain the differences between synchronous and asynchronous code in a span of a few minutes. Synchronous code is in an ordered sequence. They are step-by-step linear instructions. You start some process now, and you finish now. The rest of your program has to wait for a synchronous process. Just a quick demonstration, let's display something. Start. This step is synchronous, and then end. So these are step-by-step instructions. In order to move on to the second step, we first need to complete the first step. No matter how long the statement will take, our next step has to wait for the first step to finish. So our results are start, this step is synchronous, and end. Now, asynchronous code can be out of sequence. These may be tasks such as accessing a database, fetching a file, basically tasks that take time. They'll take an indeterminate amount of time. You don't want the rest of your program to wait around for some process to finish. You start now, finish sometime later, and the rest of your program can carry on with whatever it was doing. An example of some asynchronous code would be the set timeout method. So I'm going to replace the second line with set timeout. Just to keep things simple, I'll pass in an arrow function expression, and we will display a message. Console.log. This is asynchronous. And we'll wait maybe 5 seconds. Okay, we have start and end, and that asynchronous code should kick in right about now. So you can see that this step is out of order, it's asynchronous, it's out of sequence. It's running in the background. Step 3 in my program doesn't need to wait for step 2 to finish. Step 2 will start now, finish sometime later when it's ready. That's the main differences between synchronous and asynchronous code. Synchronous code has to be in order. It's a set of linear instructions. You start now and finish now, such as a console.log statement. Asynchronous code is out of sequence. It takes an indeterminate amount of time, like accessing a database, fetching a file, etc. Start now, finish sometime later, and it doesn't pause your program, it will continue on with the rest of the instructions. So that is a quick description of the differences between synchronous and asynchronous code in JavaScript. Hey guys, here's a super quick video on the time method of the console object. I think you would find this fairly useful. It's a great utility method. Its job is to start a timer that you can use to track how long an operation takes. And you can give each timer a unique name. To track how much time has elapsed for a given operation, I can use console.time. To give this timer a unique name, I can pass that as a string argument. Let's see how long it takes for a user to click a button. I'll name this timer response time. So this is the start. To end this timer, I can use time end. At the end of my program, I will invoke console.timeEnd and pass the same name as an argument, response time. So this is the end. If I run this currently, the timeEnd method will print the elapsed time in my console. This program took 0.0019 milliseconds to complete. Let's actually do something. I'll create an alert. Alert. Click the OK button. And let's see how much time elapses. Okay, click the OK button. I will press OK. And the response time for me to click on that button was 4,886 milliseconds. So about 4 seconds. If you ever need to track how long an operation takes, you can use the time method of the console object. However, if you have an asynchronous process, well, the timeEnd method isn't going to wait around for it. So what if we have set timeout? Set timeout. We'll just display a message. We need a callback. I'll simply just pass in an arrow function. Console.log. Hello. I would like this to execute after 3,000 milliseconds, so 3 seconds. So when I run this, we have already completed our program, and then the set timeout function kicks in. So the time method and the timeEnd method will track how long a synchronous operation takes. So yeah, I thought that would be a very useful utility method that you might be interested in. If you would like a copy of this code, I'll post this in the comment section down below. And well, yeah, that's the time method of the console object. Hey everybody, we have a big topic today. That is promises. Promises are an object that encapsulate the result of an asynchronous operation. A benefit is that they let asynchronous methods return values like they were synchronous. It's a promise to return something in the future. For this topic, let's pretend that we're fetching a file. I haven't talked about the fetch API yet, but we'll do so in the future. For the time being, we'll just pretend that we're loading a file. Let file loaded. This will be a Boolean value, true or false. I'll set this to true. Loading a file is an asynchronous process. We could encapsulate this asynchronous process with a promise. When this process is finished, the promise can return a value or catch any exceptions if there's any problems, like we can't find the file. So this is how to create a promise. Let's declare one. Const promise equals new promise. Within the promise, we can list a callback, a function expression, or an arrow function expression. I'll use an arrow function expression. There's two arguments, resolve and reject. If our asynchronous process is successful, we will invoke this resolve callback. If not, we'll invoke reject. So what would we like to do within this promise? We can place any asynchronous code within this promise. Then let's check to see if our file is loaded. If file loaded, we will invoke this callback of resolve. If you have any arguments for this callback, you can place those here. I'll add some text. File loaded. Else, we will invoke reject. Place any arguments within this callback. File not loaded. That's step one of our promise. Promises have a state. They're pending, then they're fulfilled or rejected. And the result is what can be returned. There's two parts to a promise, the producing code, which is this portion, and the consuming code. If this promise is resolved, what do we want to do? We'll handle that with the consuming code. We will take our promise, follow the promise with invoking the then method. If our promise is resolved, then we can perform some function. This can be a callback to a function expression, or an arrow function expression. I'll stick with an arrow function expression. If we have any arguments, we can list them here. We're returning one value, just some text. Value, arrow, then let's do something. Console.log, whatever my value is. Okay, let's try this. After creating this promise, my file loads. That's set to true. File loaded. What would happen if we couldn't locate a file? This value is false. Well, we have an uncaught exception because we invoked this reject callback. To catch any exceptions, we can follow then with catch. And I'll place this on a new line, just so it's easier to read. We have one argument, so let's set up one parameter. This is the argument. We will name this parameter error. Arrow, what would we like to do? Console.log, whatever my error is. When I run this again, we have caught this exception. File not loaded. So that's kind of the basics of a promise. It's a promise to return something in the future. The state is pending, then it's either fulfilled or rejected. Now you don't necessarily need to reject a promise. This would still work too. But it doesn't do anything. Here's another example. Let's create a separate promise. We'll wait for 5 seconds, then display a message. Const promise equals new promise. I'll write an arrow function expression. This time we will only resolve. Arrow. And then maybe some curly braces. Okay, what are we going to do within this promise? Let's set timeout for 5 seconds. Set timeout. Resolve after 5 seconds. That's 5,000 milliseconds. Then I will take the name of my promise, follow it with then pass in a function. So you don't necessarily need to return a value when resolving. So this function will have no arguments. Arrow will display a message, console.log. Thanks for waiting. After 5 seconds, this should display my message. Thanks for waiting. What if you would like to pass an argument to a promise? Let's rename this promise object as something else, something that's more descriptive, like wait. Wait is now a promise. When we create this promise, we can pass an argument. How about an amount of milliseconds? Let's wait for 3 seconds. That's 3,000 milliseconds. I'll precede this promise with an arrow function and list any arguments before the arrow. Maybe time. Time will be this value, whatever we're passing in. We'll wait for some amount of time, 3,000 milliseconds. Let's run this again. 1, 2, 3. Thanks for waiting. So yeah, those are promises. They're objects that encapsulate the result of an asynchronous operation. They let asynchronous methods return values as if they were synchronous. It's a promise to return something in the future. So those are promises. If you would like a copy of the code we worked on today, I'll post that in the comments section down below. And well, yeah, that's an introduction to promises in JavaScript. Hey guys, in this topic I'm going to explain the async keyword. It makes a function return a promise. In this example, I have a promise. There's a callback with 2 arguments, a callback for resolve and a callback for reject. All we're doing is we're checking to see if a file loaded. Not really, but we're pretending we are because I haven't taught about loading files yet. So we have a Boolean variable, file loaded, it's set to true. If our file didn't load, we can set this to false. If file loaded, we will invoke this callback of resolve. If not, we'll invoke this other callback of reject. So currently, my file loaded. If I switch this to false, my file is not loaded. An easier way of writing this is that we can stick this code within an async function and it will return a promise. So let's create an async function. Use the keyword async function. And what's a descriptive name of this function? How about load file? That's an asynchronous process. I'll copy this code, cut it, I'll delete this promise, and paste my code within this async function. There's no need to use this resolve or reject callback. If my asynchronous process is successful, I will simply return a value. Return file loaded. This will be an argument. If my asynchronous process is not successful, I could instead use the throw keyword. This will raise an error and we can catch it. So this is my error message right here. Now to invoke this function, in place of a promise, I will invoke the function that contains my asynchronous process. Load file. So let's check to see if this works. File loaded is set to true. File loaded. I'll set this to false. File not loaded. When using the then and catch methods, in place of adding these methods after a promise object, we would invoke a function, and a promise is going to be returned back to this place in which you invoke the function. Another way of writing this that's a little more clear, but it's a lot more syntax, is if we were not using the async function. We would return a promise. I'll eliminate this async keyword just for a demonstration. So we're returning a promise object. Promise.resolve, and I will pass this text as an argument, else return promise.reject. This would do the same thing, but it's more syntax. File loaded, file not loaded. When we invoke this function, we're returning a promise back to the spot in which we invoked this function. But I like using the async keyword. It's a lot less text. So yeah, that's the async keyword, everybody. It makes a function return a promise, and it pairs very well with the await keyword, which we'll discuss in the next topic. In about 3, 2, 1, go. Hey guys, in this topic I'm going to explain the await keyword. It makes an async function wait for a promise. In this example, I have an async function that is named loadFile. We're pretending to load a file. That would be an asynchronous process. If our file loads, we will return a promise with this text as an argument, file loaded. If for some reason we can't load our file, we will throw an error and catch it and display this error message. Another way of writing this without using these two lines of code, invoking an async function followed with then and catch, is that we could use the await keyword. So we will type await, then invoke an async function. Await, load file. We're waiting for a promise. Awaiting an async function in this example will return some text, file loaded, or file not loaded. So I'm going to store that text within a temporary variable. Let's say let message equal await load file. Then I'll simply display that message, console.log message, and I can eliminate these two lines. So after running this, we have an uncaught syntax error. Await is only valid in async functions. So in order to use this await keyword, we need to place it within another async function. So maybe we're beginning the process of loading a file. Usually that takes more than one asynchronous process. You have to first locate the file, open it, then close it. So I'm going to declare an async function start process. And I will stick these two lines within that function. You can only use the await keyword within an async function. And then we need to invoke this function to begin the process. Start process. File loaded. There was no need to invoke this async function followed with then and catch. We can eliminate that. All you need is await, but it does have to be within an async function. Now check this out. What if our file doesn't load? This will throw an error. Uncaught, in promise, file not loaded. We would need some way to catch this error when it's thrown. One way in which we can do that is to surround any dangerous code with a try block. See the topic on the series in error handling, where I'll discuss this more in depth. So try this code. If there are any errors, we will catch them. So catch, there is one argument of error, and I will simply display our error. Catch, console.log error. So let's run this again. File not loaded. So this is very helpful if we have to wait for more than one asynchronous function. We'll discuss this in the next topic. Maybe not only do we have to load a file, but we first need to locate it and we have to close it. In the next topic, we'll have to wait for multiple asynchronous functions. We might have locate file and close file. So when we begin a process, we're waiting for multiple asynchronous functions. But we'll discuss that in the next topic. So yeah, that's the await keyword, everybody. It makes an asynchronous function wait for a promise. When using the await keyword, you don't need to invoke a function, then follow it with the then method and catch. There's no need for that. So yeah, everybody, that's the await keyword. We'll practice this more in the next topic. Hey guys, in this video I'm going to explain ES6 modules. The idea behind a module is that it's a file of reusable code. We can import sections of pre-written code to use whenever we want. They're great for any general utility values and functions. They help to make your code more reusable and maintainable. Think of modules as separate chapters of a book. Each JavaScript file could be its own individual chapter. To begin working with modules within the opening script tag of your HTML document, add this attribute, type equals module. Then we'll create a new JavaScript file. I'll name this math_util.js. This file will contain some general math utility functions, such as get the circumference of a circle or the area. So let's begin. I'll create a constant as well, const pi. I'll set this equal to 3.14159, and maybe some functions. Function get circumference will accept a radius, and we'll return 2 times pi times radius. Then let's create a get area function. Get area will return pi times radius times radius. To export any variables or functions, I will precede them with the export keyword. I like to do this inline, then save. Heading back to our main JavaScript file, we can import everything from this JavaScript file. To do that, we will type import, then within curly braces, Then list all of the variables or functions we would like to import. I would like to import pi, get circumference, and get area. Add from, then an absolute or relative file path. I'll use a relative file path because these files are right next to each other. So that would be dot / the name of the file, math_util.js. And that's it. So we can use these variables and functions as if they were in the same file. To test this, I will use console.log pi. And that value is 3.14159. We have access to this variable even though it's not written within this file. We've imported that variable from this separate JavaScript file. Let's calculate the circumference of a circle. Let circumference equal get circumference. Pass in a radius, maybe 10. Then let's display our circumference. Console.log circumference. If we pass in 10 as a radius, the circumference is 62.83. We also have get area too. Let area equals get area. The area would be 314.159. Even though all of this code is written in a separate file, we can access it from another file by importing it. Make sure that anything you want to export is preceded with this export keyword. There is another way to import this too. I'm going to copy all of this and paste it. If there's a lot to import, we can simply import everything by using an asterisk. But we'll give all of these imports an alias. That's like a nickname. Import asterisk as your nickname should be descriptive of the file that you're importing. This is as if we're creating a separate namespace. Maybe math util. Now, in order to use these variables or functions, I would need to precede them with that namespace, mathutil.py, mathutil.getCircumference, mathutil.getArea. Then this would work. When I'm using mathutil.py, that's kind of similar to math.py. It's kind of the same concept, except we ourselves created the separate JavaScript file. So yeah, those are modules. They're files of pre-written code that we can import and use whenever we need to. If you would like a copy of this code, I'll post this in the comment section down below. And well, yeah, that's an introduction to modules in JavaScript. Hey guys, in this video I'm going to quickly explain the DOM. It's an acronym for Document Object Model. Technically, it's an API, an Application Programming Interface. It's an interface that's used for changing the content of a page, and it's arranged in a hierarchical tree. Our DOM is a representation of an HTML document, and this tree contains nodes. The first child of our document is the HTML root element. So our HTML tags enclose all of this content, including the head and the body elements, which are here and here. The head can contain a title and some text, which you see right here. And the body can contain some various HTML elements, like a div tag. By interacting with this DOM, we can change the elements of a web page. Document is the entry point of our DOM. If I typed console.log document, this would display my DOM and everything within it. So we have document, our HTML node, the head, and the body, and a bunch of stuff within those nodes too. Now, if you were to type console.dir, then pass document as an argument, this will list all of the properties of your DOM. If I need access to the title of my document, I can access that by typing document.titleProperty, and then I'll display this console.log document.title. And the title of my document is, well, document. Or I could get the URL, console.log document.url. So this is my URL. And you can change these properties too. I can change the title of my web page, document.title, set this equal to something. Title goes here. And taking a look at this tab of my web browser, you can see that it says title goes here. I can even change the location. Document.location, I'll set this equal to Google. So http://www.google.com. Then when I save this, it takes me to Google. By accessing the DOM, I have access to my body element, and I can change something about the body of my document. If I would like to change the background color, I would type document dot the name of the node, body in this case, and I will set the style background color sky blue. And this will change the background color of the body of my document. If I need to change some HTML element, like this div tag, I could type document dot get element by ID, and we will search for an ID within our DOM, like my div. And I can set the inner HTML equal to some text, like hello. Hello. That's a quick summary of what the DOM is. It's an API, an application programming interface. It's an interface for changing the content of a page. We can change content without having to reload the page to reflect any changes. Document is the access point. Each node can contain an object. This tree is a model. So it's a document object model, a DOM. And in the next few topics, I'll demonstrate how we can search for given elements and traverse nodes. So that is a quick overview of what the DOM is. Hey guys, in this video I'm going to show you a few different ways we can select elements in a web page. Let's begin with something very basic. I'm going to create an h1 header tag. We'll create a menu for a restaurant. This is the menu. And I will give this h1 element a unique ID, my title. To select this element, I can type document.get element by ID, and the ID was my title. And I will store this within a variable. Let element equal document.getElement by ID. And what should we do with this element? Let's change the background color. So type element.style.background color. I'll set this to light green. That's a good color. So yeah, you can select an element by its ID, but you probably knew that already. We have a little bit of experience with this method. Let's select elements by their name. The name attribute is useful if you have more than one element in some sort of group, like radio buttons. Let's create some radio buttons. Input type equals radio, and I will give this a name of fruits. The first will have a value of apple, then I'll create a label for this. Label for equals apple. Close the label, I'll add a line break, and I will type apple. Okay, 2 more fruits. What about an orange? For orange, the text will be orange, and banana. Value banana for banana, and the text will be banana. So each of these 3 radio buttons has the same name, fruits. To select all of these radio buttons within my document, I can type document.get elements, that's plural with an S, by name. Then pass a name as an argument, fruits. This method returns a node list. It's similar to an array. So I will store that within, let's say, fruits. Let fruits equal document.get elements by name, fruits. So what would I like to do with this node list of fruits? If I were to use console.log and display fruits, well, we have a node list with our 3 elements, a radio button for apple, orange, and banana. If I add an index number, only that element is displayed. So we have our apple, at index 1 would be our orange, and 2 is our banana. Maybe I would like to change the background color of each of these elements. What's one way we can check to see if one of these elements is selected? I'm going to add an attribute. With the apple radio tag, let's add this attribute. Checked equals checked. By default, this will already be selected. I would like to print whatever radio button is checked. We've already selected our elements by their name, fruits. So I will use the for each method of this node list, fruits for each. I will cycle through this node list of elements and find whatever element is checked and display it. So we have our parameters, fruit, arrow function. Let's check to see if our fruit is checked, fruit.checked. Then we will console.log whatever our fruit is. Then add dot value. So our apple is selected. Let's change the checked attribute of our orange this time. So we have orange now. And banana. So that is get elements by name. Now we have get elements by tag name. Heading to our HTML file, let's create an unordered list. UL for unordered list. Close it. We will add some list items. Perhaps these are vegetables. Carrots. Potatoes. And onions. We can select elements by a given tag name, like list item. Let's store our elements within vegetables. Let vegetables equal document.get elements by tag name. And the tag name was li for list items. This method returns technically an HTML collection. It behaves similarly to an array. Let's take vegetables at index of 0. That would be our carrots. I'm going to access the style, the background color property, and set this equal to light green. The second element would have an index of 1, and the next element would be 2. So that is get elements by tag name. Find tags that you would like to select, and then just pass that as an argument to this method. Okay, we have get elements by class name. I think this time I'll create some div elements. Div, close it, and I will give this a class of desserts. Desserts. First we'll have ice cream, cake, and maybe pie. Each of these 3 div elements has the same class name, desserts. I'll store our elements within let desserts equals document.get elements, plural, with an S, by class name. And the class name was desserts. Desserts is technically an array-like object, but it behaves similarly to an array again. So I'm going to change the background color. Let's start with element 0. So that is the first element, index 0, index 1, and index 2. That is the get elements by class name method. Now we have query selector. Query selector tends to be fairly popular. We can select an element by either an ID, a class name, a tag, or an attribute. Let's create variable element equal document dot query selector. Then pass in an ID, a class name, a tag name, or an attribute. Let's begin with an ID. Let's select ID my title. If you're selecting an ID, be sure to precede the name with a hashtag. I will change the background color of this element to light green again. There, so using query selector, we've selected an element by a unique ID. We can also do so by a class name. So class desserts. With a class name, you're going to precede the class name with a dot. So class desserts. Now with query selector, it selects the first element of any group. If you need all of the elements, you'll need to use query selector all, which we'll cover in just a little bit. You can also select by a tag name, like list item. The first list item within my document will be selected. Or you could even use an attribute. So maybe the first element that has the for attribute I would like to select. I will use a set of square brackets and type for. The first element with the for attribute is selected. If you need all elements, you can use query selector all. So let's copy this, paste it, let elements query selector all. I would like to select all list items and change the background color, but we'll need to iterate over each of the elements. I'll use a for each loop. Elements for each element. I will change the background color of each element. There, each list item was selected. How about anything with the desserts class name? Or anything with the for attribute? So yeah, those are a few different ways in which we can select HTML elements. If you would like a copy of this code, I'll post all of this in the comment section down below. And well, yeah, that's how to select elements using JavaScript. Hey guys, for this topic, I'm gonna show you a few different DOM traversal techniques. But before we do that, I need to explain some family relationships between elements. Say we select our body element. Within my HTML document, I have 3 unordered lists, a list for fruit, vegetables, and dessert. They are arranged in a hierarchy, a family tree. If we select our body, these 3 lists, since they're contained within the body, they would be considered children. My list of fruit is a child, same with vegetables, and dessert. Since my list of fruit appears first within my body, the fruit list would be considered the first child, kind of like it's the firstborn. Dessert is last, that would be the last child. It's the lastborn. If we select this middle list of vegetables, then my body element is considered the parent of this list. The body element is the parent. The 2 other lists would be considered siblings. Sibling and sibling. Since fruit appears before vegetables, fruit would be considered the previous sibling. Dessert would be considered the next sibling. My unordered list does have children too. Each of these list items would be children of my unordered list. Yeah, that's a quick overview of the family relationships between elements. With that out of the way, here's my HTML document. Within the body, I have 3 unordered lists. Each has a unique ID: fruit, vegetables, and dessert. Suppose I would like to select the body of my document. I'll store that within a variable. Let element equal document.body. To select the first child, that would be the first unordered list. I'll store that within another variable. Let child equal element dot first element child. Let's color the background of this child element green. Child dot background color equals light green. This entire unordered list is now green. Let me show you what happens when I select the last element child of my body. So nothing appears to change. Let's take a look at this child using console.log. Console.log child. So when I selected the last element of my body, we selected the script element. This element is the last child of my body. So that's something you need to pay attention to. Let's select our vegetable list. Document.query selector. I will select vegetables. We will select the parent element. I'll rename this as parent. The parent of this list would be the entire body of my document. That's why the entire background color is now green. We can choose the next element sibling. 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 If we select our list of vegetables, the next sibling would be my list of dessert. And the previous element sibling is my list of fruit. What if you need one of these list items? I'll select my list of fruit, then select one of these elements. First element child. That would be the apple list item. Last element child is the banana. Another way to access the children of an element is via an index. This time I will follow element with children and list an index number. 0 is the beginning, and we will change the first element at index 0. 1 would be the second element, orange. 2 is the next element, banana. If you need all the elements, you can simply use children. This will return a collection. We would need to convert that to an array. This collection doesn't have the for each method. I will surround element.children with array.from method. And we can iterate over the elements of this array. Let's rename child as children. Children dot for each method. We have our parameters, child, arrow function, we'll change the style of each of the children of this list. Now each child is green. We could select a different list, like vegetables or dessert. So yeah, those are a few DOM traversal techniques. Elements are arranged in a family tree. Whatever element you select, that element can have a parent, maybe some children, or siblings. So yeah, those are a few basic DOM traversal techniques in JavaScript. Hey guys, for this topic, I'm going to show you how we can add and change HTML elements. I need to create an h1 header tag. To do that, I will type document.create element. Within the create element method, and within quotes, I can list a tag that I would like to create. I would like to create an h1 header tag. I'll assign this to a variable. Constant, maybe name tag. We'll store our name. Name tag is an h1 header tag. However, it doesn't contain any text. That's where changing HTML elements comes in. Two ways in which I could add some text to this h1 header tag is to either use inner HTML or text content. Text content is the preferred way because inner HTML is vulnerable to something called cross-site scripting attacks. I'll give you a demonstration momentarily. If we were using inner HTML, I would take my tag dot inner HTML, set this equal to some text, maybe your first name. Then to add this element, I would need to declare where I would like to add this tag specifically. The body of my document would be a good place. Document.body, and I will use the append method and place my tag within the append method as an argument. This will create an h1 header tag, then add it to the body of my document. What if we accept some user input instead? Window.prompt, enter your name. Enter your name, type in your first name, press OK, and there's your h1 header tag. Now here's the problem with using inner HTML. We could also assign some tags along with some text. If I was to run this again, I could place a malicious script within the user input. This would be an example of a cross-site script attack. I'm gonna blur this section just because I don't want to give you guys any ideas. Then if I were to press OK, this would activate my script. This script that I wrote just has a pop-up that says virus. The preferred way of adding some text to an element is to set the text content. When I run this program again and enter my malicious script, this script will be instead parsed as text. Setting text content is a much safer approach than using inner HTML. This time we're going to add a list item to an unordered list. Heading to our HTML document, we'll create an unordered list. I'll give this list an ID of fruit. Then we will add some list items. Apple, orange, banana. Okay, here's my list. To append an item to my list, well, I need to know what my list is. I'll store that within a variable, constant my list, and I would need to select this list. I can do that with document.query selector, pass in an ID. The ID was fruit. Then I can create a list item element. Const list item equals document dot create element. What kind of element would we like to create? Let's create a list item element. To set the text of this list item element, I will take my list item, then set the text content property equal to whatever I want. I feel like a mango. Then we just need to add this list item to my list. My list, use the append method, then pass in my list item. There, we have added a mango. If you would like this list item at the beginning of your list, you can use prepend. Prepend. Now we have mango, apple, orange, banana. Otherwise, if you need to place an item somewhere within the middle of the list, it's a little more complex, but here's how. Take your parent element, my list in this example, dot insert before method, pass in what's to be inserted, our list item. Then we need to get all of the elements. We can do that by taking my list again, dot get elements by tag name. We would like to select all list item elements. Then an index number, To insert mango before orange, the index would be 1. Following the getElementsByTagName method, I will add the index of where I would like to insert this list item, so 1. Now we have apple, mango, orange, banana. 2 would be apple, orange, mango, banana. And then 3 would be the end. So yeah, everybody, that's a beginner's way to add and change HTML elements. If you would like a copy of this code, I'll post all of this in the comment section down below. And well, yeah, that's how to add and change HTML elements using JavaScript. Hey, what's up guys? In this video, I'm going to show you how we can change some CSS properties of elements. Heading to our index.html file, let's create a simple h1 header tag. I'll give this header tag a unique ID of my title. Then add some text. This is my title. Then save. In order to change the CSS properties of this element, we first need to select this element. I'll declare this as a constant, const title equals, then to select an element, you type document dot get element by ID. Within the parentheses and within quotes, we will list the ID of our element we would like to select. Get element by ID is a very basic way of selecting an element. In the future, we'll cover more advanced methods. But for now, we'll stick with get element by ID. So we're storing this within a variable, title, and now we can do stuff with it. To change CSS properties of some element, such as my title, I will follow the name of this element, title, then access the style attribute, dot, then a CSS property. Maybe I would like to change the background color, so I will list that property, background color. When accessing a CSS property through JavaScript, the format is in camel case. Normally with CSS, there's a dash between words, such as background dash color, but if you're using JavaScript, you use camel case. The first letter of the first word is not capital, then the first letter of any word after the first is capital. Background color. And set this equal to a color. You can pick a color name, maybe blue. You can select RGB values, RGB. Within the parentheses, you have 3 numbers. Each corresponds to the amount of red, green, and blue. So maybe 50, 200, 250. I don't know what this color is going to be. Ooh, I kind of like that color. Or you could use hexadecimal values. What's 222222? Okay, that is a dark gray. You have a couple options when it comes to colors. Let's change the font of my title. What element would we like? We would like title. We'll access the style, then a property. Color. Let's use RGB this time. RGB 50, 200, 250. There, and we have that color again. So again, you can use color names, RGB values, or hexadecimal values. And if you don't know any, you can always Google hex color picker and pick a color that you like. Here are the RGB values or the hexadecimal values. Okay, let's change a few other properties. We're selecting our title, accessing the style attribute. Then let's change the font family property. I will set this equal to pick a font. I like this font. And there we go, we have a new font. I would like to text align center this element. Title.style.text align equals center. Then add a border. Title.style.border equals 2 pixels. Solid is good. Yeah, and we have a border. To hide an element, we can access the display property. Title.style.display equals none. This will hide this element, or we could set this to block to display it. So yeah, everybody, that is a very basic way to change CSS properties. You would first need to select an element or elements, follow that element with dot, the style attribute, dot, the CSS property, and you can set it equal to a new value. That is how to add and change CSS properties using JavaScript. If you would like a copy of all this code, I'll post this in the comment section down below. Be sure to look underneath the original video in the 100 video playlist. And well, yeah, that's how to change some CSS properties using JavaScript. Hey guys, in this video I'm going to explain events. An event is some action that the user or the browser does. Many HTML elements contain event attributes. For example, let's create a button. I'll give this button an ID of my button. For the text, let's just say button. Buttons have an onClick event attribute. OnClick. I can set this equal to the name of a function and invoke it. Let's create a function that will do something. I'll cleverly name this function do something. All we'll do is create an alert. Alert, you did something. I will set the onClick attribute equal to the name of my function, do something, then invoke it. When I click on this button, my onClick event attribute will invoke this function, do something. You did something. In place of setting event attributes directly within your HTML elements, you could do so within your JavaScript file. I would first need to select my element. Constant element equals document.get element by ID. The ID was my button. I will take this element and set the onClick event attribute equal to some function. Do something. Be sure not to invoke it. This is a callback. Save everything. Then when I click this button, we activate the onClick event attribute. So that's one event attribute, onClick. Another event attribute is onLoad. When the web browser loads, it does something. This time I'm going to select the body of my document. Constant element equals document.body. I will take this element and set the onLoad attribute equal to some function. Do something. When the body of my document loads, it activates the onLoad event attribute. Another option is that within the opening body tag of your HTML file, you can directly set that attribute. Do something. And this would work too. That is the onLoad event attribute. When an element loads, it does something. Next, we have the onChange event attribute. Element.onChange equals do something. When an element has been changed, it activates the onChange event attribute. Heading to our HTML document, let's create a text box. Input ID equals my text. Get rid of this. We will select our text box. Constant element equals document.get element by ID. We are selecting my text. Now, when we make changes to this text box and then leave, it activates my onChange event attribute. If used with a text box, you could format some text once you leave. Okay, this next one is going to be fun. Let's create a div tag. Div ID equals my div. Close it. Then heading to our CSS style sheet, let's select my div. We'll change the background color to light green. And the width to 100 pixels. And the height to be 100 as well. Let's save. We'll select this ID, my div. Constant element equals document.get element by ID. The ID was my div. When we move our cursor over this div tag, we'll change the background color. We will take our element and use the onMouseOver event attribute. Set this equal to a function. Do something. Let's change the background color. Element.style.background color equals, how about red? When I hover my cursor over this div tag, it's going to change the color. When you leave an element, you can set the onMouseOut event attribute. Element.onMouseOut will create a function to do something else. Let's copy this, paste it, do something else. We'll change the background color to light green again. So when I enter, the color is red. When I leave, it's green. Red, green, red, green, red, green. So that is on mouse over and on mouse out. Okay, we're on the last two. On mouse down. Element dot on mouse down equals do something. So when I click down, when I click on this element, it activates the on mouse event attribute. By itself, it's basically no different from the on click event attribute, but it pairs very well with the on mouse up event attribute. On mouse up. When we let go of our mouse, we can perform another function. Do something else. When I click and hold down, it's red. When I let go, it's green. Red, green, red, green, red, green. All right, everybody, so those are a few events. On click, on load, on change, on mouse over, on mouse out, on mouse down, on mouse up. And in the next topic, we'll look at event handlers. If you would like a copy of all this code, I'll post all of this in the comment section down below. And well, yeah, those are a few JavaScript events. Hey guys, in this video I'm going to explain the add event listener method. We can link an event and a function to an HTML element. Using the add event listener method is the preferred way of handling events. A benefit is that one element can have several event listeners. Even the same event can invoke different functions. Within my HTML document, I'm going to create a div. Div, close it. I'll give this a unique ID of inner div. Eventually, we'll create an outer div. Then within my CSS style sheet, I'll select inner div. I'll give this a background color of light green, a width of 100, a height of 100, and a border. 1 pixel solid is good. Save everything, and here's our div element. Using the add event listener method, this div element can listen for multiple events. We'll need to select an element. I'll name this const inner div equals document dot get element by ID. We're selecting inner div. To add an event listener, you take your element, inner div in this case, then invoke the add event listener method. The first argument is an event. Let's add mouse over. Mouse over, then a function. Let's create a function to change the color red. This will be a callback. Change red. Let's define this function. Function change red. Let's take our inner div, take the style, set the background color property equal to red. When I hover my cursor over this div element, it changes red. A benefit of using the add event listener method is that it's easy to wait for multiple events. So to wait for another event, we can simply invoke the add event listener method again. This time, we'll also listen for the event of mouse out. Let's create a function to change green. Function change green. Background color equals light green. This div element is listening for two events, mouse over and mouse out. Using the add event listener method, it's really easy to wait for multiple events. There's one more argument within the add event listener method. That is the use capture argument. Suppose we have an element within another element. I'll surround this inner div element with another div. Div, the ID will be outer div. Be sure to enclose your inner div. I'll change the style of outer div. I'll get rid of the border. The width and the height will be 200. Save everything. So we have an outer div and an inner div. The inner div element is inside of the outer div element. What would happen exactly if both of these elements are waiting for the same event, mouse over? Which event would be handled first? The inner element or the outer element? Well, we can set that with the third argument, the use capture argument. Let's add an event to the outer div. I'll store this within a variable. Outer div. The ID is outer div. I'll eliminate all of this. I'll add an event listener to the inner div. Add event listener. The event this time will be click. The function will be change blue this time. We'll add the same event to the outer div. Outer div. Add event listener, click, change blue. Let's define this function, change blue. Function, change blue. We will take this dot style dot background color equals light blue. Both of these div elements are doing the same thing, but there's some overlap. The inner div element and the outer div element are within the same space. So when I click on the inner div element, we're also clicking on the outer div element at the same time. Which element handles its event first, the inner element or the outer element? Just to test this within the change blue function, let's create an alert just to slow things down. You selected, then let's display the ID of the element that is being handled. This.id. Okay, so when I click on this element, we're handling the inner div first before the outer div. But with the outer element, if you pass in another argument true for use capture, well then we will handle the outer element first before the inner element. So that's what that third argument is, use capture. If two elements are taking the same space and they're listening for the same event, you could specify which one has preference. Yeah, that's the add event listener method. It's the preferred way of having an element listen for events. As arguments, you can pass in an event, a function to be executed, and a preference if you would like an outer element to be handled first. So yeah, that's the add event listener method, everybody. Hey everybody, in this video I'm going to demonstrate how we can show and hide HTML elements. For this demonstration, I recommend downloading a picture. Here's a picture of a car that I found. Place it within the same folder as your JavaScript file. When I click on a button, I would like to toggle between showing and hiding that image. Heading to my HTML file, let's create a button. Button ID equals my button. I'll add some text. Toggle is fine. We will add our image. Image ID equals my image. Set the source equal to where your file is located. This image is in the same folder as my HTML file. I just need the file name. My file name is car.jpg, but it's probably going to be something different for you. Car.jpg. Let's change the size, it's a little massive. Heading to my style sheet, I will select my image, set the width to something reasonable, like 300 pixels. That's a lot better. At the bottom, I'll add some text. A paragraph element is fine. Press the button. Heading to my JavaScript file, I'll select my button and my image. Const my button equals document dot query selector. I'm selecting my button. Do the same thing with image. My image. Next, I'll add an event listener to this button. My button dot add event listener. When we click on this button, we're going to perform a function. I'll use an arrow function expression. What we'll do is check the display property of this image. I'll use an if statement. If my image dot style dot display is equal to none. None means that this image is hidden. If it's block, that means it's being displayed. If this image is hidden, my image dot style dot display equals block. This will display my image. Else, let's hide our image. My image dot style dot display equals none. When I click on this button, it hides my image. When I click on it again, it displays my image. Now it's hidden, now it's showing. Hidden, showing, hidden, showing. There's one issue with this though. Perhaps I would like this image to be hidden from the beginning, then we display it. To do that, we can go to our style sheet, then set the display property to none. Now check this out. When I click on this button the first time, it doesn't do anything. until I click on it a second time. Then it performs normally. The reason that this is happening is that the style from our style sheet is not ready yet. To demonstrate that, I'm going to console.log the display of my image. When I click on this button, well, there's no value within my display. If the display of my image is equal to the property none, then we show the image. But this is technically null, and not the property none. Therefore, we will hide this image, which it already is. A quick fix for that is that we can add some inline styling to this element. I'll add this display property inline instead of externally. Find your image tag, set the style attribute equal to that CSS property. This should work now. I will click once to display my image, then hide it. Display, hide it. Another option is that we can set the visibility of this image. When we toggle the display property, all the elements that are underneath are going to shift downwards. But if we were to use visibility, this space will be reserved. Let's replace display with visibility. In place of none, we will check hidden. In place of block, this will be visible. Within the inline styling, let's set display to visibility. Our visibility will be hidden. Make sure to save everything. All of this space is reserved for that image. You can see that my text down at the bottom is way down here. When I show and hide this image, there's no shifting of elements. This space is reserved. So that's another option too. You can always toggle the visibility of an element. So yeah, everybody, that is how to show and hide HTML elements. If you would like a copy of this code, I'll post all of this in the comment section down below. And well, yeah, that's how to show and hide HTML elements using JavaScript. Hey yeah, everybody. In this video, I'm going to show you how we can detect key presses. To do that, we can add an event listener to our window. Window.add event listener. The first argument is the attribute. Let's detect any keyed down events. Second is a callback, a function expression, or an arrow function expression. Let's use an arrow function expression. There is one argument, event, arrow. Then what would we like to do when we press down on a key? Let's display what key was pressed. Console.log event.key. And that's it. Let's test it. Press some random keys. Q, W, E, R, T, Y, A, S, D, enter, backspace, 1, 2, 3. The arrow keys would be up, down, left, right. Okay, we know that that works. Let's have some fun with this. Let's create a box within our window, and we can move the box with key events. Heading to our HTML file, let's create a div tag. Pretend this wasn't here. Div ID equals my div. Close it. Let's style it. My div. We'll set the background color to whatever color you would like. Set a width. 100 pixels is good. A height. 100. You could add a border if you would like. Border 1 pixel solid. And we'll want to set a position. Position, either absolute or relative. We'll move our box relative to the body that it's in. Okay, save everything. I'm going to select our div element. Const my div equals document dot get element by ID my div, and we'll add an event listener to our window. In place of an arrow function expression, let's pass a callback as an argument. Let's pass a callback to a move function, and we'll need to define that. Function move. There's going to be one argument that's provided for us. Within the parameters of the move function, let's add event. This argument is provided for us. I think the best way to detect certain keystrokes would be with a switch. Let's detect arrow down, up, left, right. Switch. We're examining event.key for any matching cases. The first case will be arrow down. Arrow down. We'll have to keep track of some coordinates of where our div element currently is. Let's create variables x and y. Let x equal 0. let y equal 0 as well. Whenever we press down, let's move y by maybe 5 pixels down. Y plus equals 5. Then we will take my div, take the style, access the top property, and set this equal to whatever y is, plus pixels. Then at the end of our case, let's break. So when we save, by pressing down, we should be able to move down. Yeah, there we go. Let's do the same thing with the other arrow keys. Arrow up, we will decrement y, so we should be able to move down and up. Arrow right, x plus equals 5. My div dot style dot left equals x plus pixels. Now we should be able to go right. Arrow left, x minus equals 5. Now we can go right, down, left, and up. Then you could add a default case too if you would like. Default, break. So yeah, that's how to detect key presses, everybody. You can add an event listener to your window. The event attribute is key down. You could also switch this to key up. When you let go of a key, then it triggers the event. The second argument is a callback, a function expression, or an arrow function expression. So yeah, that's one way to detect key presses. If you would like a copy of this code, I'll post this in the comment section down below. And well, yeah, that's a very basic way to detect key presses in JavaScript. Hey guys, in this video I'm going to show you how we can create a few simple animations using JavaScript. We'll create a button and a div element. Heading to our HTML file, let's create a button. I'll give this an ID of my button. I'll add text, begin. This button will begin the animation. I'll create a div element, ID equals my div. Let's style our div element, my div. Choose a background color. I'll pick light green, but choose whatever color you like. A width of 100 is good. A height of 100 is good as well. Then set the position property to relative. We'll position this element relative to the container that it's in, the body of our document. Okay, save everything. In our JavaScript file, let's store our button element. Constant my button equals document.get element by ID. My button. Then let's get our div element. I'll name this my animation. Get element by ID, my div. When we press on the button, we'll begin an animation. We'll want to add an event listener to the button. My button dot add event listener. The event will be click. Then we will pass a callback, begin. Let's define this function. Function begin. What would we like to do? I'm going to declare a timer ID. We'll use the setInterval method. Let timer ID. I'll set this equal to null for now. We'll need some coordinates to keep track of our position of our div element. Let x, I'll set this equal to 0. Let y equal 0 as well. We will use the setInterval method, pass in a callback to a function. We'll name this frame. After how many milliseconds would we like to invoke this function? What about every 5 milliseconds? That's a good speed. SetInterval returns an ID of the timer that we're using, so let's assign this to timer ID. We will use this timer ID to stop the animation when it's completed. We're going to create an inner function. Function frame. This inner frame function will be in charge of updating our div element every 5 milliseconds. But when would we like to stop? Let's slide our div element to maybe like 300 pixels out. So I'm going to write an if statement. If x is greater than or equal to 200, then we will stop setInterval. We can do that by using the clear interval method, pass in our timer ID. This will stop the animation. Else, if we would like to advance one frame, let's increment x by 1. X plus equals 1. Then we just need to adjust the left property of this div element. We'll take my animation, axis the style, axis the left property, set this equal to whatever x is currently, then add pixels. So when we begin this animation, it should slide to the right. And stop right about here. Now let's move this animation down instead of right. If y is greater than or equal to 200, y plus equals 1, my animation dot style dot top equals y plus pixels. Now this animation moves down. We could combine them both. If x is greater than or equal to 200, or y is greater than or equal to 200. Then we will increment both x and y by 1. X plus equals 1. My animation dot style dot left equals x plus pixels. Now this animation moves diagonally. That's a simple slide animation. Let's make this element rotate. I think that would be cool. Let's eliminate some of these lines of code. I'll post all of this in the notes, so don't worry about that. Okay, we'll need a variable degrees. Set this equal to 0. Let's perform a full 360-degree rotation. If degrees is greater than or equal to 360, then we will stop our timer. Else, we will rotate by increasing degrees by 1, or a different number if you would like this to be faster. Take my animation dot style dot transform, set this equal to, this string is going to be a little bit awkward. Let's rotate x, parentheses, we'll need to insert our degrees within quotes, plus degrees plus DEG. Okay, and that should be it. So this will rotate my element on the x-axis, and it does a full 360-degree turn. Okay, rotate on the y-axis. Pretty cool, right? Or z. Hey, just for fun, let's rotate this element and have it move diagonally across the screen. This will just be practice. Let x equal 0. Let y equal 0. We'll continue this as long as x is greater than or equal to 200, or y is greater than or equal to 200. Increment x by 1, increment y by 1. My animation dot style dot left equals x plus pixels. My animation dot style dot top equals y plus pixels. Okay, this should move diagonally and rotate. Okay, let's make the spin a little bit faster. I'll increase degrees by 2. Or 3. Or a higher number, like 5. Okay, last one. We can scale the size of an image. So let's get rid of what we have written currently. Okay, let's create 2 new variables. Let scale x equal 1. 1 means 100%. Let scale y equal 1 as well. Let's scale this image twice as big. Our condition to stop is if scale x is greater than or equal to 2. Else, scale x plus equals maybe 0.01. This would be 1%. Then we will take my animation dot style dot transform, set this equal to scale, then within parentheses, we'll need to insert scale x and scale y, plus scale x plus, comma, plus scale y plus. And that should be good. If we're only scaling x upwards, then this element will expand horizontally. If we stop where scale x is 3, it would expand to be 300% on the x-axis. Okay, let's do this with y. Scale y. Y plus equals 0.01. This element will expand on the y-axis. Then let's do both. If scale x is greater than or equal to 2, or scale y is greater than or equal to 2, then increase both scale x and scale y. Then this element will expand in both directions. Or we could shrink an element by scaling down. Scale x is less than or equal to, what about 0.1? Do the same thing with scale y. Less than or equal to 0.1. Then let's decrement scale x and scale y. This will cause an image to shrink. So yeah, those are a few simple animations you can do with JavaScript. If you would like the code that I've written here, I'll post this in the comments section down below. And well, yeah, those are a few simple animations with JavaScript. Hey guys, in this video we're going to draw some simple shapes using the Canvas API. It's a means for drawing graphics. It's useful for animations, games, and data visualization. Heading to our HTML document, we'll need to create a Canvas element. Canvas, close it. I'll give this an ID. My canvas. And we should probably set a width and a height. Width equals maybe 500. And height equals 500 as well. Let's save. There's no apparent change, but we do have a canvas here. To better visualize it, heading to our CSS file, make sure that you link it within your HTML file. We can begin styling the canvas. I will select my canvas. I'll add a border. Border, 1 pixel, solid, black. Yeah, and there's our canvas. You can also change the background color too. Background, color, and pick a color. Maybe sky blue. That's pretty nice. So this is our canvas. But just for demonstration purposes, I'm going to turn this line into a comment. We can begin drawing some shapes. Let's head to our JavaScript file. I'm going to store my canvas within a workable variable. Let canvas equal document.get element by ID. The ID is my canvas. To draw on the canvas, we need to get the context. And I will store that within another variable. Let context equal canvas.get context. And there's one argument, 2D. Imagine that context is a painting within a picture frame, and the canvas is the picture and the frame together. That's how I imagine it, at least. To draw on the canvas, we need to draw on the context, the painting itself, and not the frame. Let's begin with a simple line. I would like to draw on the context. To begin drawing a line, I will use the begin path method. Then we need starting coordinates. We'll begin in the top left corner. Type context dot move to, then pass in a pair of coordinates. The top left corner of our canvas is 0, 0. Think of the move to method as if we're placing our brush on the canvas. We're picking a starting position. To draw a line, we have to use the line to method. Context dot line to, then pass in another set of coordinates. So the bottom right corner over here would be 500, 500. Then we will follow this with the stroke method. Context dot stroke. There, and there's our line. Let's pick a different set of coordinates. What about right in the middle? So 250, 250. You can continue this line in a different direction. Just invoke the line to method again. I'll take this line from the middle of our canvas to the bottom now. I'll follow line 2 with another line 2 method. If I need to connect the line down here, I'll follow line 2 with 250, 500. There, so we have drawn 2 lines. I would like to draw a line from the top right corner to the middle. My brush is currently down here. I need to move this brush to the top right corner. I will invoke the move to method. And the top right corner of my canvas would have coordinates of 500, 0. Then again, invoke the line2 method. And the middle is 250, 250. Cool, we have drawn some lines. We can set a line width. Currently, the width is 1 pixel. Context.line width equals, what about 10? So we have some extra thick lines. You can also change the stroke color. Context.stroke style equals, and pick a color. This can be a color name, RGB values, or hexadecimal values. I'll say just purple. I like purple. We have some purple lines now. That's how to draw some lines on our canvas. Draw lines. This time we're going to create a triangle. To create a triangle, we have to use the line2 method. We'll type context.beginPath and end this with context.stroke. We'll need to place our brush somewhere, maybe the top middle. To place our brush down, we will use the move2 method. Context move 2. So the coordinates of the top middle would be 250, 0. Let's draw a line to the middle of the left border. Context line 2, that would be 0, 250. Let's draw another line. Line 2, maybe the opposite side. That would be 500, 250. And another line. Let's bring it back to the top. That is 250, 0. There, we have a triangle. There is a fill method to fill this triangle. In place of stroke, you can use fill. You can pick a fill color. Maybe you want more options than just black. So that would be context.fill style and pick a color. Maybe yellow. If you need a border, you can use the stroke method along with the fill method. There, we have a border around our triangle. We can increase the border width. Technically, that's the stroke width. Context.line width equals maybe 5. Let's change that to maybe 10. There, that's better. To change the color of the border, all you have to do is set the stroke style. Context.stroke style equals, currently it's black, maybe we can pick, I don't know, gray. There, we have a gray border. So that's how to draw a triangle. Next, we'll move to rectangles. To draw an empty rectangle, we will use the stroke rect method. Context.stroke rect. We'll need starting coordinates, maybe the top left corner, that is 0, 0, followed by a width and a height. So for the width, 250, and the height, 250 as well. There. We have a rectangle. To change the stroke style, we can set the stroke style property. Context.stroke style equals, let's pick, I don't know, red. There, so we have a red border. I think I'll change that to black, though. If you need a filled rectangle, use the fill rect method. So I'm going to copy this, paste it, and this would be fill rect. So this will fill our rectangle. If you need to change the fill color, we can set the fill style property. Context.fill style, and pick a color, maybe red again. There, we have a red rectangle with a black border. To change the border thickness, you just have to change the line width property. I'll keep that as it originally was. Okay, let's create another rectangle. So I'll copy this, paste it. I'll make the original one black. Let's place the second rectangle directly underneath the first. So the starting position would be 0, 250. And the stroke would be 0, 250 as well. There. Let's create another. This will be a green square. And the starting corner will be 250, 250. Same thing with the stroke. Okay, last one. Let's fill in this empty space. A blue square. And this will begin at this point. That is 250, 0 for the coordinates. So yeah, we have successfully drawn 4 squares. Okay, this time we're going to draw a circle. Context dot begin path, and we will end the section with context dot stroke. To draw a circle, we will use the arc method. Context dot arc, and there's a few arguments. Starting coordinates for the center of our circle. If I place the starting coordinates at 0, 0, the center of my circle will begin in the top left corner of my canvas. Then a radius. What about 100? For the next 2 arguments, we need a starting angle and ending angle in radians. For a full circle, that would be 0, 2. Then multiply 2 by math.pi. There. Well, it's a part of a circle, but the center is starting in the top left corner. I'll set the x and y coordinates to 100. There, that's much better. What about the middle? 250, 250. I'll increase the radius to maybe 200. The starting angle and ending angle are in radians, so you can change these for an incomplete circle. If you ever need to reverse these, pass in true for the last argument. This would probably be helpful to you if you have a pie chart to work on. Okay, let's fill this circle. Context dot fill. Let's change the color. That would be fill style. Context fill style. I'll set this to maybe light blue. Let's try and draw a bubble. And I'll give this a thicker stroke for the border. Context dot line width property equals maybe 10. I'll change the color as well. Context dot stroke style equals maybe dark blue. Sweet. So yeah, that's how to draw a circle. And for this last section, we'll draw some text. Draw text. To draw some text, you would type context dot fill text. What's some text we would like to add? Maybe you win. Then we need some coordinates. Let's begin at 0, 0. You can't really see it right now. It's above the top left corner. Let's bring it down a little bit. 100, 100. There. Although it's very small, let's change the font. Context dot font property equals, and pick a font. Maybe 50 pixels, and the font style will be, pick whatever you want, but I like MV Bully. That's better. We can change the fill style. That's the font color. Context dot fill style equals maybe gray. Now, if you need to center some text within a canvas, this is what you can do. We'll need to calculate half of our canvas's width. So as the second argument within the fill text method, type canvas.width divided by 2. Do the same thing with the height. Canvas.height divided by 2. We're almost there. We will need to set the text align property to center. Preceding our fill text method, context.text align equals center. And that's how to center some text. So yeah, everybody, those are a few simple shapes along with text that you can draw on a canvas. If you would like a copy of this code, I'll post this in the comment section down below. And well, yeah, that's an introduction to the Canvas API in JavaScript. Hey guys, in this video I'm going to explain the window object. It's an interface used to talk with the web browser. And actually, the DOM, the document object model, is a property of the window. Let's examine this window object. I will use console.dir and pass our window as an argument. Here's our window object. It has its own properties and methods, one of which is document, the document object model. By interacting with the properties and methods of our window, we can change the behavior of our web browser. Let's cover a few. I need the width and height of this inner window. To do that, I would type window.innerWidth and window.innerHeight. I'll place these within console.log to display it. Console.log. The inner width of this window is 383 pixels and the height is 263, but we could change these. Now the width is 488 and the height is 208. There's also outer width and outer height. So these are now respectively 871 and 984. Another is scroll X and scroll Y, but we'll need some scroll bars within our window. I'll create a very large div element. Div ID equals my div. I'll close it and add these properties: a width of 1000, a height of 1000, and a background color. So we have these scroll bars now within our window. I can get the scroll X and scroll Y properties to show how far that we have scrolled. Console.log window.scroll X and scroll Y. Scroll X is this value, 631, and scroll Y is this value, 758. If I were to place these back in their original positions, well then these values are both 0. That is scroll X and scroll Y. I'll get rid of this div element. We can change the href property of this window so that it redirects somewhere else. I'll display that. Console.log window. Now href is found within location. Window.location.href. The current href property has this address. It's basically my web address, but we could redirect it somewhere else. Window.location.href equals pick a website, maybe Google, https://google.com. This should redirect me to Google. Yeah. Hey, if you need the host name, that would be window.location.hostname. Here's my host name. It's just a local IP address, 127.0.0.1. If you need the path name, that would be window.location.path name. And my path name is /index.html. For me, this would be the landing page. Here's a few useful methods. We're going to create a button though. Button ID equals my button. Let's close it. I'll add some text. Just button's fine. I'm going to select this button. Constant my button equals document dot. I'll use query selector this time. Query selector. The ID was my button. And let's add some event listeners. When I click on this button, I would like to open a new window. I'll take my button, invoke the add event listener method. When we click, I will perform a function. I'll use an arrow function expression. And I will invoke the Windows open method. When we click on this button, it opens a new window. You could pass a URL within the open method. I'll place this address for Google as an argument. Then when I click on the button, it takes me to that website. Another is close. Window.close. This will close the current window. When I click on this button, it closes the window. Okay, another method is print. Window.print. And we can print the current page. So when I click this button, we initiate the process of printing this page. We do have a few pop-ups too. Window.alert. I'll just display the message, hello, hello. There's also window.confirm. We can have a user confirm something. Press OK to continue. Press OK to continue. Window.prompt is another. Window.prompt. Enter your age. Let's store this within a variable. Let age equal window.prompt. If age is less than 18, let's create an alert. Window.alert. You must be 18 plus to visit this site. Then we will close the window. Window.close. Okay, enter your age. Let's say that I'm 12. I press OK. You must be 18 plus to visit this site. Then it closes the window. Well, okay then everybody, that is the window object. It's an interface used to talk with the web browser. There's a lot of useful properties and methods related to the window object. If you would like a copy of all my code, I'll post all of this in the comment section down below. And well, yeah, that's an introduction to the window object using JavaScript. Hey guys, in this video I'm going to explain cookies. A cookie is a small text file that is stored on your computer. It's used to remember information about a user. Data within a cookie is saved in name-value pairs. In order to check to see if we have cookies enabled, within console.log I can type navigator.cookie enabled. For me, that's true, I have cookies enabled. To add a cookie, we would type document.cookie. We will set this equal to a string, but the string has certain components. First is a name-value pair. I would like to create a cookie to store a user's first name. The name of this pair will be, let's say, first name. Set this equal to some value. The value that I will pick is SpongeBob. Then end it with a semicolon. Now you can add an expiration date. When the current time is past a certain expiration date, well then this cookie will be deleted. To set an expiration date, set expires equal to, then pick a date. I'll pick Sunday, 1st January, maybe a date that's really far out, like 2030. At midnight, UTC, then semicolon. We're also able to set a path for this cookie. I'll use the default path, that would be path equals /. Okay, let's take a look at this cookie. Console.log document.cookie. Even though this appears to be a string, it's actually an object. The expiration date and the path aren't displayed. All that's displayed is the name and the value. You can add more than one cookie. So again, we will type document.cookie. Let's copy this text, paste it. Last name. Last name equals square pants. Then let's take a look at our cookie again. The cookie property of our document can hold more than one cookie, but to access it, you would just type cookie. To overwrite a cookie, you would just change the value of a name-value pair. If I overwrite the first name and the last name, they'll change. This time, let's set first name to Patrick, last name star. There we go, first name Patrick, last name star. If we change the expiration date to a date that has already passed, that will delete this cookie. It'll expire. So maybe the last name expired in the year 2000. That last name portion of my cookie is no longer there. So that's how to expire a cookie. At this point, we're going to create a function to create a cookie instead of doing so manually. Function set cookie. We'll need a few things. A name, because these are in name value pairs. A value, and an expiration date, although that's optional. For the third argument, let's name this parameter days to live. As an argument, you'll pass a number of days that you would like this cookie to be set to expire. 365 would be 1 year. Let's create a date object. Const date equals new date. I will set the time of this date. Date dot set time method. Within the parentheses, we will take date dot get time. This will return the current time in milliseconds, then add the amount of days to live converted to milliseconds. Days to live times 24 hours times 60 minutes times 60 seconds times 1000 for 1000 milliseconds. Our future date is currently in milliseconds. We'll convert that to UTC string. Date to UTC string method. I'll assign this to a variable. Let expires equals, and then we'll use some string concatenation. We'll need to set this expires value. So within quotes, expires equals plus our future date converted to a UTC string. Then we can assign our cookie. Document.cookie equals, I'll use a template literal. We're inserting our name that we pass in equals our value. Add a semicolon to finish this section. Then the expire section. expires. Then you could also add a path if you would like. Path equals /. That's the default path. Okay, now let's create some cookies. I will invoke our setCookie function, pass in a name value pair, and the amount of days I would like this cookie active. What about an email address? Email, make up some email address, sponge@gmail.com. I would like this cookie to live for 365 days. Then let's display our cookies. Console.log document.cookie. And here's our cookies. We still have our first name and last name because we never deleted them, but we do have an email now. Email equals sponge@gmail.com. How can we delete a cookie? All we have to do is set the expiration date to a past date. Here's one easy way to do that. Let's create function delete cookie. All we'll need is a name. What we'll do is invoke setCookie, pass our name as an argument, null for the value, and null for the days to live. If I was to invoke the delete cookie method and pass in the name email, well, that email cookie is no longer in here, so it's gone. Let's delete the other cookies too. Delete first name, delete last name. And those 3 cookies are cleared. Let's create a function to get the value of a cookie by a name. Let's declare this function get cookie. We'll accept a name as an argument. What we'll need to do is decode our cookie. I'll store this within a constant. Constant C for cookie decoded equals decode URI component, then pass in document.cookie. Let's take a look at this. Console.log C decoded. Let's make sure we have at least 2 cookies. Set cookie first name SpongeBob 365 days to live. Set cookie last name SquarePants. Then I will invoke the getCookie method. Then pass in a name. First name is fine. Okay, let's see what we have. This is what's stored within C decoded. We have our name value pairs. What we'll need to do is split each of these name value pairs at each of these semicolons. That's how to separate them. So after this first statement, we'll take C decoded and split at each semicolon space. This will return an array. We'll store that within const C array, cookie array. Let's display cookie array, console.log cookie array. Each of those name value pairs is now within separate elements. What we're going to do is for each element, we'll check to see if there's a match between each of these element names and the name that we're looking for. Let's take our cookie array, C array, and use the for each method. I'll use an arrow function expression. There is one parameter, element, arrow. What would we like to do for each element? I'll use an if statement. Let's check to see if our element at index of the name that we're looking for is equal to 0. Say that we're looking for last name. We'll iterate over each element of our array and see if there's a match. We check the first element. These don't match, but this one does. If there's a match, then let's return the result. Result equals, and we'll create a substring. Element.substring name.length plus 1. The length of the name plus 1. We'll create a substring and return this text. So let's declare let result at the end return result. Actually, I'm going to set result to null. Okay, let's see if this works. So we have 2 cookies, and I'm going to console.log get cookie, pass in my first name. And that first name is SpongeBob. Let's get last name. Last name, SpongeBob and SquarePants. Okay, yeah, that's how to set, delete, and get cookies. Let's take this a step further. Let's create some text fields, a submit button, and a get cookies button. Heading to our HTML file, let's create some text fields and some labels. Label for equals first text. First name, colon, close the label. Input ID equals first text. I'll add a line break. Let's do the same thing with last name. Last text. Last name. ID is last text. I'll create a submit button. Button ID equals submit. Now let's name this BTN for short. Submit button. Text will be submit. Then a get cookies button. Cookies, BTN for button. The text will be get cookies. Okay, heading back to our JavaScript file. Let's select these elements. Const first text equals document dot query selector. We're selecting the ID of first text. Let's do the same thing with last text. Our submit button. Submit button. Then cookie button. Cookie button. I'm going to add an event listener to our submit button. Submit button dot add event listener. The event attribute will be click. When we click, we're going to perform an arrow function expression. We will set the cookies according to what these values are within these text boxes. We will invoke the set cookie function. The name will be first name. The value will be whatever's within our text boxes. First text dot value and days to live. I'll set this to be a year. 365 days. Let's do the same thing with our last name. Set cookie last name. Last text dot value. Let's add an event listener to our cookie button that will populate the fields. That function will search for any cookies and return a value. Okay, we have cookie button, add event listener, click, first text dot value equals get cookie, then the name of the cookie, first name. Do the same thing with last text. Last text dot value get cookie, last name. Whoops, looks like I misspelled this ID. Cookie button. Now before we run this, I'm just going to delete our cookies. Delete cookie first name. Delete cookie last name. Then save and run it. So when I press get cookies, well, we don't have any first name or last name cookies. There's nothing to populate these text fields. So I'm going to type in a first name and a last name. SpongeBob. SquarePants. Press submit. This first name and last name are stored as cookies now. So I'm going to refresh this page, press that get cookies button again. That will populate these text fields with the cookies I have. So yeah, everybody, that's an introduction to cookies. They're small text files stored on your computer. They're used to remember information about the user, and they're saved in name-value pairs. If you would like a copy of all this code, I know there's a lot here. I'll post all of this in the comment section down below. And well, yeah, that's an introduction to cookies using JavaScript. Hey, what's going on, everybody? It's your bro, hope you're doing well, and in this video we're going to create an interactive stopwatch using JavaScript, so sit back, relax, and enjoy the show. Sup guys, let's create a stopwatch. Head to your HTML file, then we will create a container to hold our stopwatch. Div ID equals, I'll name this time container. Then we're gonna close it. Within our time container, let's add a div for the time display. ID equals time display. I'll add a time 00:00:00:00, hours, minutes, and seconds. Let's close that div section. We'll add 3 buttons: start, pause, and restart. Button ID equals start button. I'll put this within a class. Class equals timer button. Let's close the button, add some text. The text will be start. Let's copy this button, paste it 2 times. The second button is a pause button. The text will be pause. Next will be a reset button. Reset. The text is reset. That is everything for our HTML file. Let's head to our CSS file. Let's begin by adding some properties to the timer button class. I'll set a width of 80 pixels, a height of 30 pixels, a border, 3 pixels solid is good, a border radius of 12 pixels, a background color. Let's select a hexadecimal value. Pick whatever color you want. I'm going to pick a dark gray color. You can always use a color picker to select the color. I'll set the color to be white. I'll set the cursor to be a pointer. When we hover our cursor over that button, then we have a cursor pointer. Then I'll change the font family. Font family. I'll pick this font with the backup of monospace. Yeah, cool. Let's change the time display right here. This is an ID. Time display. I'll edit the font size. Font dash size. This will be 75 pixels. I'll select a color. Go ahead and pick a color. I'll select maybe that. That looks good. Sweet. I'll change the font family. Then let's add a background color and center everything. This will be our time container. Text align center. I'll add a border. 3 pixels solid. Border radius of 25 pixels. Background color of, this is a dark gray color, 6 2s. Yeah, there we go. So there's our CSS styling. Our CSS styling is done. Our HTML file is done. Let's head to our JavaScript file. Let's select all the elements that we'll need. First is the time display. Let's get that ID. Time display. I'll store this as a constant. Const time display equals document dot query selector. We're selecting an ID. The ID is time display. Next is our start button. Let's copy this, paste it. Start button. Start button. Then our pause button. Pause button. Pause button. Then reset button. Reset button. The ID is reset button. Here's the variables we'll need. Let start time. I'll go ahead and set this to 0 right away. Let elapsed time equals 0. Let current time equals 0. Let paused, this will be a Boolean variable. If our timer is currently paused, we'll set this to be true. False if it's running. Let interval ID, let hours, HRS is fine, equals 0. let mins for minutes equal 0. Let then sec for seconds equal 0. Here's what we're going to do. We're going to add event listeners to each of our buttons. Start, pause, and reset. Add event listener. I'll fill these in momentarily. Pause button, then reset button. Then we'll declare a function to update our time. Function update time. Let's fill in these event listeners. These will each be click. We'll use an arrow function expression. I'll just copy this and paste it. Okay, let's begin with our start button. We'll check to see if paused is true. If paused, we'll take paused, set it to false, calculate the start time. Start time equals date.now method. The now method of date will give you the current date and time in milliseconds, minus elapsed time, which will initially be 0 to begin with. Then we'll begin our timer. Interval ID equals set interval. We'll need a callback. The callback will be update time. Let's invoke this function every maybe 75 milliseconds. That should be good enough. Let's fill in the update time function. We'll calculate how much time has passed. Elapsed time equals whatever time it is right now, date.now method, minus the original start time. This will be a time in milliseconds. We'll have to format it so that we can display it within our timer. Let's take our seconds, set this equal to math.floor method. We will pass in our elapsed time divided by 1000 because it's normally in milliseconds, modulus 60. I'm going to put these within parentheses. It's a similar process for minutes, except this section is 1000 times 60. That will be 60,000 milliseconds in every minute. Let's calculate the hours. Hours, 1000 times 60 times 60. Then we'll need to update our display. That is time display dot text content equals, I'll use a template literal. We'll display the hours, colon, the minutes, then the seconds. Let's take a look to see what we have so far. We'll have one issue. Let's press start. You can see that it's currently running, but when we display zeros, I would like 2 zeros. Let's add a 0 as padding for any single digit numbers. I'll create an inner function. Function pad will accept a unit. We will return. This will be a ternary operator. It might be a little difficult to understand. So we're going to add a 0 to the front of our unit, whatever we pass in. Hours, minutes, and seconds. We'll access the length property. If we add a 0 to our unit, what's the length? Is that length greater than 2? Question mark. If it is, we'll simply return unit. Otherwise, we'll prepend a 0 plus unit. Then we'll invoke the pad function. Our seconds equals invoke pad, pass in our seconds. Do the same thing with minutes and hours. Minutes, hours. Then let's move this line down. Right about here. Okay, we should have some zeros as padding now. Yeah, there we go. 1, 2, 3. So we have no way to pause this timer. Let's work on that next. Let's head to our pause button. We'll check to see if not paused, then we will set paused equal to true. We'll calculate the elapsed time equals date.now minus our start time. This will save how much time has passed in milliseconds. Then clear our set interval method. Clear interval will pass our ID as an argument. Okay, now we should be able to start our timer. 1, 2, 3, and pause. And you can see that it's paused. Lastly, reset. And this one's kind of easy. Head to our reset button. We'll take paused, set that to true, clear our timer, take start, elapsed, and current time, set them all to 0, take hours, minutes, and seconds, set them to 0. Then lastly, change our time display to all zeros. Time display dot text content equals 00:00:00. Oh, then make sure you don't add this let keyword. Then we're creating a local variable. Okay, this should work now. 1, 2, 3. We can pause. We can reset. We can start again. And reset. All right, everybody, that is a simple timer. If you'd like to make a more advanced version, you could add milliseconds. And well, yeah, that's a basic stopwatch using JavaScript. Hey guys, in this video we're going to create a game of rock, paper, scissors using JavaScript, so sit back, relax, and enjoy the show. Alright then everybody, in this video we're going to be creating a game of rock, paper, scissors. We'll be using HTML elements, JavaScript code, and styling with CSS. Let's head to our HTML document. I'll create a div section to contain our game. Div ID equals, I'll name this game div. We'll close it. I'll create 3 labels, one for the player, the computer, and the result, who won. These will be h1 header tags. I'll give each of these header tags a class. Class equals game text. I'll give the first h1 header tag a unique ID of player text. The second header tag will be computer text. Third will be result text. The first h1 header tag will have this initial text. Player, :space, then computer, :space, result, :space. Let's add 3 buttons for rock, paper, scissors. Button, close it. Each of these buttons will have a class. Class equals choice button. We'll need 3 buttons. Add some text. Rock, paper, scissors. That's everything for now. Let's head to our JavaScript file. Let's select all of the elements that we'll need. We'll begin with the player text. Const player text equals document dot query selector. We are selecting an ID. That ID was player text. We'll select the computer text. Const computer text. The ID was computer text. We'll select the result text. Const result text. The ID was result text. Then we will select all of the buttons. Const choice buttons equals document dot query selector all. We are selecting the choice button class. We'll create 3 variables. Let player to store the player's choice. Let computer for the computer's random choice. Let result to display who won. We'll iterate over our choice buttons using the for each method. Choice buttons for each. We'll use an arrow function expression. For each button within our choice buttons array, we will use an arrow function. I'm going to add an event listener to each of these buttons within the arrow function expression. Button dot add event listener. The event is click. When we click on a button, we're going to do something. Within the add event listener, we'll add a second arrow function expression. There are no arguments. Arrow. Then we're going to do a bunch of stuff. So let's expand this. When we click on a button, what are we going to do? Let's take our player. This is our player's choice. Set this equal to whatever button we select and get the text content. If we click on this rock button, then our player variable contains this string, rock. Same thing goes with paper and scissors if we select those. Then we will invoke the computer's turn. Computer turn function. We'll need to declare this function. Outside of our for each method, let's declare this computer turn function. Function computer turn. We'll select a random number between 1 and 3. Const rand number equals math dot floor. We'll need a random number, math dot random method. There's only 3 choices. We'll multiply this by 3. Then add 1. This will give us a random number between 1 and 3. We can examine this random number with a switch. Switch rand number. We'll find any matching cases. Case 1, computer will equal the string rock. Then break. Case 2, computer equals paper. Case 3, computer equals scissors. And that's it for the computer turn function. The player variable will be assigned a string as well as the computer. Next, what we'll need to do is set the text with our choices. Player text dot text content equals, I'll use a template literal, player colon space, I'll add a placeholder, player. Let's do the same thing with computer. Computer text, text content, computer, computer. Then the result text. Result text dot text content. We will set this equal to invoke a check winner function. We'll need to define this function. Let's do that after the computer turn function. Function check winner. First, we'll compare if our player and computer strings are the same. If player is equal to computer, we will return a value. This will be a string. Draw, it's a tie. Else if computer is equal to rock, I'm going to return, then use the ternary operator. Our condition is if player is equal to paper, question mark. If the computer is equal to rock, is the player equal to paper? If so, then we will return a string. You win. If this condition is false, we'll return a different string. You lose. Okay, let's create another else if statement. Else if computer is equal to paper and the player is equal to scissors. Add another else if statement. Else if the computer is equal to scissors and the player is equal to rock. And that should be it. Let's test it. Okay, rock, it's a draw. Paper, you lose. Scissors, you win. All right, so that is the logic of our game. Hey, for fun, let's style this using CSS. Let's begin with our game div element. That surrounds our game. Let's take this ID. We will style game div. It's an ID. I'll set the font family to brush script MT. If my web browser can't display this font, I'll have a fallback of cursive. I'll add a border. Border 3 pixels solid. All around the corners. Border radius 25 pixels. That's better, but let's add some padding. Padding 10 pixels is good. I'll add a background color. Background dash color, maybe light gray. I'll align the text in the center. Text, align, center. Okay, we're getting somewhere. Let's select these buttons. They all have the same class. That class is choice button. I like to add classes at the top. Choice button class. Let's change the line height to 30 pixels. Then set a width, because all of these buttons have different widths to accommodate the text. I would like them all to be uniform. Width of 150 pixels is good. Let's expand this a little bit. There. Let's select our player text. ID, player text. I'll change the color of the text. Color, pick a color. I'll be blue. Let's do the same thing with computer text. ID, computer text. I think the computer should be red. Okay, let's try this one last time. Rock, paper, scissors. Well, all right, everybody. That is a basic game of rock, paper, scissors for beginners. If you would like a copy of my JavaScript code, as well as the HTML and the CSS markup, I'll post all of this in the comments section down below and pin it to the top. Be sure to check underneath the original video in the playlist. But yeah, that is a basic game of rock, paper, scissors using JavaScript. Hey, what's going on, everybody? It's your bro, hope you're doing well, and in this video we're going to create a game of tic-tac-toe using JavaScript. So sit back, relax, and enjoy the show. Well, alright everybody, let's create a game of tic-tac-toe. Let's create a div element to contain our game. Div. This will have an ID of, what about game container? Let's close it. I'll add a title. This will be an h1 header tag. The title will be tic-tac-toe. We'll create a div section for a grid. Div ID equals, let's name this cell container. It will contain 9 cells for each of the spaces. Then let's close it. Within our cell container div, we're going to create 9 div tags. Div. We'll create an attribute named cell index. I'll set the first equal to 0. Add them to a class. The class will be cell. Then close the div tag. Let's copy this div element and paste it 8 additional times. So we should have a total of 9. We have cell index 0, 1, 2, 3, 4, 5, 6, 7, 8. Outside of our cell container, that ends right here, it looks like. We'll create an h2 header tag to display some messages, like whose turn it is, who won. So let's close this h2 header tag. I will give this an ID of, what about status text? Then we'll need a button. Button. The ID will be restart button. Add some text. Restart. Okay, that should be everything within our HTML file. Let's head to our CSS style sheet. Be sure to save everything. Let's begin with the cell class. This is a class, so use dot, the name of the class, cell. I'll set a width of 75 pixels, a height of 75 pixels. I'll add a border. 2 pixels solid is good. Okay, here's our div elements so far, but we got to put them in a grid. They're all in a single column. I'll select our cell container. We're selecting this by an ID. Cell container. The display will be grid. Grid. Template. Columns. Repeat. 3. Auto. Then we got to set a width. Width, 225 pixels. Margin, auto. Yeah! Let's head back to our cell class. Let's add a box shadow. Box, shadow, 0, 0, 0, 2 pixels. All of these lines should have an even thickness. I'll add a line height of 75 pixels. Just to test the X's and O's, I'm going to add an X like right here and an O here. Let's edit the font. Font size 50 pixels. When I move my cursor over these cells, I would like my cursor to be a pointer to indicate that we can click on something. So cursor, pointer. Let's test that. Yeah, there's our pointer. Okay, let's select our game container. I'm going to center everything and change the font. Game container. I'll add a font family. I'll select permanent marker. I like that font. And a backup of cursive. Then we just got to center everything within this container. Text, align, center. Yeah, and that's our CSS style sheet. So let's get rid of this X and O that we have. I was just writing that there to test it. Okay, so our HTML file is done. Our CSS file is done. Let's head to our JavaScript file. Okay, now we're within our JavaScript file. Let's declare all of the variables that we'll need. Const cells equals document dot query selector all. We're selecting a class, the cell class, dot cell. Then let's select status text, const status text, document dot query selector, not query selector all. We are selecting status text. Then our restart button, const restart button, ID restart button. We need a constant of all of our win conditions. Const win conditions. Win conditions will be a two-dimensional array of indices. If 3 cells all have the same character, we would need to check that, but we'll have to know what cells to check. Let's begin with the first row. These would have indices of 0, 1, 2. So let's add that. 0, 1, 2. Then the second row. 3, 4, 5. 6, 7, 8. Then columns. 0, 3, 6. One, 4, 7. 2, 5, 8. Then the diagonals. 0, 4, 8. 2, 4, 6. And that's it. We'll need an array of placeholders. I'll name this options. Let options equals. Options will be originally an array of empty strings. We'll need 9 of them. 1 for each cell. Okay, let's make sure we have 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. We'll need to keep track of the current player. Let current player equal X. Then we'll need a Boolean variable to keep track if our game is running. Let running equals false. We'll switch this to true when we initialize our game. Let's create all of the different functions that we'll need. Function initialize game. Function cell clicked. Function update cell. There will be 2 parameters, cell as well as index. Function change player. Function check winner. Function restart game. Okay, and that's the functions. When we begin our game, let's initialize the game. We'll use this function initialize game to take care of any setup before we need to start. We'll have to add some event listeners to our cells. Take our cells, then use the for each method. We'll use an arrow function expression. For each cell, we will take our cell, add event listener. The event will be click. We will add a callback of cell clicked. The second line, we'll add an event listener to our restart button. Restart button dot add event listener. When we click, we are going to invoke the restart game function. For the third line, let's update our status text. Status text dot text content. Set this equal to, I'll use a template literal, current player, it's their turn. Okay, it looks like we have one problem. Looks like I accidentally capitalized that L in current player. Okay, let's work on the cell clicked function. When we click on a cell, what are we going to do? I'll create a local variable, const cell index. I will set this equal to this. This refers to whatever cell that we click on. We will get an attribute, get attribute. The attribute that we're getting is cell index. We have an index number. What we would like to check to see is if that index number within our options, our placeholders, are not empty. We'll only want to update a cell if there's nothing there. If our options at index of cell index does not equal an empty space, or if the game is not running, then we will return, not do anything. Otherwise, we will invoke the update cell function, pass in this as an argument, as well as cell index, followed by check winner function. Okay, let's head to the update cell function. Take options at index of the index parameter. Set this equal to the current player. So we're updating our placeholders. Then change the text content of one of these cells, whatever cell that we click on originally. Cell.text content equals current player. Now we should be able to click on at least one of these cells. Oh, I forgot one thing. When we initialize our game, we have to set running to true. Running equals true. There. So we can click on one of these spaces. X, 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 X. Then we just need to change the player. Take our current player. Then we will set this equal to, then use the ternary operator. Our condition is if change player is equal to X. If current player is equal to X, we will reassign our current player with O. Otherwise, X. Then take status text dot text content, set this equal to, I'll use a template literal, current player, it's their turn. Yeah, just temporarily I'm going to invoke this function after updating a cell. Now we should be able to alternate between X's and O's. X, O, X, O, X, O. Yeah, we're good. I'm going to remove this. I was just testing it to make sure it works. Okay, then head to our check winner function. We have a lot to do here. We'll create a temporary variable of round1. I will set this equal to false. If somebody wins, we'll flip this to be true. We'll use a for loop. We haven't used those for a while. We will iterate over all of the win conditions within our two-dimensional array. The first statement will be let I equal 0. We'll continue this as long as I is less than our win conditions dot length property, increment I by 1. We will iterate over each inner array within win conditions, but let's store each of these arrays within a temporary variable. Const condition equals win condition at our current index of I. Each row has 3 indices. Const cell A equals our options, but at what index? Well, the index is going to be our condition at index 0. Then we have cell B, condition at 1, cell C, condition index of 2. Let me explain how this is going to work. Let's head to the top. We're iterating over all of these inner arrays. We'll begin with the first. We have 3 indices, 0, 1, 2. We're going to check within our options at these 3 indices, 0, 1, 2, at least that row to begin with. If these 3 are not spaces and they're all the same, that means somebody won. If there is no winner, we'll check the next set of win conditions, 3, 4, and 5. These are indices. Within our option at these 3 indices, 3, 4, and 5, if there are no spaces and they're all the same character, that means somebody won. We'll repeat this process for each set of win conditions. So heading back down to our check winner function, we'll need to check if there's any empty spaces. If cell A is equal to an empty space, or cell B is equal to an empty space, or cell C is equal to an empty space. If there's an empty space, we'll continue and skip this iteration. So if there are no empty spaces, that means all the spaces are full. Let's make sure they're all the same character. If cell A is equal to cell B, and cell B is equal to cell C, that means we have a winner. We'll take our local variable of round1, set this equal to true. Then break. We don't need to continue this for loop anymore. We can break out of it. Outside of our for loop, if round1 is equal to true, Let's update our status text right here. Status text dot text content is equal to, I'll use a template literal, current player wins. Running equals false. The game is over. Else if. So if there's no spaces left, it's a draw. We could check that with this condition. Take our options, then use the includes method. We'll check for any spaces. Does our array include any spaces? Precede this with the not logical operator. If our options does not include any spaces. If this is true, then we will update our status text to equal draw. Running equals false. Else, we can change player. Change player. Okay, let's try this. XO, XO, XO. We should have a winner here. Yeah, X wins. Let's work on this restart button to restart the game. We'll take current player, set this equal to X. Take our options. I'll just copy this. We're going to reset them. So they're all empty spaces. Status text dot text content equals, I'll use a template literal, current players turn. We'll have to clear each cell. Take our cells, use the for each method, use an arrow function expression. For each cell, we will take that cell, update the text content equal to an empty space. Then set running equal to true. Okay, let me make sure the game's a draw first. Okay, draw. I'm going to restart, and we have a new game. So yeah, everybody, that is a basic game of tic-tac-toe. If you would like a copy of all this code, I'll post this in the comment section down below, underneath the original video in this playlist. And well, yeah, that's a basic game of tic-tac-toe using JavaScript. Hey, what's going on, everybody? It's your bro, hope you're doing well, and in this video we're going to create a game of Snake using JavaScript, so sit back, relax, and enjoy the show. Hey, what is up, everybody? In this video we're going to create a game of Snake. Let's head to our HTML file. I'll create a div as a container. Div ID equals game container. Let's close it. We'll be using a canvas to draw our components. Canvas, the ID will be game board. I'm going to go ahead and set the width and the height attributes right away. 500 for the width. The height will be 500 as well. Then close the canvas. I'll add a score. Div ID equals score. Let's close the div section. The initial score will be set to 0. Then we'll need a reset button. Button, close it. ID equals reset button. The text is reset. Okay, let's work on our CSS styling. That's everything for our HTML file. Let's select our game board. Game board. This is an ID. I'll add a border. Border 3 pixels solid is good. Let's center everything within our game container. Game container, text, align, center. I'll change the font of the score. You can barely see it. Score, font, family. Pick whatever font you like. One font that I like is permanent marker. Permanent marker. Then a backup of cursive. Let's change the font size 100 pixels. Then let's work on our button next. Reset button. I'll pick the same font family. The font size will be 22 pixels. a width of 100 pixels, a height of 50 pixels, border 4 pixels solid, border radius to round the corners 15 pixels, then cursor pointer when we hover our cursor over this button. Okay, that is our CSS style sheet and our index.html file. Let's head to our JavaScript file. We have a lot of variables to declare. Let's begin with the constants. Const gameboard equals document dot query selector. We are selecting an ID. That ID is gameboard. That's our canvas. With a canvas, to paint on the canvas, we have to get the context. Const ctx for context equals gameboard dot get context, then pass in 2D. We'll store our score text as a variable. Const score text equals document dot query selector. We're selecting an ID. The ID is score. Let's change this ID to score text. We're already going to have a score variable. Hey, this is Future Bro. So I forgot to change that within my CSS style sheet. Make sure you make that change here as well. Let's select our reset button. Const reset button equals document dot query selector. We are selecting our reset button. I'm going to create a variable to hold the width of our game board. Const game width equals gameboard.width, then game height. Const game height equals gameboard.height. Width and height are the attributes that we assigned within our canvas. Initially, when we run this JavaScript file, if we would have declared those within the CSS file, they wouldn't have been available to us right away. That's why I assigned these attributes within the element itself in line. We're going to assign some colors. The first is for the board background. Const board background equals pick a color. I'll just pick white. Pick a color for your snake. Const snake color. I'll pick light green. But feel free to pick a different color. I'll add a black border around the snake. Snake border equals black. Then we'll need some color for the food. Const food color equals red. It's an apple. Okay, then a unit size. What's the size of everything within our game? Const unit size equals, I'll pick 25 pixels. Now we'll create a couple more variables. Let running equal false. We'll examine running to see if our game is currently running or not. Let x velocity. X velocity will be how far we move on the x-axis every single game tick. I will set this to be the unit size. We'll be moving 25 pixels on the x-axis every game tick. If x velocity is a positive number, we'll move to the right. If it's negative, we'll move to the left. Then we have y velocity. Let y velocity equals 0. That means we're not moving up or down. If we would like to move down, we would set this to unit size. If we would like to move up, we would set that to negative unit size to move up or down one space, 1 unit. But to begin, we'll just be moving to the right. We'll need the coordinates of our food. Let food x coordinate. Let food y. We'll calculate these randomly later within a function. Let score equals 0. Then we need our snake. Our snake is going to be an array of objects, an array of parts. Let snake equal straight brackets, it's an array, and we will create objects, an object for each body part. Each body part will have an x and a y coordinate. Let's begin with the tail. The tail will begin in the top left corner. So I will set those coordinates. 0, 0 is the top left corner. Initially, let's create 5 body parts to the snake, but after it eats its food, it's going to increase by 1. Let's add a second body part. This is a separate object, separated with a comma, but I don't want this in the same space. I'll place this next body part to the right of the first one. So let's say x is unit size times 1, or just unit size, I suppose. Okay, let's add another body part. Unit size times 2. So we'll have 3 squares. Okay, 2 more body parts. Unit size times 3. Unit size times 4. And that's our snake. It's an array of objects, body parts. Each object is a body part of the snake. They each have their own x and y coordinates. Let's add an event listener to our window to listen for key events. Window.add event listener. The event is key down. We'll pass in a callback to a change direction function. Then we'll add an event listener to our reset button to restart the game. Reset button dot add event listener. When we click, we will invoke the reset game function, which we still need to declare. Then we will invoke game start. Let's declare the functions that we'll need. Let's begin with the first. Function game start. Function next tick. Function clear board. Clear board is going to be in charge of repainting the board. Function create food. The create food function will find a random place within our game board to place a food item. Function draw food. We'll need to paint the food within our game board. Function move snake. Function draw snake. Function change direction. Function check game over. Function display game over. Then lastly, function reset game. Those are the functions. Let's begin with the create food function. We'll create an inner function. Function random food. There will be 2 parameters, min, then max. Within this function, we'll return a random number. Return rand number. So to calculate this number, we'll store this within const rand num. Set this equal to math.round math.random. We will multiply this by max minus min, plus the minimum if there is one. I think I'm going to expand this. All right, just to demonstrate this, I'm going to invoke the random food function and store this within food x. Food x equals random food. We'll pass the minimum, 0, then the max, game width minus our unit size. Temporarily, I'm just going to display whatever food x is. I have to explain something. Then we will invoke this create food function temporarily. I gotta explain something. Currently, when we're generating a random number, that random number is between 0, then our game width minus our unit size. Every time I run this, I have a random number between that range. However, I would like to divide the width and the height of my game into spaces. I will take this part of this expression divided by unit size. Now we'll receive a random space between 0 and 24 because 500 divided by 25, our unit size, is 25 available spaces. To accurately place the food in the top left corner of one of these spaces, I will multiply all of this by unit size. So every time I refresh this, you can see that all of these numbers are divisible by 25. And that's what we're looking for. Let's create food y. Food y equals the same thing. Okay, that is our create food function. Let's move on to the draw food function. This is fairly easy. We'll take our context, set the fill style equal to our food color. Take our context, fill rect to fill a rectangle. We need a pair of coordinates. Food x, food y. We need a width and a height. They are both going to be unit size. Now, if I were to invoke the draw food function after the create food function, this will draw a random food item every time we refresh the page. And that's what we're looking for. That completes the create food function and the draw food function. I'm going to eliminate these two function calls. We're going to fill in the game start function. We will set running equal to true. Our game is currently running. We'll update the score text content to equal whatever our score is. Initially, it's going to be 0. We'll invoke the create food function, then the draw food function. Then lastly, next tick. Next tick is what we want to do every round, every time we update the clock. Okay, every time I refresh this, an apple should appear randomly within your game board. Let's close the game start function. We'll work on the next tick function. We'll check to see if our game is currently running. If running, let's invoke the set timeout method. Set timeout, we'll use an arrow function expression. There's a lot we have to do. We'll list an order of steps. First, we'll clear the board. Clear board function, followed by draw food, move snake, draw snake, check game over, then invoke next tick again. So after the right curly brace, how often do we want a game tick to occur? Maybe 75 milliseconds, that's a good speed. If you would like a slower speed, you can increase the number or decrease the number for a faster speed. I'll just pick 75. Then we'll add an else statement. Else display game over. If our game currently isn't running, that means the game's over. So that is the next tick function. Let's work on clear board. This is fairly simple. We'll take our context, set the fill style. We'll take our fill style, set this equal to board background. This is a color that we picked. Take our context, fill rect. We'll begin in the top left corner, 0, 0. We'll end in the bottom right corner. We will take our game width for the width, game height for the height. And that's it for this function. Let's work on draw snake. We'll need to change the fill style. Context dot fill style equals snake color. For my snake, I picked green. If you have a border, we can set the stroke style. Context dot stroke style equals snake border. We'll take our snake. It's an array of objects, so there is a for each method. I'll use an arrow function expression. The argument is snake part. For every snake part, then within curly braces, I will take our context, fill rectangle, snake part. Each snake part has an X coordinate and a Y coordinate. So we'll begin painting wherever that snake part currently is, on the X axis and the Y axis. What's the width and the height of the snake part? Well, our unit size, 25 pixels. And the height is 25 as well, unit size. Hey, if you have a border, we can fill that in. Let's copy this, paste it. Stroke rect. Looks like I misspelled something. Clear board fill rect, not rext. Okay, and that will draw our snake. So now how do we move our snake? Let's go to the move snake function. To move the snake, we're going to create a new head of the snake in the direction that we're moving, then eliminate the tail. Const head equals, then within curly braces, the x coordinate will be our snake's current head. So that has an index of 0. Take the x coordinate of that plus our x velocity. How far are we moving on the x-axis? This will be a positive number if we're going right, a negative number if we're going left. Okay, then do the same thing with y. Y equals snake at index of 0 dot y plus the y velocity. Then to add this new head to our snake, we can use the unshift method. Snake dot unshift head. Okay, so our snake is just expanding. Now we need to eliminate the tail after each move. I'll use an if-else statement. If else will be snake.pop. That will eliminate the tail every time that we move. But I gotta fill in something for now. I'm just going to set this to be false. Just temporarily. Okay, our snake should move now. Within this if statement, we'll check to see if the food was eaten. If food is eaten. So that's a comment. If the head of our snake at index 0, take the x coordinate, we will use the comparison operator. Is the x coordinate of our snake equal to the x coordinate of our food? Food x. And let's copy this portion. The y coordinate of the head of the snake is equal to food y. If the head of the snake and the food are overlapping, well then the snake has eaten the apple. Let's increment the player's score by 1. Score plus equals 1. Change the score text dot text content equals the new score. Then create a new food object. Create food. We have no way to test this until we can control our snake. Let's close out of this function. Then go to the change direction function. The change direction function should have one parameter, event. We invoke this function every time we press a key. Our window is currently looking for the key down event. We'll store this within const key pressed. Set this equal to event dot key code. So I'm going to display whatever key pressed is currently with console.log. I'm going to click on my window and press up, down, left, right. Each of those 4 arrow keys has a key number. That's what we're looking for. In fact, I'm going to store those. Let's say const left equals 37. Const right equals 39. Const up equals 38. Const down equals 40. Actually, I'm going to rearrange these so that they're all in numeric order. Much better. This is how to determine which way our snake is headed. I'll store these within some constants. Const going up equals, we'll write a condition, is the y velocity of our snake equal to negative unit size. So our unit size is currently 25. If the y velocity of the snake is negative 25, that means we're moving up. So let's do the same with the other directions. Going up, going down, going right, going left. Going down is going to be y velocity is equal to unit size, positive. Then x velocity is equal to positive unit size. Going left is x velocity is equal to negative unit size. So these will be Boolean variables. I'm going to write a switch. Switch will examine true against many matching cases. The first case will be key pressed is equal to left. And we are not going right. We don't want to be able to move like to the left, then immediately to the right, because according to the rules of Snake, if any body parts touch, then we lose the game. We don't want to accidentally go back into any body parts. So if we're going left, we can continue to go left, otherwise up or down, but not right, because then we lose the game. If we would like to go left, then let's set the x velocity equal to negative unit size. Take our y velocity, set that equal to 0. We're no longer going up or down. Then break. Let's add another case. Key pressed equals up, and we are not going down. X velocity equals 0. Y velocity equals negative unit size. We need another case. Key pressed equals right, and we are not going left. X velocity equals unit size. Y velocity equals 0. Okay, last one. Key pressed equals down, and we are not going up. X velocity equals 0. Y velocity equals unit size. Okay, we should be able to control our snake now. Yeah, there we go. We can go up, left, down, right. So let's eat the apple and we should expand. And our score increases. Now let's work on getting a game over, because we can go off the screen currently, which we should not be able to do. Okay, let's close out of this function. Check game over. If we pass one of these borders, then we have a game over. I'll write a switch to check that. Switch will examine true against many matching cases. The first case will be, is the head of our snake, snake at index 0, take the x coordinate, is that less than 0? That means we went over the left border. If this case evaluates to be true, well, we have a matching case. So let's take running, set this equal to false. Then break. So if I go over the left border, the game stops running. Okay, let's add another case. If the x coordinate of the head of our snake is greater than or equal to the game width. Now if we go over the right border, the game ends. Take the y coordinate of the head of our snake, check to see if it's less than 0. That means we go over the top. Game's over. Then the last one is case y is greater than or equal to game height. We shouldn't be able to go over the bottom border. Yeah, awesome. There is another game over condition too, if any body parts of the snake overlap. To check that, I'm going to use a for loop to iterate over the body parts. For, then our index is going to be I. We don't want to begin at the head. Let I equal 1. That's why I'm not using the for each method. Our condition to continue is I is less than snake dot length property. Increment I by 1. We'll write an if statement. If our snake at index of I, that's going to be one of the body parts besides the head, because we're starting at 1. If the x coordinate of that body part is equal to snake at index of 0, take that x coordinate, and let's copy this, paste it, change x to y. If the head of our snake is equal to one of the body parts, that means the game's over. Running equals false. Okay, let's test that. Yeah, the game just ended. Now we'll want to display game over. Let's close out of the check game over function, then head to display game over. I'll take the context, access the font, set this equal to a font of your choosing. I'll pick 50 pixels, MV Bully, context.fill style. Pick a color, I'll just pick black. I'll center the text, context, text align equals center. To draw some text on a canvas, we'll type context dot fill text, add a string of text, game over, then your placement. I'll put this right in the middle. Game width divided by 2, comma, game height divided by 2. Then set running equal to false. Okay, so when we hit a border, it's game over. Then when the head of our snake runs into a body part, it's also game over. The last thing we need to do is set up the reset game function. We'll take our score, set that back to 0, take the x velocity, set that equal to unit size, take our y velocity, set that equal to 0. We'll recreate our snake, copy that, paste it, but we're not going to use the let keyword, then invoke the game start function. So after we get game over, we should be able to reset our game. Yeah, sweet. Well, okay then everybody, that is a game of Snake using JavaScript. If you would like a copy of all this code, I'll post this in the comments section down below. Be sure to check the original playlist. And well, yeah, that's how to create a game of Snake using JavaScript. Hey, what's going on everybody? It's your bro, hope you're doing well. And in this video, we're going to create a game of Pong using JavaScript. So sit back, relax, and enjoy the show. All right, let's begin everybody. Let's create a div section to contain our game. Div, close it. The ID will be game container. We'll add a canvas. Canvas, close it. The ID will be game board. I'll set a width and a height in line. The width will be 500. The height will be 500. We'll add a score. This will be another div section. ID equals score text. The initial text will be 0:0. Then a reset button. Button, close it. The ID is reset button. The text is reset. Cool, that's our HTML file. Let's head to our CSS style sheet. ID, game board, border, 3 pixels solid. Let's change our score text next. Score text. Pick a font family. Font family. Pick a font that you like. Then I'll add a backup. I'll change the font size to 100 pixels. That should be readable. Okay, let's work on the button. Reset button. I'll set a font of permanent marker. Then a backup of cursive. Font size 22 pixels. A width of 100 pixels. A height of 50 pixels. Border 4 pixels solid. Border radius 15 pixels. Then cursor pointer. When we hover our cursor over this button, the cursor is now a pointer. Then let's center everything. I will select our game container. Text, align, center. All right, there we go. So that's our CSS style sheet and our HTML file. Let's head to our JavaScript file. Let's declare all the constants first. Const game board equals document dot query selector. We are selecting our game board. Const context equals game board dot get context 2D. Context is what we draw on. Const score text equals document dot query selector. We are selecting the score text. I'm just going to copy this. Then we have our reset button. ID is reset button. Let's store the game width within a variable. What's the size of our canvas? Const game width equals game board dot width attribute. Then we have height. Game height equals game board dot height. I'm only storing them within a variable so that they're accessible. Let's select some colors. Const board background. What color? I'll select forest green, kind of like it's a tennis court. Const paddle 1 color. What color would you like the first player to be? I'll pick light blue. Then paddle 2. Paddle 2 color. Player 2 will be red. If you want, you can add a border. Const paddle border equals black. Const ball color. I'll make this yellow like it's a tennis ball. Const ball border color. I'll pick black. So what do we want the size of the ball to be? I'll store that as a constant. Const ball radius. I'll set this to be 12.5. Then the full diameter is 25. Then our paddle speed. How far do we want our paddles to move when we press down on a button? Paddle speed equals 50. That's good enough. Feel free to change this number if you'd like. Now we have let interval ID. Let ball speed. I'll set this to be 1. That will be the lowest speed. Then ball X and ball Y, they will be coordinates. Let ball X equal. Initially, I'll place the ball right in the center of our game board. I will take game width divided by 2. Then ball Y is going to be game height divided by 2. Let ball X direction. I'll set that to be 0. Ball X direction will be the direction in which the ball is headed on the X-axis. Then ball Y direction. Let player 1 score equal 0. Let player 2 score equal 0. We'll define two paddle objects. Let paddle 1 equal, this paddle will have a width property of 25. A height of 100. These are in pixels. The starting X coordinate will be 0, all the way at the left border. Then Y, 0. So this paddle will be in the top left corner initially. So let's copy this, paste it, change paddle 1 to paddle 2. The width and the height will be the same. I would like paddle 2 to be on the other side of my canvas. I will set X to equal game width. Then I'm going to subtract negative 25, whatever the width is. If I set X to be game width, the left border is going to be lined up with the right border of my game board. So I'm just going to shift it over by the width, 25 pixels, so that you can actually see it. Then Y is game height minus the height of our paddle. And those are the two paddles. Let's add an event listener to the window to listen for key down events. Window.add event listener. We will listen for key down. Then we will invoke a change direction function. Let's add an event listener to our reset button. Reset button dot add event listener. We are waiting for click, then invoke the reset game function. We'll still need to declare these two functions. When we would like to start our game, we'll invoke the game start function. Then we'll need to declare these functions. The first function is function game start. We'll fill these in momentarily. Function next tick. Function clear board. Function draw paddles. Function create ball. Function move ball. function draw ball, function check collision, function change direction, function update score, function reset game. Okay, those are all the functions. Why don't we begin by drawing the paddles? We'll start with the easy stuff. So we will take our context, set the stroke style equal to the paddle border. Let's begin by drawing paddle 1. Context dot fill style equals paddle 1 color. Context fill rectangle. The first two arguments are the x and the y coordinate of the top left corner of the rectangle. That will be paddle1.x, then paddle1.y. The next two arguments are the width and the height of this rectangle. The width will be paddle1.width, then paddle1.height. To test this, I'm going to invoke draw paddles right after game start temporarily. Okay, there's our first paddle, but let's add a border. We can just copy this, paste it, change fill rect to stroke rect. Okay, there is our first paddle. Let's copy these 3 lines of code, paste it, change paddle 1 to paddle 2. And there's our second paddle. I'll eliminate this function call. Let's fill in game start. When we begin the game, what are we going to do? First, we'll create a ball, then invoke the next tick function. Let's fill in the next tick function. We will take our set interval ID, set this equal to set timeout method. We'll pass in a callback. Then we'll add a routine. What are all the things that we're gonna do? First, we will clear and redraw our board. Clear board, then draw paddles, move ball, draw ball. Draw ball is going to have 2 arguments, ball X, ball Y. And we should probably fill that in within the parameters. There. Then we will check collision. Then invoke next tick for another round. I would like to repeat this routine every 10 milliseconds. That is the next tick function. Let's fill in the clear board function. All we're doing is redrawing our board. Let's take our context, set the fill style equal to the board background. Context.fill rect will begin in the top left corner, 0, 0. The width will be game width. The height will be game height. And that's our background. So that is the clear board function. We're redrawing our canvas. Let's head to the change direction function. This will be in charge of moving the paddles, but we'll need to know what key that we pressed. I'll store that as a constant. Key pressed equals our event dot key code. So we do have one parameter, that's event. So fill that in. Let's display whatever key pressed is. Console.log key pressed. W has a key code of 87, S is 83. The up arrow key is 38, the down arrow key is 40. So we can use that for something. Const paddle 1 up equals 87. Const paddle 1 down equals 83. Const paddle 2 up is 38. Const paddle 2 down is 40. Let's write a switch to look at key pressed. Switch, we're examining key pressed against many matching cases. The first case is paddle 1 up. If we press up, we will take paddle 1, access the Y property, minus equals our paddle speed. You could also think of paddle speed as paddle distance, how far we're going to move, then break. So we should be able to move up, but we can't move down. Paddle 1 down, the y property of paddle 1 plus equals paddle speed. By pressing S, we can move down. By pressing W, we can move up. But currently, we're exiting the game board. Let's write an if statement to check that. If paddle 1 dot y is greater than 0, then we will move. Then within the second case, paddle 1 down, we'll write another if statement. If the y property of paddle 1 is greater than game height. Okay, now check this out. So we can't go above the border, but we can go below the border, up to a certain point. From game height, we need to subtract the height of our paddle. Game height minus paddle 1 access the height property. We cannot go above the game board or below. Okay, let's work on paddle 2. Case paddle 2 up. We'll check to see if paddle 2's y property is greater than 0. Then we will take the y property of paddle 2 minus equals the paddle speed. So we cannot move paddle 2 above the game board. Then our last case is paddle 2 down. Okay, let's copy what we have here within paddle 1 down. Paste it, but change paddle 1 to paddle 2. The y property of paddle 2 plus equals the paddle speed. With paddle 2, we shouldn't be able to go below or above the game board. These paddles are complete. Let's close out of the change direction function. Let's work on the draw ball function. We'll take the context, set the fill style equal to the ball color. Context dot stroke style equals ball border color. We can set a line width if we'd like. Context dot line width equals to context begin path, context arc to draw a circle, ball X, ball Y, then the radius, ball radius, 0, this is for radians, 2 times math.pi, context.stroke method, context.fill method. And there's our ball. Okay, that is the draw ball function. Let's head to the create ball function. When we create a new ball, let's set the ball speed equal to 1. Let's begin with the x-axis. If math.round math.random is equal to 1. This part of the condition will give us a random number between 0 and 1. If that number is 1, let's move to the right. If not, let's move to the left. So if we would like to move to the right, let's set ball x direction equal to 1. Else, ball x direction equals -1. We're moving to the left. Okay, let's copy these if-else statements. Then change ball x to ball y. Then when we create a new ball, we'll set it to be right in the middle. Set the ball x coordinate equal to game width divided by 2. Set the ball y coordinate to game height divided by 2. Then invoke the draw ball function. Pass in as arguments ball x, ball y. That's the create ball function. Then we need to move the ball. Ball x plus equals the ball's speed times the ball's direction, ball x direction. Then do the same thing with y. Ball y plus equals ball speed times ball y direction. So our ball should move in a random direction. Let's just test that by refreshing the page. So let's close out of the move ball function. Now we'll need to check collisions. Let's check to see if we hit the top border. If so, then we'll bounce off of it. If ball y is greater than or equal to 0 plus the ball radius. Remember, the center of the ball is where we place the x and y coordinates. So that's why we're adding the ball radius to account for that. If we touch the top border, let's change the y direction. Ball y direction times equals -1. That will reverse the direction. I'm just going to test that. So we should bounce off the top. Yeah. Let's check to see if we hit the bottom border. If ball y is greater than or equal to game height minus ball radius, then we will change direction. Okay, let's check that. Yep, we just bounced off the bottom. What if we touch the left border? If ball x is less than or equal to 0, let's update player 2 score. Player 2 score plus equals 1. We'll update the score. Create a new ball. Then return. Once we hit the left border, that should create a new ball. Yep, there it is. Okay, let's copy this if statement. If ball x is greater than or equal to game width, then we will update player 1 score. When we hit the right border, that creates a new ball. Okay, now this is the tough part. We're going to bounce off the paddles. I'm going to maximize the screen. If ball x is less than or equal to, this is for paddle 1. Paddle 1, take the x property, plus paddle 1, access the width property, plus the ball radius on the x-axis. If so, let's check the y-axis. If ball y is greater than paddle 1, take the y property, and ball y is less than paddle 1 dot y plus paddle 1 dot height. That means there's a collision. We'll take ball x direction, multiply this by -1. Hey, if you want for fun, you can increase the ball speed. Ball speed plus equals 1. Okay, we should be able to bounce off this paddle. Yeah, there we go. Okay, let's do the same thing with the right paddle. So I'm going to copy this section, paste it, is greater than or equal to the x property of paddle 2 minus the ball radius. If ball y is greater than the y property of paddle 2 and ball y is greater than the y property of paddle 2 plus paddle 2's height. So we should be able to bounce off these paddles now. Then the ball speeds up. So we do have one situation where the ball might get stuck. Kind of like this. If that happens, I'm just going to push the ball out of the way and move it forward. Ball x equals paddle 1, take the x property, plus paddle 1 dot width plus ball radius. This is if ball gets stuck. This line of code helps prevent the ball from getting stuck within the paddle. This statement will be ball x equals paddle 2 dot x minus the ball radius. Okay, now let's update the score. Update score. This one's easy. Score text dot text content equals, I'll use a template literal, player 1 score colon player 2 score. So we should be able to keep track of the score. Okay, that's 1. and 1. Lastly, we have the reset button. Reset game. Player 1 score equals 0. Player 2 score equals 0. Let's reset these paddles. I'll just copy them, paste them, get rid of the let keyword. By setting the x and the y coordinates, that will put them in their original positions. To demonstrate, I'll press reset, and they go back to their respective corners. Ball x equals 0. Ball y equals 0. Ball x direction equals 0. Ball y direction equals 0. We'll update the score. We'll invoke the clear interval method, pass in our interval ID, then invoke game start again. Okay, we should be able to restart this game. Yeah, there we go. Well, okay then everybody, that is a game of Pong using JavaScript. If you would like a copy of this code, I'll post this in the comments section down below. Be sure to check the original playlist. And well, yeah, that's a game of Pong using JavaScript.